mean, honestly, one of my favorite things to do is just smear things. So it is off by one, but it's an amortized one. So you manage to like ruin the day of every single person out there. Just everybody. People that think, oh, it's off by one this way, it's off by one that way, they're all wrong. People that think, oh, it's clock skew, still wrong. Just, it completely ruins everybody's day. Mm-hmm. Back in ninth grade, my algebra teacher actually managed to convince the entire class that you could do 2 plus 2 equals 5 if you managed to use limits in order to like get a sufficiently large value of 2. He had the entire class just absolutely losing it. Yeah. So my favorite answer to that is to figure out in the group of people where they kind of skew philosophically, and then pick the answer that's going to piss the most of them off, which is incidentally how I also choose software licenses. Hmm. But I mean, if you took a license under WTF PL and then AGPL and then GPL version 2, like, come on, it's just right there. Nobody's done it. So speaking of licenses and of course all the other things, let's get started with the talk. Since nobody's actually saying it's my turn to talk, but the timer is telling me it is. So, welcome. My name is Hazel Wakely. I have thoughts, lots of thoughts. They never stop thinking and they never stop thinking. Today we're going to be talking about source available is thriving, but open source is dying. So this is somewhat of a kind of emotional and or controversial type of topic. It's been discussed by many people in the community for decades. It's been something that's been rehashed in some form or another for over 60 years. This is not going to be the end-all perfect answer for everything. This is going to be one perspective, my perspective, and that is a limited one, but hopefully a useful one. And so some of the context of that perspective is useful to know. I am the first fellow of the Nivenly Foundation, and one of the missions that we have of the Nivenly Foundation is to figure out how to help projects, communities, ecosystems, programmers sort of take this evolution of you have this thing that you're working on, and then it goes from being a project into being this sort of kind of community thing. And then it goes from being this community into being this ecosystem. And it turns out that when you do these types of different evolutions, it's not a gradual change, it's a giant cliff of all these extra things you need to worry about, all these things that nobody told you about, all these different concerns, people emailing you at 3 in the morning asking you to fill out a 40-page questionnaire so that they can use your software in places they can't even tell you about? What? Nobody warns you about that. And so we're trying to figure out how to help people do that if they want to. Or if they don't want to, how to opt out of that. Because you kind of can't sometimes. But then another thing that I do is I'm also a director on the board of the Haskell Foundation. And so I'm kind of on the other side of things, trying to take this already existing ecosystem and steward it and help it become legible to different companies, help it have the resources that it needs in order to do all the things that it wants to do. And so I'm kind of engaging and circling around this question of open source is in a kind of a hard spot right now. But the source available thing seems to kind of be working. It certainly has a lot more attention. And what are we going to do about that? Is that where the industry is going? Is that how software collaboration is going? So that's kind of the context of where I'm at, and the things that I know and the things that I keep in mind, and that'll color and change sort of everything that I talk about, but hopefully not in a way that ruins the point of it, because it's an exploration of a many-faceted thing. So this is sort of a general statement. We'll break it down, but given the current conditions of today, this is kind of the punchline. Many of the problems encountered by open source participants right now seem to be most aptly handled by quote-unquote controlling interests that have this laundry list of things. They have become legible to corporations, and we'll go over what that means. They work on developing legibility towards nation states, which sounds scary and kind of is, but also isn't. They are developing resilience towards value capture by agents exercising soft and hard power, and have somehow managed to, in doing all of this, remain culturally palpable to open source communities. If a project, if a whatever you want to call it, has all these attributes, you seem to be doing pretty good. Okay, but like before we get into all that, that was a bunch of like really complicated words with very specific meanings. So let's dig into some of this. Okay, first off, we have all these different terms that we use, and people have a whole lot of opinions on things. What are we talking about when we say things? And so caveat, I am briefly summarizing decades of opinions from people who are known to hold those opinions strongly, not weakly. I am weakly, but yeah. So free/libera software. Again, brief summary. Kind of the fundamental thing that makes this thing tick is it has 4 freedoms. The 4 freedoms are, the execution, the distribution, these types of things that we're available and aware of that tend to be associated with copyleft software licenses. Importantly, in the movement around this, kind of the fundamental thing that they really used to distinguish themselves from other movements was that software development and the licensing of it, that it was a social and ethical issue. You did not use this license because you felt like it. You developed software in this way because you were ethically and socially compelled to. And that was a different distinction from basically anything else. It also psychologically turns out the 4 different things that you have there turn out to be roughly the bare minimum set of things and conditions that a group of humans needs in order to effectively learn. Humans are unique in the animal kingdom in that we think we're special, but we're actually kind of not. But the other thing that is actually somewhat genuinely unique is we use tools. We use tools, we develop and work together, but the way we do that is we use something, someone mimics that. Someone takes that mimicry and then kind of changes something, and then that change is then shared, and as that kind of stews in this soup of communal action, communal sharing, communal collaboration, humans literally evolve our understanding of the world through this process. And that happens to be pretty much exactly what the 4 freedoms guarantee you, more or less not an ounce more, not an ounce less. So that's kind of cool. But that's sort of an aside. So then we have the open source definition from OSI, which tends to be the one that most nation states recognize as a legal definition. You have these 10 different freedoms that are really required license terms in order for it to be a software license. They are pretty much the 4 freedoms plus or minus a couple other things. And the plus or minus is where a lot of the philosophical and sort of heated debates and discussions come from. Neither one is necessarily better or worse than the other, but they're different. This was intended, as far as I understand, to really focus on software as a public and common good. Specifically, there was actually an intentional choice made here to be pragmatic rather than idealistic. That was the perspective that they took, and that was how they enunciated and explained it, of why we do an open source license of, say, MIT license versus the GPL, because it's pragmatic, because it's interesting to corporations, because it allows us this type of influence that we can then use to get the goal that we want of open source software development being the best way to do software development in general. Is that the perfect answer? It's complicated. But that was the reasoning. And so that's important because it's different than the ethical thing, right? Like they're same kind of goal, but different way of shaping it, different way of thinking about it. And then you have source available, which is kind of a new thing, which more or less is you can see the code. And that's it, that's the definition. And everything else, we're just kind of figuring that out. Different corporations, different projects, different venture capitalists, things are source available, whatever that means. You have HashiCorp, it's source available with a certain license. You have some other stuff like Redis, source available, different license than HashiCorp. What are the terms? How do they go about it? It's kind of the Wild West. People don't really even know. They're still figuring it out. There will be new versions of source available. It's just its own thing. And that's okay. And then you have some newer stuff that's coming out. As an example of people still chewing on the problem, still figuring out different ways to think about it. So you have ethical source, which is different in that it's not just a license. So this one is, it's a license, but it's, you notice how the community is structured, how the governance is structured, what type of things that the work is for, what are you prioritizing. It's an interesting way to approach the problem rather than just saying tech is tech, and this technical problem is a technical problem. You go, maybe humans are doing the work. Maybe humans need to work together. And how do you encodify that in representing legally or not legally, like in the structure of the actual project itself? Like, is that workable? Can you do that? I mean, you can write anything down on a piece of paper, but like, sure. So taking a step back from all these different ways of approaching a problem. When we talked about it earlier, we had this source available is thriving, open source is dying. What is dying necessarily? Like, well, what's the crisis people keep talking about? So you have these different sort of things kind of coming in the landscape of today that shape what is happening. And we'll get into it because it's not necessarily a black and white thing. It's not necessarily a clear-cut thing. And because it also depends on how you view yourself in the ecosystem, how you view your relationship. There's a lot going into it. But we have, in general, the things that people bring up, the things that people have in the mind share collectively. This is important. This is the crisis. So you have a funding crisis. All the money just up and disappeared, except for like 1 or 2 areas. It just seems to be gone. You have the political turmoil. And I'll stop there. And then you have the mounting pressure of regulation, security, SBOMs, supply chains. You have all these different things. Maintainers being asked new and increasingly clever and baroque different demands on their time, different demands on their energy, different demands on their why. And then you have increasingly sophisticated attacks on the community, whether they're intentional or not, but it turns out that probably something like the SCU Utils attack is not necessarily an anomaly, but perhaps a foreshadowing of what could become semi-common, which could be terrifying if you're not ready for that. So we have, of these, kind of the pressures of, if you want to address this, as an open source community or as an open source project, you're going to need some type of capital or some type of power in order to actually be able to act. But the funding crisis just happened, and political turmoil just happened. Your main sources of funding and power just kind of disappeared. And if you have things like an attack or pressure, and you need to be able to withstand that or cooperate with people, but all the people disappeared, lots of people got laid off, different governance structures, communication is breaking down. How do you deal with it? So the funding, the politics, all the things that open source needs to sort of survive these shapes of conditions, at all the same time, seem to have gone really, really hard to get. And so, but you might just sit there and go, hey, I'm just a hobby programmer. I write some code, I have my dot files, I have this badass Vim configuration that I've been carrying around since high school, and it's open source MIT license, and I don't care what you do with it. China wants to download it, that's fine. I've had people say that, China wants to take over my project, I don't care. It's got 1 star on GitHub. Okay. But we're also trying to attempt to answer the question of how does collaboration work at scale? And we don't understand that, then that can change the very nature and fabric of how do we as developers work? How do we learn? How do we share? What does our software look like? Can you imagine a world in which Linux doesn't work? It's not a thing, in which your IDEs are $3,000, your compilers are proprietary and locked down, and you have to get a license and a training course. You need to pay for everything per CPU. That was a thing. Do you want that again? Do you want an even worse thing? Imagine drinking a verification can to hit compile. What? Maybe that might happen. That's weird. So so this does kind of matter. But how do we even get here in the first place? Why are we even sitting here talking about the fabric of reality and the fabric of communication and ecosystems and everything? Well, if we have this organizing and understanding your decision making, if you have this interaction points between collectives, if you have all these large groups working together or not working together, it turns out that on the internet, people are actually pretty nice to each other. Even the most toxic and evil people on the internet are, roughly speaking, pretty nice to each other compared to a lot of the stuff we get up to in the real world. And the real world is no longer sticking in the real world, and it seems hell-bent and determined to get into the not real world, to get into the digital world, and continue with doing whatever it's doing there. And as those two continue to mesh and interlap, all the concerns of different types of economics, different types of economies, different governance structures, different ways of influence and power, and all these things that don't have anything to do with the code you're writing, now have everything to do with the code you're publishing and consuming and producing. You can no longer avoid this. You really just can't. So it seems that maybe if open source doesn't become sustainable, it will remain exploitable. And that is pretty uncomfortable to think about. But also, caveat. If open source, whatever we mean by that, does not, quote, become. I mean, there's plenty of projects that figured it out 25 years ago. Like, did become? Okay, sustainable. What does sustainability even mean for a whatever we're calling open source? Is it is my hobby project sustainable? Is the Linux kernel sustainable? What does sustainability even mean? If I give you $1 million and nothing happens, is that sustainable? If I give you all the developer time in the world but no money to do anything with it, is that sustainable? Like, okay, and then so remain. Remain exploitable? What do you mean remain? Is it already exploitable? What about the stuff I haven't even written yet? What about, well, exploitable? What is this exploit thing anyway? Like, exploits are only exploits if they come from the threat model region of I care about that. Otherwise, they're just sparkling code paths. Maybe, so caveat. But to kind of dig into a lot of these issues that we talked about earlier, I do want to paint the picture that it's dire, because the situation is dire, but it's not hopeless. So if we're talking about situation, let's paint a picture in more detail of what it is, and then we'll go over together how things might be evolving to try and present solutions to these or present some stuff. So digging a bit more into the funding crisis. One of the things that I noticed when I was on the board of the Haskell Foundation was we went through a period of having enough money to survive. We didn't necessarily need to worry about that. And then all of a sudden, we were out. And it wasn't just that we were out so quickly that we didn't even have time to think about it. Of the 10 to 15 different sponsors, not a single one renewed. Just all at once, it was a cliff. It wasn't like a tape, it was a cliff. And then we reached out to every other open source community out there that we knew, every other foundation, and every single one of them had the same problem. But there's a couple foundations out there that said, oh, we're fine, not because they had sponsors, but because they had some savings. They had a 2 or 3 year runway, not the 6-month runway that we had. And then you had the Linux Foundation is fine. They're fine. Cool. Good for you. Everybody else in the world, all at the same time, had that problem. And it was so sudden that we realized, the funding solution used to just kind of exist and wait for companies to go out of their way to find you and throw money in your face over and over until you figure out how to catch it. And then all of a sudden that stopped working. And we realized we had to spend, 10, 15 years not understanding how to explain the value of software to anybody who's actually using it. Like the Haskell Foundation, for example, is in charge of things like the main package repository for all of Haskell, for things like overseeing the development of the compiler and overseeing the development and the funding of every open source tooling that everybody just depends on. Like if all of that evaporated, development on Haskell would freeze in time. Everything would just immediately start falling over. So obviously, for the hundreds of millions of dollars worth of value that's being generated by the ecosystem, it's critical. But you can't just walk up to a company and say, hey, I know we've never asked you for anything, and then in the 25 years we've existed, but all this, can you send us 6 figures worth of money for no reason? What? You can't just do that out of nowhere. But we spent the whole time period of Haskell, and everybody else did, just going, well, the value is obvious, isn't it? And I mean, it is, but also. And it turns out that value is also just not monetary. It's a whole bunch of other things. So you have all these open source software developers who are employed by companies to do nothing but just mess around, have fun, and do open source development. And then all those got laid off. At the same time as the funding dried up. And you're like, well, at least we have this compiler developer. Oh, no, that team got, well, can anybody hire them? Oh, nobody wants to hire them to do that. They just want to hire them to make money for the company. oh, does anybody want to hire anybody to actually make the ecosystem function so that you can continue to do your job? No, it's a tragedy of the commons. Someone else can do it. You're just playing chicken with the whole ecosystem. You're just going, someone else can pay for it, not me. Because it worked for 15 years. It worked for 20 years. It worked for 30 years. And all of a sudden it stopped. Well, okay. So is it a funding crisis? Or is it a bad business model? Because there's a whole lot of people out there who will talk about the funding crisis of open source, who will talk about and say, oh, this is a bad problem. This is like a huge burden. And I'm like, I hear you. With the context of the Haskell Foundation, you know, I'm like, I hear you. I empathize. What's your perspective on this? And they're like, oh, we're a startup and we have no plan, but we just put every single thing we ever developed in the internet with an MIT license, and nobody's buying it. And I'm like, okay, is that a crisis? But yeah, obviously and I'm like, you just suck at business, man. Like, what? So there's this conflict of different perspectives. Is it a funding ecosystem? Is it a funding crisis? Is it bad business model? Is it, well, how do you make money with open source anyway? Nobody knows that. Absolutely nobody knows how to make money with open source. You have people that call themselves open source and make money. And no one can really replicate that particular model because they have one type of context, one sort of situation, one sort of business model, and it is instantly tied to open source. And almost very rarely is it more directly tied to open source than 2 layers of indirection. So that's not replicable. It's cool. You can have like one of those companies, maybe 2. Nobody else needs like the same shape of that. So we don't really have a good business model. And we have this, people talking past each other constantly because of this issue of you just don't have a way to translate between a capitalist economy and a very not capitalist economy of goodwill and the gift kind of economy, or the post-scarcity sort of shapes of economic value. Like if I do open source, my work is valuable if everybody knows about it, and everybody uses it, and everybody relies on it and innovates what then contributes back. I don't need to worry about money. Like I don't care. But then people like, I need to eat, so I need to translate that value somewhere else, somehow. And that value transfer is super, super tricky. Nobody really knows how to do it. But a whole lot of people will talk past each other using the same words and get mad that each other are not understanding this. So that's tricky. So you have people saying, oh, if it weren't for all these freeloaders, we could get somewhere. We could make money. Look at all the value captured by open source. If everybody paid their fair share of $20,000 a year for this thing, we'd have trillions. And I'm like, what? Like, can you imagine if Linux cost $20,000 a year for anybody to download? Nobody would use it. No, people would use Windows. Like, can you imagine what? So freeloaders make the world go round. And freeloaders create the tragedy in the commons. And both are true. And it depends on which economy you're talking about. In one structure of economy, freeloaders are bad because they're taking a resource and they're not contributing back to it. They're acting not in good faith to the social contract. But on the flip side, if you have an ecosystem and you have this community, like a community library, well, the freeloader is someone that's sitting there reading the books, but they're sharing ideas and they're contributing to the atmosphere and they're generating all these cool ideas, and then they sit there and have a conversation with someone and they say, oh, I have a book, I can do that. And they were a freeloader for a year and a half, and then all of a sudden they provide value. Are they a freeloader? Like this, you can't think of freeloaders in ecosystems and communities the same way as you do in like a store or a marketplace. But they use the same word. They talk about the same problem with the opposite results and opposite. It gets tricky. Then, of course, you have the political turmoil issue. So this is really an issue in a lot of different ways, but I'm going to avoid touching a lot of it. There's hard power, and there is soft power. And that is an inescapable fact of how Western-style societies are built, and how large governance structures influence and wield this influence on itself and on other people. So the hard power would be any action. I make an action, I force you to make an action. The soft power would be influence. I have an idea, I share the idea. Well, in one type of economy, that's how it works. But in another type of economy, maybe the hard power is I can fork your code. Is that hard power? I'm not forcing you to do anything when I fork it. That's influence. But it's an action. But so things are tricky. But when you have these nation-state actors, when you have these large actors working in the real world, doing this hard power, soft power thing, and all of a sudden they realize, oh, I can make things happen in the real world. By screwing over something over here in the not-real world, that comes in. You can't escape it. It's already happening. It's been happening. It's going to continue to happen. Which means that we also need to think about consumption and production. If I consume something, if I produce something, how that is influenced in the flow of exchange of ideas and resources in the entire world, if someone interrupts that, or if someone influences and redirects that, that's going to change the world's economy. Maybe in a bad way, maybe in a way that someone wanted it to, maybe in a way that they wanted it to, but you didn't, and you couldn't do anything about it. But maybe they just ruined their whole life because they could. So that is uncomfortable. But we can't really escape it. Or maybe we can, right? Is it my problem? I don't do anything. I just write hobby software for myself. I have a home lab. Nobody cares about it. I put all my Linux ISOs on Plex, and I watch them. Right? It's fine. Well, to put frankly, with the advent of a lot of various technologies around the world, a lot of the various economic situations that the world is in, and a lot of the various political situations that the world is now in, the entire world is about to make it your problem, and they're not necessarily asking for permission to do so. But it is, they're only making it your problem if you're participating in open source in a way that works. So like if you say, I'm put this code out here, and I'm not doing anything with it, and if you take over, I don't care. Or if you say, oh, but I released this and I put this in its dependency somewhere. Well, do you care or do you not care? That the world's going to make it your problem, but you can choose what to do about it. But it is going to be your problem now. You really can't ignore it. You really just can't ignore it. And we've spent the last several decades pretending you can ignore it. Pretending you don't have to worry about where money comes from, what happens with the software that you write. Oh, I just, write some, remote control device software for a weird company that nobody's ever heard of, military. But I don't have to worry about that. For 20 years, we've lied to ourselves about that. For 30 years, we've lied to ourselves about that. Now, what we need to do, perhaps, is if corporations and other types of actors are determined to exercise hard and soft power and capital on you, with you, using you, with or without your say-so, you're probably going to need to think really hard about how you can create the conditions of success so that whatever result you want out of this, whatever result you want out of this idea of collaboration of software is something that works for you. It doesn't have to be what everybody else wants. You might just say, I'm going to walk away. but you're going to have to make that choice. So what do you do about that? It turns out there is a dirty secret, which is that most open source problems aren't uniquely open source problems. Tech has a bit of an exceptionalism thing where they like to think that they have the problems that nobody else in the world has ever had. And open source likes to think that they have problems that nobody else has ever had. That no other issue could ever possibly be solved with the same type of thinking and saying, well, it turns out that most of the types of problems that open source runs into, you can find ways to address it by looking elsewhere for inspiration. So let's look at some different types of strategies, some inspiration, some sort of smorgasbord of topics that we can use to go, okay, so we have a whole bunch of things that are going to be made my problem, and I kind of want to know what to do about it. So remember when I talked earlier about legibility, I used this word, it was a scary word with very specific meanings, and we didn't really talk about it. So legibility. Legibility is the idea that when a government wants to examine how it's doing something, when a government structure wants to understand how it's working, it can sort of look inside of itself, think and reflect and examine that and understand it. So you can think about legibility as like, can you write something on the whiteboard? And can you read it? Well, if I'm 5 feet away, I can read it. It's pretty easy. I just write it and I read it. If I'm 10 feet away, I need to make sure that I write it clearly. I need to make sure that I write it large. Who will have to do that? But what if I decide I want to scale myself outside of a classroom? And I want to scale myself to a whole school? How do I read everything on every whiteboard of a school? Can't do that. So none of the stuff on the whiteboard is legible to you anymore. But if you were to create a process or a policy or a set of ways to continue to read all the things on the whiteboard, maybe you want to, maybe you don't. But that is that kind of legibility, and you just scale that up from 1 school to 10 schools to the whole nation, to maybe the whole world. That's what governments do. That's how they write policy. That's what they're doing it for. Corporations, it turns out, do the same thing. But they're also, when they're doing this legibility, both governments and corporations, even though they're doing it in slightly different ways, they're really concerned about doing what's best for everybody involved in the name of protecting their own interest, for sure. But it's not one-sided. It can be and should be and often is mutually beneficial. Like if you have an agreement with a company for them to use your stuff, they don't want you to just disappear and wither away because they're using your stuff. They have a vested interest in you. You have a vested interest in them. And that is mutual. So how can you take your software project or your software community or your software something and create this mutual benefit to where all these big scary problems, governments, corporations, everybody else goes, oh, this is expensive and you can't afford it. And if you can't afford it, you go away. And if you go away, that's really bad for me. I'm going to step in and do my part because I consume some of this. And I have this agreement with you to make use of the shared resource. How do you do that? That's legibility. When you make that support feel obvious, when you make it feel part of this contract, rather than it being a social contract where you pinky swear, you make it legible. You turn it into something that's not a pinky swear. It can be something as simple as rate limiting the downloads of everything to a really small amount, way more than any individual developer would ever need. But all the corporations are going to have to figure out a way to not take all your bandwidth. They can pay for it. Wow. Cool. The open source community historically has gotten pretty mad about that. But what if they didn't? You can do the legibility in that way too. You can explain why this needs to happen. Okay, that's cool. So we have governance. We talked about governance. So governance, this is one of those things of, it can be tricky because there's a lot of emotions in it. but no one's really sitting there saying, there's emotions in this. So, for example, when you have certain types of open source software, and they want to release this type of service, or this type of thing that you can run, an infrastructure or a utility or something like that. You really want, idealistically, if people get a lot of value out of it, they should contribute back to it. And if that effect is super, super, super outsized, then something should happen. So, an individual developer writing something, releasing it, doing their own, home server, that's cool. A giant cloud provider getting billions of dollars of values out of your thing, refusing to contribute back, forcing a fork to happen, ruining your project and running a dark PR campaign to run the valuation of your company into the ground because that was cheaper. That's not cool. But how do you address that in a way that's not going to be more harmful than letting the harmful thing happen? Like, how do you actually think about that? There's also this other type of governance where you can try and take your project and take your community or take your ecosystem and make it more resilient to certain types of corporate influence, or certain types of government influence, or certain types of what we call capture. What happens if you have a software company that says, we do this, but we're going to do this and utilize this open source software. And we're going to be such active contributors into this software, we're going to get all of our employees on all of the governance of the board and the steering committee and the feature thing, and we can prioritize all of our feature requests. And that's pretty cool. Oh, there's this major, project that they use. Well, we have enough resources, we can do that all the way down. And we can do that all the way down. And the Linux kernel has a couple drivers that the whole thing relies on to make everything work. I guess we can buy the company that built those too. We can just keep going. Now we own the whole stack vertically. And we can prioritize all of our stuff. And I'm sorry, we don't have the bandwidth to do stuff that a competitor wants us to do. But also the community wants it. You can set up your governance to make that not an issue. No one does it, but you could. Maybe you should. You can also experiment with it. Governance is one of those areas that programmers have been extremely reluctant to understand as a thing. Almost pathologically, honestly. And so go wild with it. Do you have particular values in your governance structure? You can try embedding those. SQLite has famously done that quite well. Have you ever read the terms and conditions, the COC of SQLite project? It's wild. Good for them on taking their values and putting it exactly where they want those values to be. Nobody else seems to do that, but they have achieved a lot of success because of it. Interesting. You can also take the rules of engagement and put that in your governance structure. If a corporation or if a government or if anybody wants to engage with your project in a certain way, if part of your project or other employees or anybody wants to participate, how do you want them to participate? How do you want the collaboration to happen? Do you want it to be for ethical good? Do you want it to be no assholes allowed? Do you want it to be benevolent? You can actually take the rules of engagement and embed them in your governance structure rather than just saying, we're going to promise that everybody thinks exactly the same way and everybody solves all these problems in exactly the same manner. We're just going to pretend that that's going to happen, and then we'll get really, really mad about it, and then complain about it, and have a whole lot of fights about it for years afterwards if it doesn't happen that way. You also have policy. So what if something important enough gets large enough that it turns out you might actually need governance oversight for necessary support? To be really specific, what if you have the supply chain issue? What if XZ utils becomes a commonplace occurrence? And you start getting dozens, if not thousands, of emails from everybody saying, Oh, you have to do this, you have to do that, you have to do this. You're in the critical supply chain of all these other stuff. Like, did you know that your stuff is powering things that turn on all these things we can't even tell you about? Sounds like a you problem, buddy. You can't just say that. Can't just say that. I mean, you could. But they're going to be mad about it anyway, and they're going to do something about it anyway. But if you have the policy written in a way that you say, via policy, sounds like a you problem. But you know, via policy. Ooh, maybe the government says, as part of our continuity, as part of operating a functioning government that does not get taken over by other governments, our stuff should be secure and we're going to foot the bill. Because they should do that. Or a major financial institution, or a major critical company, or a major, like the power grid. What if they go, oh, you know, people can like really mess up everything if they just want to spend 5 years getting buddy-buddy with like the 5 people that keep everything running. Okay, you know what? We're going to put the bill for that. We can use policy to take the entire industry, to make that a standard, to make that a requirement, to make that part of the rules of engagement for them. Telcos have been doing this for decades. Hardware is really, really expensive. You want to know how they do it? Everybody builds a whole bunch of hardware. They take all their stuff, they slam it together, and they go, who won? All right, that one won, that company won, cool, you get to patent that, and everybody else is going to do a patent ring around that. We're going to copy that software, and that's the standard. They just do that. Because iterating and forking, you know, switches, or forking like actual hardware, that's a pain in the ass, you don't want to do that. But you can do this bake-off thing, you can have everybody say, hey, let's figure out this. Y'all fight about it, and then we collaborate when someone wins. That's a policy thing via patent, via whatever. We could think about what it means to have healthy competition, healthy collaboration in a way that doesn't involve ceaseless infighting to the point of destruction of the things we care about. What have we thought about that? What if we, you know, you might say, oh, this is a government problem. This is a giant big thing problem. What can I do? Well, you have your own dependencies, don't you? You might say, well, as the policy of this project, we're not going to use dependencies from maybe these areas. We're not going to use dependencies from maybe these ecosystems. We just don't run this entire programming language because we don't like it. Or maybe there's another reason. But if you write that down and you say this is a policy, you can do that. You can curate your dependencies. You can curate your time. You can curate your energy. You can curate a whole lot of things that most people get hit with later after the fact, that they get drained with later after the fact because they never thought to sit down and take the boundaries of their own personal life and say, I want my own space. Now you're going to have to do that, but you can, and you should. Speaking of your own personal life, here's one that I don't really see a lot of people thinking about. Are you a cook or a chef? They both make food. One of them can do it however they want to because they're just cooking for themselves. Maybe they're cooking for their partner, maybe they're cooking for their family. Doesn't matter. If you want to use week-old milk, have at it. You want to use weird ingredients, you want to put pineapple on your pizza, nobody's mad at you. You can do whatever you want. You want to wash your hands, you want to not wash your hands, please wash your hands. But no one's firing you from cooking your own dinner. What if you're a chef? Being a chef is an extraordinarily different skill than cooking food. You can be really bad at cooking food and be a really, really good chef. You can be really, really good at cooking food and you can be a really bad chef. Kind of like how you can be a really good programmer and be really, really bad at running open source projects. Or you can be really, really good at running open source projects and not actually even necessarily care a whole lot about the code. And if you force those to always be the same people, you're going to miss a lot of potential. But also, if you just always assume that it's the same people, if you just go, oh yeah, I like to cook, and then someone says, you're a chef now. You have to follow all these regulations. You have to follow all this and that. I'm taking your food and I'm feeding it to the president. What? I didn't sign up for that. You're going to have to ask yourself what you signed up for now. And it kind of sucks that you have to ask yourself what you signed up for. But you are already doing that, just never explicitly. When you use a very permissive license, you are kind of signing yourself up for someone taking your food whenever they wanted to and then feeding it to someone really important. And then that can cause issues for you. So maybe you're going to want a license that says, hey, I'm just a cook. Maybe you're going to want to think, oh, this is a product and it's never going to be a product. It's never going to be a community. It's never going to be an ecosystem. And in fact, this product self-destructs if it gets 100 stars on GitHub. Screw you, don't like my stuff. Why not? What's your identity? What's your relationship with the stuff that you write? What's your relationship with the communities that you share with? What's your relationship with the friends that you have? What's your relationship with the communal learning? How do you engage with that? You're not just smashing your face on a keyboard. You are yourself, and that's awesome. But because you're yourself, you have to think about what that means for everybody who interacts with you, and the you interacting with everybody else. What are the problems you want to think about? Do you say, hey, you know what? I don't really care about international politics. If you want to sanction me, you can't. Like, and if that's a problem, like, what? You need to think about that. And if those problems that you want to solve, if those types of issues that you want to encounter, if what you aim for your project or your community or your ecosystem is incompatible with the types of problems that you're willing to solve, you got to fix that incompatibility. You can't just get yourself into a really, really sticky situation and then go, oh, but I don't want to deal with the consequences of making really hard choices now. I'm like, you did sign up for that when you purposefully signed up for that and you hit the giant button saying, I signed up for that. No one really said before what the giant button fully entailed, and now we're kind of figuring out the hard way what that fully entails. But now that we have to be aware of that, you don't have to hit the button. You really don't have to hit the, I could be emailed by the government at any time button. It's optional. It really is. Maybe you don't want to hit it. It's fine. Your code doesn't have to do anything important. If you wanted to do something important, if you wanted to be impactful, you're going to have to hit the button. But at least you know it going into it. But you're going to have to know that now. So the situation isn't hopeless. It's just kind of dire. It's going to require you sitting down and thinking, well, I thought I was just someone that took a keyboard and hit it and made code. But it turns out I'm also a human that interacts with other humans in this weird, messy world that we call humanity. And I can't just hide behind a keyboard and a screen and pretend that the world doesn't exist. As long as you're okay with that, it's only dire. Thank you very much. Any questions? See if this works. So I did not turn this on. Yep. Testing. Yeah.
Hopefully that's, oh, okay, there I can hear myself now. It seems like there's this incentive in the beginning for a lot of profit-making companies, startups, that build themselves around an open source identity. And in game theory terms, you hear people talk about it as the prisoner's dilemma, where they're collaborating, and there's an incentive for them to be collaborators with the community up to a certain point. And then it seems like a lot of the time those incentives shift. And the incentive is for them to become, in game theory terms, defectors and turn their backs on their open source roots and go with source available or even closed source licenses, which they usually have contributor agreements that allow them to do. And so I'm wondering if you see any way for there to be a way to structure things so that those incentives don't shift, or at least maybe shift much later.
So one of the things that's interesting about that is when you're thinking of the prisoner dilemma, or you're thinking of this type of game theory, all of these problems exist in the confines of a singular economy, a singular scenario, a singular whatever. And when you externalize the difficulties of a whole bunch of like the translation, and you have these two different economies, or two different prisons, and you're not really talking about the fact that there's two. The shift is what's happening when invisibly you've shifted from one to the other, but you're pretending like you're over here. And then so you're still doing a prisoner dilemma, but you're playing by a different rule book. And you have a communicating the rule shift. And so the thing they need to do is to give everybody the same rule book, and that would be like legibility, for example, is a way to do that. You have this economic prisoner dilemma versus this, collaboration prisoner dilemma style thing. And if the collaboration starts producing less money than the economic one, then it doesn't matter if you're not playing the economic one. It does matter if you are. And so what you see a lot of happening is you have the VC type of funding, where the VC funding style is explicitly to do this in a really weird way that often ends up creating a scenario where you're always playing by the economic one, but you artificially push out the start date of the economic prisoner dilemma. And then all of a sudden the start date kicks in, but nobody talked about it. And it may be 5 years down the road. Then all of a sudden they're like, oh, you have to actually start playing by the rules now. And you start seeing the value capture. They were always playing by the rules, they just weren't talking about it. So can you make that visible, can you make that legible from day one? That'll help a lot. But everybody needs to understand that you have to do that. And part of that could be, as an open source community, we might say, we're not going to interact with any VC company or any VC product or startup or venture or thing until we know that they're playing by the same rules. We know that they're doing this thing, that they're legible, and they're not punching out the start date in a way that they're going to sort of look like this value capture bait and switch. Everybody understands that at the end of the day, money needs to happen. It's fine, but don't lie about it. You can be clever about it, but don't lie about it, right? Like if you change the rules of engagement and make the playing field clear, it doesn't have to be level, but it can be clear.
Why don't talk about free software as in freedom? Free software as in freedom, and not just open source that means business. That might be a change of the mindset. I'm from Mexico, so we don't have all that startup thingy. Well, we have it, but it doesn't work. Why don't address from the standpoint of freedom and maintain the software supply chain free, as in freedom?
The software supply chain freedom
Not just open source, but
for open source.
with philosophy, not just business.
One of the complexities that's happening there is you have, when people talk about freedom, they mean in one perspective and one relationship, and they don't really communicate all of that. So like, for example, the difference between, say, MIT as a license and GPL as a license is MIT is more free than the GPL in terms of the consumer. If I consume the software, I can do whatever I want with it. I don't have to open source anything. I can do whatever. It's more free for them. GPL is more free for the producer, for the person who's writing the software. Oh, you fork this? You have to show me what you're doing. You have to contribute. You have to collaborate. We have to work together on this. You can't just disappear. So when we talk about freedom in the supply chain, we're really talking about you have these consumers, you have these producers, and you're often both. And what is your relationship with what you consider culturally or value-wise to be free? What's important to you? Is it that people can do whatever they want to, or is it that people have to play by the rules that you want them to? Or is it that, what's important? Maybe everybody can do what they want to, but people can't steal value, or maybe people can't make so much money off of it that you can't even afford to build your own software anymore. What's the values that you care about? And that's going to be what the free thing is. But the complexities that are happening there, people are going to use the word free, or they could use the word open, and they're not going to talk about the consumers or the producers or what they mean by free or what they value. They're just going to say these certain things, and then often kind of have a fight about it if you disagree with them, without really going into the subtleties of why. So that's where a lot of the friction can come from.
So there seems to be an inherent sort of pull on both sides of this. You sort of talked about how, for example, setting up rate limits is actually the perfect example of this, of using that as a way to prevent large corporations from abusing your service. But in some ways, open source being built on trust, there's an assumption there that at a certain size, you don't deserve that trust anymore, which is something that I've seen in a larger, older open source project, we've been on the bad side of having to basically architect around the walls that are put up to prevent corporate exploitation, even though we're not that corporate. So how do you manage that in an inherently trust-based system while also putting limits in place? How do you find that balance?
So that's actually a really fun question. Thanks for asking that one. One of the things that I think is important to sort of imagine is it doesn't necessarily have to be trust or preventing abuse. It can also be just sort of, often you don't know your own size. So if you're a giant corporation, the difference between stepping on an ant and kicking a rock is kind of the same. So a great example with rate limits. It's really easy to pass -- no cache when pulling a Docker image because it prevented a CI bug once, and you just added 3 zeros to their bill. If I do that, you don't even notice the difference. I went from 20 pulls to 25. You went from 2,000 to 200 million. And so I need to be able to, it's not even about necessarily protecting myself, it's about letting you be visible and letting you understand the effects that you're having on the community. And so if you're thinking about that, it's not necessarily how do you set up these guardrails. It's more in a trust-based community, how do you communicate so effectively with each other with this trust, with this knowledge that you can act in each other's best interests. I'm not necessarily going to remember to check how much of your bandwidth I'm using. But if you set up all these limits and sort of guardrails and protections, or maybe notifications in a trust system of, oh, by the way, did you really mean to go through 20 gigabytes per second of bandwidth? That's a lot. And you can go, oh my goodness, no, I forgot to set, production English true, and I forgot to set, oh, whoops. You wouldn't know that otherwise. So does that help? Yeah. I am probably at time. I see other people climbing in, but it was great, and I will be around afterwards out there, and you can all chat with me, and I'd love to talk. But thank you very much. Mhm. I am in Seattle, yes. Okay. Yeah. Yeah, that would be awesome. So I have Signal. What? I'm still on.
Check 1 2 1 2. Hey hey. 1 2 1 2. check, 1 2 1 2 hey hey, 1 2 check 1 2 1 2 1 2. Check 1 2 1 2 check hey hey, 1 2. Check 1 2 1 2 1 2 hey hey, 1 2. Check 1 2. Check 1 2 1 2 1 2. Check 1 2 1 2 hey hey, 1 2 1 2.
Hello. It's on. It's on. Want to do a little introduction? Okay, hey, hi. Hi, everyone. Thanks for hanging out with us. We can start with some introductions. We'll introduce ourselves. I'll introduce myself first. I'm Catherine Druckman. I'm an open source evangelist at Intel. I am really excited to be with these esteemed panelists, and I'll hand it over and let you introduce yourselves.
Hi, I'm Mike Stonke. I'm a VP of Engineering at Phlox, and prior to that, I ran engineering over at CircleCI, and before that, at Puppet.
Hi, I'm Kelsey Hightower. I'm just a person at this event. Happy to be here.
Awesome. Hey everyone, I'm Ron Afrani. I'm CEO and co-founder at Phlox and also the president of the NixOS Foundation.
Fabulous. So can we get started by talking about why we're even here, right? So the title of this panel was about taming the chaos in the future of engineering. But what do we even mean by chaos in this context? Anybody want to go first?
Y'all looking at me?
Yeah, we're all looking at you. I don't know how that happened, but everyone wants to hear from you.
I mean, it feels chaotic as someone who's recently retired and been able to step back from it. Software's never done. I think throughout my career, I think we keep working on software until it doesn't work anymore. We build up technical debt. We bring in new solutions. We go to conferences. We see new things. Come back to work, pad the resume. And before you know it, it's like a sea of chaos. I think we're at that point now where you can't really hold this stuff in your head. I don't think anyone's sure that they're doing it right. And if you ask someone if they're doing it right, it seems like no one knows. And so I think we've all kind of developed a way of just dealing with it. Just get it done by Friday. We run the QA tests. We scan for security vulnerabilities. We make the lights turn red. Then we make them turn green. And then we come back and do it all over again. So I think all of us have found our own way of taming chaos. Some of you went to group therapy. We call it DevOps. Which is another way of taming chaos. So that's the way I think about chaos. It's just like we're building the unknown, and it's never done.
So we created this ourselves, though, right? That we created the chaos. This community, all of us who have been engineers, are engineers. Anybody who touches the software technology in any way, we've created it ourselves. Is it a bad thing or is it a good thing? Anybody want to go?
I mean, fundamentally, there was a quote in computer science for as long as I've been studying it that was, you can solve any problem with another layer of indirection except for too many layers of indirection. And the problem is we're now living in the too many layers of indirection pattern. And you know, in a cloud native world, every time you had to do something new, there was a new tool you had to buy to go uncover that complexity or manage that piece of complexity or, you know, debug or monitor or whatever it was. It was just, you know, adding layers and layers and layers. And when you have 30 or 40 tools in there that you're trying to figure out how they all work together, now you have a new type of chaos, and just how do all those tools that are telling you how everything works work together and stuff like that. So it just seems like we've compounded this in big ways, and some of that's great, and sometimes you need all that complexity, but a lot of times it's kind of just adopted without really thinking about the benefit through and through.
So we haven't heard from Ron yet. We talked about this earlier, actually, right? We talked about how in the good old days, or maybe the bad old days, who knows, but we used to have one single brain. A single person could understand the entire tech stack and like really understand how everything works. And today that's insane. That's not possible, right? Is it possible?
Yeah, I think for me, the whole aspect of chaos is coming in from the fact that what we call internally, well, I call internally the squeeze. I think it's like we have two forces of nature kind of squeezing on us, the developer, in the middle. We have on the left the complexity of what I think Kelsey and Stonke were referencing. It's like more complex stacks, more repositories, more open source reliance, which is great. Like, these are all great things. And on the right, we're expecting our code to do way more than we did 20, 30 years ago, right? If I go back to when I started coding, it was in the military, so it was even 10 years behind that. There, like, all the code was kind of spaghetti code written by someone before me in that very same team. Right, and today that's really not the case. So I think today there's so much going on, so many layers to the stack that we need to either understand or be part of in order to take ones and zeros and turn them into magic. And I think that's chaos for me.
So I mentioned before, I love to think about in terms of the unforeseen consequences of the worlds that we create, right? The complexity that we create. Kelsey, you talked about technical debt as one of the maybe unforeseen or not. Maybe it's a foreseen consequence. But what are the things that we might be missing when we think about the complexity in the world in which we live?
I don't know. But I think that, I guess the way we get to it, every team I've been on, most of the work everyone was doing for the first time. Hey, we need a front end. Anyone's ever done that? Not quite to those specifications. I can probably do it by Friday. You've never done it before, so we just guess. Story points, whatever your flavor of Agile. And people are literally throwing spaghetti at the wall, coding the IDE until it works. Once it works, we're like, it looks good to me, ship it, goes to production, your customers QA it for you. You go back to the drawing board, but you don't always get to start over. We don't always get the privilege of building that second system. So whenever something new comes out, someone wants us to ship a version of it, and we don't get the luxury of saying, I've never done that before, and I'm gonna have to build an iteration of this that can be thrown away so that I can have the actual expertise to build something of quality. And I think a lot of this complexity trade-off has been, who cares about quality? Everything has bugs, so who cares if you make a few more? And I think that is literally the root cause. I'm not sure there's a lot of industries where you can be almost as reckless as this one, right? Because we always feel there's just another release right around the corner, and you can just fix it later. And so if you do get the privilege of experience, where you can carry that experience to the next company, and you get a chance to actually start to build with experience, if you're like me, you're probably bored by that point. I do not want to build the same thing 4 and 5 times. And a lot of times, that's where excellence comes from. People that are professionals tend to do the same thing over and over. Most of us get a little bored before that occurs.
Yeah. Can we put the horses back in the barn?
There's always someone with enough money that will let them run wild again.
Oh, that's fair. I like that.
Venture
That's a great answer.
capital, stock gains, hype cycles,
Hype.
right? Someone's going to always say, hey, I know, forget all that discipline. Move fast and break things. I'll pay you extra. And most people will raise their hand because it's a little bit more exciting. It has a little bit more creativity to it. When you say professional where it needs to actually work, a lot of people have given a stigma to that. Oh, that's waterfall. We're agile around here. We ship bugs and we ship them fast. And so I don't know if the appetite exists to be patient anymore because patience is seen as moving a little bit too slow, right? You're going to fall behind if you're a little bit too slow. So I think there's a balance here where we have to come back and say there's a reason why some things need patience. I would like my doctor operated on me to have patience. I don't need an agile procedure. If you don't know what you're doing, I will wait.
Sorry, I need a little laughing break there. That was great. So you had a really great segue there, right? Let's talk about hype cycles a little bit. So it seems like hype cycles are shorter. There's less time today between research and the next big thing and putting things immediately into production, right? That cycle moves very, very quickly. How do different people, different teams, different types of engineers, how do people deal with that chaos? How do you embrace it? How do you learn from it? How do you harness it to your benefit?
So I think that's a really good point, and part of that entire chaos is just the general equation of technology just ramping up at a more rapid pace all the time. So the gap we have between hype cycle to hype cycle is just getting shorter and shorter and shorter, right? It was like web, and then we have mobile, and then we had probably a bunch of things in between, and then we had crypto, and then literally, I don't know, it was really short between like Web3, crypto, and now AI into agents. So it's like, I even find myself in a situation where I feel like I'm way behind, right? There's new tools coming out every day. There's new platforms coming out every day. Am I gonna be a less effective, I'm a CEO, but at heart an engineer. Am I gonna be a less effective engineer or a CEO or a leader because I'm not using fill in the blank tool? And that's a question that I always have, and I think that's one thing that the hype cycles are creating, right? You have less time, to Kelsey's point, to kind of slow down, have patience, embrace the new wave of technology that's gonna help us do something ideally better in the world, get with it, and then understand how it impacts me and how I should use it. Here, I feel I'm starting to be way more reactionary, right? I'm like, oh crap, this tool is coming out, Devon's coming out. Should all of our engineers be using Devon because that's gonna be what makes us ship products faster to our customers and users? It's scary.
Yeah, I bet Michael has an opinion about that. But how hard do you chase?
You don't. I mean, like, what you need to do is you need to figure out, are there capabilities that you're missing? And as you read about new things that are arriving or understand what they are those capabilities something that matters to you in any way? There are so many tools out there that solve a problem that you don't have. And if it's a solution looking for a problem, just move on. And there's a lot of things where you're like, well, what if we get left behind? Well, what if you do? Do anybody remember unikernels? Remember how they were going to take over the world? Yeah, they're not here anymore. Yeah, they're not here anymore. And so, there are hype cycles that just burst out, and there are some that take on. Now, you look at, Node had a giant hype cycle, and people were like, oh, Node's over its hype cycle. Well, Node's pretty here. It's pretty embedded. It's pretty much a part of an ecosystem, whether you like it or not. But then other things just fall away. And so you kind of have to look at what are the capabilities that we need to deliver, and how do we deliver them? And I think, a lot of the move fast and break things mantra is that you do that because you don't have good product management. You do that because you don't know if you're building the right thing. You just go out there and you're like, here's some shit. Do people like it? Let's see. Let's try it again. Let's do something different. And whereas if you're doing the user research and figuring out the demands of actually your customer base and all that, you don't have to move fast and break things. You can move deliberately toward a great thing. So you have different options there, depending on how you understand the problems domain. And it doesn't mean you should always operate that way, but if you have the skills, do that, and that will feel more deliberate and patient. So maybe you can get around some of the hype cycle by actually having an understanding of what you're trying to accomplish.
So I think we're inevitably going to have to talk about AI because, it's like a rule now. But before we get there, so I wanted to talk about, so I really like to think about the real developers, the real engineers that are in the trenches doing the work that are going to have to tackle the problems that we're talking about right now. The people, how do we make all of this, all of these ideas that we're talking about here relevant to the people that are putting in the work? And one of the things that I'm thinking in terms of is, Michael especially, since you've led all these fantastic engineering teams, what are the things that we're missing here? What do people not know about? I think this is a fantastic opportunity for people to learn from you about some kind of underrated tools and things that you might need to impart.
Did you want tools that were AI based or tools that were
No,
not?
let's not.
Okay.
This is the calm before the AI storm.
I mean, there's a lot of new tools that I read about all the time that are not AI based that I really like, but there's some that I try out for 3 days and then I'm like, yeah, okay, and that was the end of that, and it didn't come back. And if it wasn't sticky for me, it probably wasn't that important. But most of the tools that I really end up centered on are, do you actually really understand the problems in front of you, and measurements and metrics? And like one of my favorite things to do with an engineering team is say, your job is to move this number from here to here. And it might be, okay, you get 0.5 engagement a day. I need it to be 0.7 engagement a day on these feature areas and things like that. And so then the engineers say, okay, I've got 25 ideas on how we can do that. And you watch them and you watch them iterate and brainstorm. And like, that's really fun. So what's the tool there? The tool is clarity on what your purpose is. That's the tool. Like that matters so much more than I downloaded some new installer and something magic happened. But there is a tool called Savvy that I really like that I played with recently. If you haven't played with it, check it out. But it's kind of like this weird thing that you can go through your shell history and say, these are the things you need to do for this run book or whatever, and it just exports it all. It's kind of neat. So, there are also all sorts of cool tools that are still being built all the time, and I write a lot of them that are integrate with Slack, and like, what do? They ship post faster than you do, but that's okay. Those are fun too. So.
Yeah, y'all have any thoughts about the non-AI things that we might be missing while we're so distracted, getting so excited about AI?
Your own brain, like it's okay to think. Most people that have a vision or are driving in a direction, they're really good at not getting distracted because they know where they want to go. I think when it comes to like the tooling side, when I see people do engineering, like the person that can paint with just 3 colors on the palette, they know the fundamentals of the material so well that they can just make that work. And you say, hey, what kind of paintbrush do you use? And it's like, I've just been using this one for 20 years. It's not a name brand, it's not fancy, but I've mastered this thing, and I only need 3 colors. I don't need to buy all that stuff, and I can paint the Mona Lisa too. And that level of discipline to be able to work within the confines when you go that deep. And I think a lot of times we might get distracted, like, man, if I just had a better paintbrush, I might be a better painter. And it's like, I don't know if that's the problem here. And I think a lot of times we forget that learning the fundamentals, so dealing with those hype cycles for me, most of them aren't actually that different. The reason why they're faster is because no one's really doing something that different. They may introduce new words to confuse you. Service mesh. And you say, okay, what does a service mesh do? Oh, there's this thing called HTTP, and you can make a web request, and then it will proxy to other things in the back end. He's like Nginx. It's like, yeah, but service mesh. Those that know Nginx well, you looked at service mesh, it's like, this is not radically different than the thing we had before. Now, I might download it, touch it, play with it a little bit, and say, oh, this is not making anything better. I just needed a load balancer. I already got one. This is not a net improvement. I'll revisit this when it shows actual value. And then those people just keep walking in a straight line. If you don't have those fundamentals, you're like, hey, have you heard of service mesh? There's like a better way to do networking. I heard packets move around faster with service mesh. He was like, wow, you don't know where networking is. Like, I never took the time to learn networking. So that's my number one tool. Just learn to think. A lot of the students here are like, hey, what programming language should I pick? I was like, just pick one. Maybe you like Python because you're into snakes. Learn Python all the way down, right? We used to have this saying, or at least I was taught this saying about the T-shaped engineer. You go deep over a lot of things over time, and over time you'll have the breadth and the depth required. And I think that's the number one thing we can do. So yeah, Go versus Python, you can do that. But whatever one you pick, go deep enough so you have fundamental skills that are transferable.
Yeah, I mean, I'm not going to get away from this question, and I can't beat the use your brain. But I can say, my favorite tool is definitely around Nix. I don't know how many people have heard that. I don't know if you were waiting for me to say Nix. Not going to say that much about Nix, other than the fact that I think fundamentally, right, Nix came around 22 years ago, and I feel like it kind of was clairvoyant. I think Nix came in and said, hey, at some point, things are going to get so complex that what if we just had a common architecture for everything? And we can take a stack of 4 or 5 stories in that really tall building of the CNCF landscape and just compress them into one, right? What if we can just do that base layer stack really simply? Now, yeah, it's complex. It's a bit harder to do. Maybe 20 years ago, we didn't care for that because, again, things were simpler. It was okay to be a bit more chaotic. But that chaos mixed with the additional chaos today, I feel like for me, Nix has been a very fundamental shift in a software principle, but also very much agree with the user brain. At the end of the day, there's some low-level language happening behind the scenes, whether you're asking an AI agent to do it and that's compiling it out into something else, something's happening back there.
Can I ask Ron a question?
Yeah.
So there's a thing that happens when you build tools. I've worked at Puppet Labs with this guy, and we're building tools. I've worked in enterprise companies where you're building tools, even if it's just corn shell scripts, that you put the date in the script so no one forgets what's the new version. And the question I have for you is, like, how do you avoid becoming myopic? A lot of times, if you work on CI/CD, you believe CI/CD is the center of the universe. CI/CD is the only reason why our customers are having success. And the software developers are like, bro, without the code, there will be no CI/CD. And we all kind of get trapped in the center of the universe is the thing that I'm working on. Because we talk about all this innovation and all this hype. No one's talking about biophysics innovation, medicine innovation, energy innovation. The universe is out there doing its own thing. That's not on your radar. But somehow CI/CD is the most important topic in your universe. How is you as not only just a toolsmith, you also lead a company where, for you all, that does have to be the center of the universe. How do you keep zoomed out enough to make sure you recognize that it's only going to be a piece of the puzzle for the things that people are actually responsible for?
I think that's a great question. I think that's also, I've seen that often, obviously, inside of Nix for a very long time. We've kind of viewed the world as like, you either use Nix or you don't.
Two types of people.
Two types of people. And for the group of those that want to be in the, you use Nix, you got to use everything inside of Nix. You got to use it for your packages. You got to rip out your OS. You got to use our Nix language. I think in general, right, if I'm kind of abstracting this away, not just on Nix itself, and I think us as a community inside of Nix have been doing a way better job in the recent years, it's been, let's focus on the problems, first of all, right? Let's focus on the problems that we're trying to solve, and then bring in our solutions. Once we have that clarity, I think Stocky was talking about that as the product aspect, right? Like, ship fast and break things. If you know what the customer wants, you don't have to ship fast and break things. You can ship deliberately and end up with something really good. And I think that once you have that, we can kind of meet developers. We can meet the ecosystem that we want to come and be part of us where they're at, right? So there's this question all the time with Nix that we get Hacker News once a month, like some blow up, where it's like, Nix and containers, what do you do? Well, both, right? Developers are using containers. Our users are using something today, right? We're not coming in and saying, hey, it's our way or the highway, it's our religion, which kind of sometimes feels like it. We're coming and saying, hey, we can do some really good things, and it's okay if you want to only use 30% of it, because that 30% is going to make you 30% happier. Great. So I think that step back, looking at the landscape, recognizing that not everyone thinks the same, there's a lot of variability, and understanding how you fit into the puzzle as a wedge rather than as a hammer is kind of like my key point for it.
I think the other thing is I commonly have conversations with developers that, you know, work in engineering departments that I'm part of, and I remind them that software engineering is not development. Software engineering is delivering a total solution to someone that solves a real problem. And a total solution is beyond writing code. It's beyond having CI/CD. It includes documentation. It includes packaging. It includes how you're going to support something. It includes everything in that ecosystem. And so when people say, hey, I don't do that, I'm a software engineer, I'm like, oh, wow, your definition of software engineering and mine are very different, because I thought we were out here to solve user problems, not spend all day in our editor. And that's just something you have to think about, like, kind of going back to your myopic point. Like, if all you do is work on CI/CD, sure, you can solve a whole ton of problems with CI/CD. That's great, but you know, your CI/CD system probably isn't documenting how all that stuff works. You have to have that externally or set aside in some way, and it's probably not packaging up everything from an end user pricing and packaging and download and payments and all that kind of stuff. Like, there are all sorts of things to do to complete software, and we get so caught up in the, if I'm not in my editor, I am wasting my time, and that is just, that's a different type of myopic like viewpoints on things that I also think is just totally overblown in this industry right now. And right now, I mean the last however long I've been in this industry.
I think, so something this myopia conversation is really interesting to me, but also something that Kelsey mentioned earlier, and that's this thought about paintbrushes, right? These simple tools to create what it is that you're creating. And I think, you know, just going back to the original, you know, the topic of why we're here is to talk about the future of engineering and cutting through the chaos. I think sometimes a fundamental belief I have is that the best developer tools, the best engineering tools are the ones that you forget about because they're so good that you don't have to worry about them. Those are the best. Those are the best ones, and the ones that often get overlooked. So maybe the future is sometimes just cutting through and ignoring the chaos to make sure that we're nurturing those things that go unseen, to make sure that those communities and those tools are healthy, and that we're kind of giving back what's necessary to take care of them, and that we're kind of, again, cutting through the chaos to take care of our ecosystem in the kind of environmentalist way of saying it.
I think there's questions in the audience. I don't know if
Oh,
we're
are
gonna have
there
time for
questions
them.
already?
Yeah, so we should probably take the question from the
Yeah,
audience.
I'm going to just go out there and we're going to do that. We're going to Oprah this thing.
Oh, while we're doing that, I was going to respond to that. That's
okay.
question or statement you made. There are times in my career I embraced the chaos or probably caused the chaos. Distinctly when Kubernetes came out, it was very disruptive. I was working at a startup called CoreOS. We had our own vision for how distributed systems would play out. We were building on top of Docker just like the rest of the startups in this space. And then Kubernetes comes out. And I look at our roadmap and I look at that thing, and very early on I could tell that that thing was going to be our roadmap in 10 years if we even knew or understood how to build such a thing. And so I saw the pivot very clearly. It was immature product, it's not ready for production, and I chose at that moment to join the chaos. That means disrupting our own roadmap, and then a part of that chaos is that I like to bring clarity. So I knew we're in the midst of chaos, and I got into the habit of learning in public. So nights and weekends, you're contributing to the project, fixing bugs as you discover them, but you know that's not enough. You have to write the guides like Kubernetes the hard way, or the O'Reilly book so that other people can get that through line clarity from the work that you've done. So I think there's a part in the chaos where you go to all the conferences and you grab all the stickers from the vendors' booths. There's the other part where you kind of dive in and contribute to see if you can bring calm to the chaos. But even the people that aren't contributing or writing the code, the educators are really important components during that chaos period. The people who look at the hype cycle and see right through it and say, oh, no need to panic. This is what that really is, and they bring clarity. And that's like a group of people that no one really listens to well enough in the beginning, because like, hey, you're killing the vibe. The stock is going up, not right now. But you need those people if you ever want to get that, you want to bring calm to that wave.
Awesome. Well, I'm ready to be Oprah over here. You had a question.
Yeah, great talk so far. My question is, this is important to me as a father, as a Linux user, a SCaLE attendee, and I think it matches the whole talk about paintbrushes. It's like, what's your thoughts on trial by fire? So in terms of like giving people new tools, I feel like what made me an engineer today is like, the thing about paintbrush is like, it's a very basic tool, it's challenging. A lot of people want to fast track their way to growth with tooling, and that, I was having discussions with other people here, like, what kind of chef would you like? Someone that cooks on a microwave or cooks on an open flame? And one's a lot more easier, but that seems at odds with these hype cycles with the tooling, and especially I think the growing use of Apple hardware. I'll throw that there too. So yeah, just keen to hear your thoughts.
I mean, I like tools that allow me to grow. Like there are situations where I do want to learn how something works. So for example, I'm going back to learn C. I skipped that. So when I joined the industry, it was Python, Ruby, Java. Those were all the rave. Then eventually Golang. But now that I'm retired, I have a little bit more space. I don't have a sense of urgency. I'm not applying for a job where C may not be the most popular thing to apply for. And as I'm learning C, I do not want autocomplete. I do not want something to generate code for me. I'm actually trying to learn. And so I prefer to bring up the various libraries, what the flags mean, that this pointer won't crash my entire machine. I look at other people's make files, compile their flags. Then I go revisit the history. Why is C deemed unsafe to use? What makes it hard? I didn't appreciate a string until I started writing C code. And so I think going back and getting those fundamentals and having the space and the patience to do so. So in those cases, I kind of turn those things off. So me as the tool, I'm looking to level up, so I don't want the shortcuts. But here's the thing. As someone who's starting to learn the trades, like the things that electricians do, people who do drywall repair or carpenters, once you've done that once or twice or 100,000 times, you are not trying to spend a lot of time on a job site. So you go look for the automatic saw. You go look for the things that make the job 1,000 times faster. I think the confusion is a lot of people that are learning something for the first time, they look at an expert in that capacity. They look at their toolbox and don't understand why they have specialized screwdrivers for specialized situations when they don't really understand the fundamentals yet. And it's hard, right? Because the way we present ourselves at the conferences, we're showing people the end of the journey. We don't always show people what it took for us to get there and the background knowledge that makes me appreciate the specialized tool. So I think that's kind of the trade-off. So it's not really Apple that's at your detriment. I use Apple just like any other Unix flavor myself. It has system calls, it has a kernel, you can run a VM, nested virtualization, ARM can emulate Intel with a Rosetta. It's a very advanced thing, no different than the other things. So fundamentals matter, and if you learn them, then most tools don't prohibit.
Yeah, I guess another way to look at this would be, like, let's say you love Lego. Do you buy Lego because you want the thing that's on the box and you just want to put it on the shelf and you want to show your Millennium Falcon off? Or do you buy because you enjoy the assembly and the journey along the way, and that's actually the fun part? And the second you're done with it, you basically just want to tear it down and build it again because, like, it's done. Like, what's the point of that? And so I think a lot of people want to just have an end product. And if that's the case, then you don't necessarily need to understand all the fundamentals. If there's tools that help you and you're effective at using them, then go ahead and use them. But like, know that you don't have the knowledge to modify the thing that got you to that level or to make a change or enhancement or whatever. It might just be, hey, I used this thing, it generated my, my homepage or my screen, and it's exactly what I wanted. Well, cool. Then you solved your problem and you can move on. Or you could be, I really want to understand the way that, Tailwind CSS works under the hood and all of Vercel and all of Next.js and everything like that. Okay, then go spend, 5 weeks sitting there and figuring all that stuff out, and you'll really understand it. And if you really understand all that, then you can go build N different web applications instead of just the one that you requested from a prompt on an AI. And so I think there's just a lot of options there, and it depends on, do you just need the outcome, the final product, or do you actually want to understand how it's all put together? So it's just, do you play with the Legos, or you just put them on a shelf?
Both?
So,
I guess you can pay
Why not
someone to
both?
build them and let them stop them for you.
yeah, I'm sure.
yeah.
You can probably also buy it already, kind of shipped to you. So I think I just want to add one slight opinionation on top of that. I think that I fully agree with the fundamentals. I think that if you, to your question about hype waves, trial by fire, kids, right, the relationship there, I think it's like fundamentals are not changing that fast, right? Okay, yeah, we can now use natural language in order to ask something to code something for us. But again, fundamentally, at the bottom, it's going to be assembly. It's going to be, above that, it's going to be whatever, Python. Above that, it's going to be words in English. Fundamentals change way less often. So the emphasis of, just to your point, and even Stanki's point about that T-shaped kind of person, where you dive really deep, you understand the fundamentals, you're going to be fine, right? Those cycles, you're not on that wavelength. I think the second thing I look at it from the right, I like just looking at it from both sides. On the right, I personally prefer 99% of the time predictable and reliable output over spikes. And what I mean by that is that as we're going through, these hype cycles and things are advancing, and yes, we can go faster, we can deliver products faster, whatever it is, I'd rather be an engineer, have an engineer on my team that is reliably outputting the things that we need, rather than someone that's oscillating. And one time they're diving into Web3 and becoming a Web3 expert, and we get very low output. And 3 months later, they're diving into AI, and they have like this spike for 3 months where they're just like at 150. I'd rather have that 90% consistently dripping in new tech as it comes slowly, but fundamentals are there, reliable output is there, because I think that's what drives the ecosystem, what allows us actually to deliver things at the end of the day. And I'm loving that there's audience questions, so maybe we do more audience questions. I saw him.
Okay.
raise
All
it.
right. Yep. I'll go over there.
We can also repeat it. All right.
Thank you. So I like the Lego example. Obviously, Kelsey and I have spoken. I like the user mind. I like the T-shaped thing. But you all are saying have a developer that knows the fundamentals. You want someone that already has the fundamentals, but nobody's talking about how you get to know the fundamentals. Like companies aren't really optimized for helping new people learn the fundamentals, but yeah, everybody wants someone that learns the fundamentals. What say you?
So this is my plug for open source. But I think you're right. I think you're 100% right. Right? There's a race. There's a consistent race, and it's very hard, close to impossible, to remove yourself from this race. Whether it's in software engineering, outside of software engineering, just in general life, like there's always the, look behind my back. Is someone gonna like blast past me? Is my next resume or CV not gonna be enough? Because, 2 years, I dove deep into something. To your point, like companies are generally not built to allow new folks to just dive into the fundamentals. I think from my point of view, I don't know if there's much to do outside of taking the time, and I think that's a privilege, right? Because not everybody has that time. Folks need to work, need to study, need to do things that they can. I think it's just, as long as you drip slowly into that fundamental, and that's like the main point on your mind for the first few years of your career, I think you'll get there. Yes, if you have privileged time and you can take a full year and just go really deep, to Kelsey's point, on your language of choice, which is the snake language, and you get all the way down deep into it, then great. And if you can't, maybe seeing how you split that up into 4 years, right, or just like stretching it out a bit. But you're on point. We're not built now anymore for that early developer.
I would say another way you can really get a grasp of a lot of the fundamentals is get closer to operating software versus authoring it all day long. The more you author it, the more you have to understand, when this fails, here's a failure pattern. When this failure pattern occurs, here's the fundamental reason why. You have to get into that or you can't do the job. So the closer you can get into operating software or doing even like QA analysis of software, things like that, like the other aspects that are in the software engineering family that are not all day in your editor, you will understand a lot more of those fundamentals. I learned more about software doing operations as system administration than I ever did being an engineer. And it's just a different viewpoint on the same stuff where, I'm operating the things that somebody else has written, but when it crashes, it's like, oh, it grabs the heap this way. Oh, it shouldn't grab the heap this way, or it shouldn't put this back on the stack, or, whatever. Like, there's all sorts of things that you end up having to learn just because it's broken and it's overnight, and it's your job to figure out how to fix it. So, like, it sucks sometimes, but you can learn a lot that way.
We got really lucky in our field, I think, of tech. Like this, I've never seen this before. If you want to be a lawyer, there's a criteria. You want to be a teacher, there's a criteria. And until you meet that criteria, you're not that. And tech is like, depending on the situation, the job you're applying for, they may accept the fact that you're not a professional. You don't know how to conduct a meeting. You don't know.
Advantage of it, because their families are too poor to pay for the incidentals. The room, the board, the internet, the computers, the books, the transportation back and forth, drinking beer on a Friday night, whatever it is, their family is too poor. And not only that, but typically the oldest child in the family went to work at the age of 15 to be able to help to support the other siblings in the family. And consequently, that's why a lot of Latin American families, it's the younger children who get to go to university and not the eldest. Now, some of these students try and get by flipping hamburgers or being a night clerk at a hotel or stuff like that, but that doesn't pay very much money and is typically not what they're going to university for. And so they work for a few times and then they drop out. And I knew one young woman, it was painful. She was within 2 courses of getting her bachelor's degree in computer science, and she said, I just can't do it anymore, and she dropped out. Very painful. So I started thinking about how could I get students to be able to work on a part-time job that would generate enough money that they would be able to pay for these incidentals. And the part-time job, we figured out, would be about 21 hours a week, which meant that typically the students would have to go for another year, 5 years instead of 4, to get all of their courses in. But they would be learning not only how to apply their computer science degrees, but also learning a little bit about business, how to run their own company, how to do marketing, how to determine what they needed to know for their customer and what the customer's needs were. And so that basically, by using open hardware, free software, and free data, don't forget Creative Commons, they would be able to create solutions to sell to these customers. Okay. We'll talk about a few of those in a moment. And they would be supplying what we in the computer industry call frontline support to the customer. How many of you have ever been on a computer support line by a telephone? How many of you have ever been on that support line for less than 20 minutes? And how many of you have actually gotten a real answer to your question? Now, back in the day, I used to work for Digital Equipment Corporation, and we had places where people could email in, or before the web, email in their problem reports and stuff like that. And I would ask business people in the audience, how many of you have ever turned in a problem report? And everybody's hands would go up because they were business people and they had problems. And I'd say, okay, all the people with hands up, how many of you ever got a well-worded workaround or fix for that problem? And now 1 or 2 hands would go down, but most of them would stay up. And I say, How many of you really got a really good answer to that? And now all the hands would go down, except one person's hand would stay up, and I say, Mr. Gates, you don't count. We need more frontline support work, not less. We're told, the cloud is going to make everything easy. No, it's not. I can prove that. But what Project CALA is doing is taking technical people studying computer science and computer engineering and teaching them how to run their business. And more than that, coaching them in how to run their business so they are successful. Now, we've done many pilots of this, okay? And originally, we were talking about only supplying support to free software. And after we ran a couple pilots, the students came to me and said, Mr. Hall, we want to have products that we can sell. And so I sat down and I said, okay, what type of products could we make out of free software that we could take and do 99.99% of the work so that these people could pull these products down, pull the software down, put it on open source hardware, whether it be a Raspberry Pi, a BeagleBone Black, or whatever, and have it work. And one of the products I latched onto is a product called Odoo, which is a point of sale and ERP system. It's the same type of system that you see in Starbucks up here, you see at McDonald's, you see almost every place. It has a little printer, maybe a cash drawer, it hooks up to a card payment system, it has an LCD screen and stuff. You can buy all that stuff, and you can put Odoo on there, and you can solve somebody's problem with it. Now, typically you will buy those systems from Oracle or Hewlett-Packard or something like that, and you might pay $30,000 to start, or $15,000 to start. I could do the same thing for $500. And not only that, but it's open source software. In a lot of cases, not just open source software, but free software. We'll get more into what that means later on. And that means that if you need to have it do something else, either the student might be able to do it for you for extra money, or if the student doesn't know how to do it, they can go to an Odoo support company and get it done by paying time and materials. So Odoo is one of them, a multimedia system based on Kodi. Put it together, have a really nice multimedia system that will do way more than your smart TV from LG or anything else. And more than that, you can fix it. And more than that, you can use components from a wide variety of different companies, not just LG or whoever is putting it out. You create a secure home server and keep it in your house. Plug it into the wall, use a couple watts of electric power. This is for the people that don't want to store their Social Security information or their credit card information or stuff up in the Google Cloud. Now, many of us live in the United States, and our information, our data is protected by laws and our Constitution. But if you live outside of the United States, and since I do a lot of work in Brazil, I tend to talk to people outside of the United States. You find out that there are certain acts that say, oh yeah, you're protected, Mad Dog, but they're not. And we can listen to your conversation because they're not, okay? And that's a problem. And it's a problem that they can't store their data. If they're storing it in the cloud, they can't make sure that it's being stored outside of the United States. Now, let me say at this point, I love my country, okay? You may hear me say things, you say, Mad Dog, you don't like your country. No, I love my country. I want my country to be perfect. And unfortunately, it's not. So, getting that out of the way, then a lot of you are aware of the Fediverse and social media, social constructs and stuff like that that can replace things like Facebook and new Twitter and all these other things. And they're all free and open source software. And you could take the Fediverse and put it on top of this secure home server and actually make a community server that would help out in lots of different ways. Now, I gave a talk, complete talk on Project Kawa last year here at SCaLE, and like I said, it's up on the web, you can watch it. But here are some of the updates this last year. We've had the Home Assistant I/O to this to be able to allow people to go in and set up home automation. Now you say, well, Mad Dog, you know, it might be really expensive to do that. And so part of our counseling to the students would be, don't necessarily pick mom and pop as your customers for this. Pick the people up that have homes up in Bel Air who money is no object. And you say, we're going to go in, we're going to help you design your house, we're going to help you install your house, and we'll be doing it with free and open source software. And they'll say, okay, here's a couple $100,000, go to it. But instead of you having to share that money with Hewlett Packard or Oracle or some other thing, you'll be able to stick that money in your pocket. We've also extended the program from university students down to high school students. And the reason for that is that we want to have the high school students know how to do this before they leave for college. Because they'll probably be changing their address at that point. And what they want to do is to be able, as soon as they get to the university and get settled in, they want to be able to take over customers from the graduating class who have already done it. And they want to be able to give the same level of support to the customers of the students who are now leaving to go off to do whatever they want to do. But yet the freshmen coming in will know the system, so they'll be able to take over. So we're moving down into the last 2 years of high school to start this. And we're going to be implementing this through LPI's program of Linux clubs. Now, why do we have Linux clubs? It's because if you're talking to a high school in a lot of places, the high school already has its classes set up. They have certification of their classes and things like that from the Board of Education or whatever. If they disturb that, that means they have to go through certification again. But a club, you can teach all of this stuff to them, and you don't have to get any approval from the Board of Education. All you need is a mentor, a faculty member who's willing to go along and supervise it. And I now have an engaged website developer who's an amazing website developer and can typically develop a website in a day or two that most people would take a month or two. We've got all of the information together for that. He's going to start next week. We hope to have everything done by April the 18th, which is the Linux Fest Northwest, where we'll have the announcement and show it off. So now we come to the latter part of the talk, where we're going to have fun. We have an answer for oligarchy. I was talking to a gentleman earlier before you all came in about having local businesses, local people doing stuff. And so an extension to Project Kawa is an answer to oligarchy. Instead of having one company that has 1 million employees, we're going to have 1 million companies that have 1 or 2 employees. And they're not going to have any middle management. There's not going to be any middle management to have, because the person who is the CEO and the president of a corporation is also going to be the person delivering the services. And so they're going to be able to stick a lot more of that money into their pocket. Okay. And how do we do that? Because when you have a company, you have to have a development staff, and you have to have a whole bunch of lawyers, and you have to have a whole bunch of marketing people, and you have to have a whole bunch of this, even before you sell the very first piece of product. We're not going to do that. We're going to use the community to create all of those things for every country, for every state, for every language, for every law firm, and we're going to put it up on the internet so that these people can pull it down and buy the components and put it together, and it will work. Now, you may have to study a little bit ahead of time. That's why we're going to put all this stuff on the internet so that you can study. I'm going to give you a little clue because you've seen the types of systems we're going to have. So look at Cody, figure out how you can tune it, put it together and stuff. get information on Odoo. So Odoo is actually two things. It is the computer science part, the database part, the graphics part, things like that, but it's also the business part. How do you set up an inventory system? How do you set up, delivery stuff? Those two parts, and you can partner with one computer science student and one business administration student to come together to create your Odoo company to deliver this. And one student would go in and take care of the technical part, and one student would go in and take care of the business part and work with the customer in setting up the Odoo system. So a lot of people say, well, Mad Dog, this doesn't sound very capitalistic. And you're right. Capitalism is just only one economic system in the world. It came after feudalism, which was the king owned everything and everybody else was serfs. And there was another one called socialism. And every time I say socialism, there's a large group of people in the far right who say, communism! And no, it's not communism. It is socialism, where a group of people come together for the benefit of everybody. They're working for a common good. And the United States has a lot of socialism. We have socialistic military, we have socialistic public schools, we have socialistic lots of stuff. And they work for the most part. Some of them are terribly underfunded, like schools, and some of them are terribly overfunded, like the military. But nevertheless, for 250 years, for the most part, they have worked. And in state socialism, what a lot of people consider communism, even though it necessarily isn't, that's where the state controls the business. But what we're talking about is democratic socialism. But if I call it by a different name, like employee-owned cooperatives, then people say, oh yeah, I know about those. That's what Land of Lakes is. A whole bunch of dairy farmers and dairies and stuff like that who banded together into employee-owned cooperative, and you can go to the food store and you can find butter and cheese and stuff like that they're working on this together. Another example of that was rural free electricity, or rural electrification program. Because back in the early days, when electricity was first created, the place that electricity came was the city. Because you had all these buildings very close together, it was easy to wire and stuff like that, and the cities had electricity. But the farms did not. The farms were still using kerosene lanterns and stuff, and the farms would burn because the kerosene lanterns would catch on fire. But more importantly, the farms did not have a way of keeping their milk cold. And so they needed to have electricity on the farm to do that. First they did that with generators, but trying to get the electric lines to go out to the farmlands was very, very expensive. Until the government stepped in and said, we're going to help you. We're going to help you design it. We're going to help you fund it. But you have to bear the bulk of the cost. And you're going to do that by forming a cooperative to produce the electricity for you. And my brother and sister-in-law belonged to one of those cooperatives in Gettysburg, Pennsylvania. And for years, they would go out to they would receive a postcard in the mail, go out to their electric meter, read the numbers of the electric meter, write it down the postcard and mail it back. And then the company would send them a bill the next month. They'd pay the bill. At the end of the year, they got back a certain dividend paid back to them according to how much electricity they used, because they were the owners of the electric company. If you go to www.coops.tech, you'll find a whole bunch of technical co-ops, including one down in Texas that is owned by the people who work on it. And these people go in and they hire managers to be able to manage the companies. But those managers report to the employees. The employees are in charge. So this is a private ownership. It's not public ownership, it's private ownership, just like capitalism is private ownership. However, the ownership is either of the employees or of the customers. So, if we think about what Linux is really, it is not closed source channels like certain unnamed companies are. Okay? It's where a community of people comes together to develop code that they equally share amongst themselves and they can use to solve their own problems. And they can tailor that code to the customer. Now, I know a lot of you use Linux on your laptops or your desktops or things like that, and you just download it and never change it. You just wait for the next release to come out because that's good enough. But if you wanted to, you could change it. If you didn't have the expertise to do it, you could hire somebody to do it. And since I work for LPI, I'm happy to announce that we have 300,000 certified Linux professionals in over 180 different countries. There's only like 2 or 3 countries that we don't have them in because, well, political reasons, let's say that. But that doesn't include Cuba. We have them in Cuba too, because we're headquartered in Toronto. So I'm going to tell you why closed source fails. Years ago, when microcomputers were first coming out, I had a CPM system. I decided I was going to buy a CAD package. And this was a closed source package generated by a little company very close to my house. It was a company that was in Massachusetts. And they had about 1,000 customers for their CAD package. And they had 20 developers who were developing the code. And I purchased it. It was a very nice little CAD package. But I had a couple problems with it. So one day I showed up at the company. They had a little entryway. There was a little door there. It was like a half door like you see in a stable. I knocked at it. They opened up this little slot. They said, yes. I said, I have this problem. I sent you an email. Oh, yeah. We got that. Here, install this. You'll be fine. It was great. I had 2 problems. Their 1,000 customers could have 2 problems apiece. That's 2,000 customers for their 20 developers. You know, that's 100 problems to solve in a year. Relatively easy, and a lot of those problems may be the same. Relatively easy to do. However, 2 years later, the company had grown. They now had tens of thousands of customers. You could buy their package for $39.95 or $40 or $34. And they had grown to 500 developers. But if each customer only had 2 problems, they had tens of thousands of problems that they had to manage, they had to solve, and whatever. And they wanted to help, but they couldn't. I've worked for a lot of different companies, Digital Equipment Corporation, SGI, a lot of them, and they're all in the same boat. They want to help, they really do. They take pride in it, but they can't. And these are problems in the software, not even extensions to the software to meet their needs, because that's even worse. And I could go on and on and on of the cost of this problem. But if you're talking about open source and free software, open source is great for developers because you gather together all this bulk of software to make your development faster and better. You can use large portions of software that's been used to other things that have been tested and to put together your solution. But with open source, there's no guarantee that the changes you make are even going to be sent upstream. And there's no guarantee that you're going to make that source code available to your customers. That's because it's a permissive license. And there's only one license that I know of which guarantees that. It's the one that most people call the restrictive license. I happen to think it's more permissive. It's permissive to the customer. And that one forces you to make your source code changes available to the end user customer. And as I said before, not every customer has the expertise to make use of those, but they can hire somebody who can. So for years, we've been told by the big companies that cloud computing is going to make things easy to do. You're not going to need as many systems administrators. Everything goes up into the cloud. It's really nice. And, oh, by the way, you've got all your phones and apps and things like that. And sure, that may treat 90% of the audience. But if you're in that last 10%, you're out of luck, okay? So that's why all these things are both easy and hard. I mean, why would you need Apple stores if it was that easy? How many of you have gone to an Apple store? I mean, I'll give it over to Apple. Apple does a great job at integration stuff. Really wonderful, really wonderful. It's so easy to use Apple. If it was that easy, you wouldn't need Apple stores. You wouldn't need Genius stores at Best Buy. Genius people, right? My husband is Brazilian. He is also the support person for the greater part of his neighborhood. And he used to try and support them with their Microsoft Windows systems over the telephone. But then he just said, no, you're going to install and use Linux if you want my support. And that's what they do now, the whole neighborhood, because they can't afford, either in time or energy, to get the support for Windows. So what we need is more localized support, more localized sales, the people who actually talk to the customer, go into the customer's site, see what they need. And this type of support is traditionally very expensive to deliver. In Sao Paulo, Brazil, the city is so large, it takes you 4 hours to drive across the city at peak hour. 4 hours to go across and 4 hours to come back. So if you're supplying telephone support to a customer and they say, I still can't get it to work, and you hop in your car and you drive across the city just to find out that their mouse is unplugged, that's a lot of expense, okay? And typically the people on these call telephone lines are overworked, understaffed, undertrained, and that's why you wait so long on the telephone for your help. So what we need to do is to flatten that hierarchy. And so I am about to tell you a management wet dream. It's called a non-salaried, commission-based local sales and support team. In other words, a Project CALA student. You don't pay them a salary. All the money they make is from sales, commission, going out and selling. And this will allow them to sell really interesting products at a much lower cost than you would think. Because typically, 36% of all software pricing, all software costs, are sales and marketing. And so you can eliminate that from going out to a, quote, sales and marketing team to going into the student's pocket. And the customer will see no change in what they pay. If you're delivering the solution and the maintenance to the customer, then he has no costs other than his or her time and materials. And if they need something that they don't have the knowledge to do, Project CALA will provide them with the ability to find a solution, either through other people in the Project CALA community or through going to a next level of paid support from professional commercial support people. Now, I've been working on this for 9 years. We've had many different pilot studies. We've learned a lot. But I now have a time to go forward. And by Linux Fest Northwest on April the 24th, we're going to have the website up. We have all the materials and steps of how to do this. We're going to have legal contracts in at least several different countries, along with advertising materials for each solution written in that country's native language. There'll be a lot more countries that can do this, and we want to do this, but what we're going to do is allow those countries to take and see what we're doing and translate it into their language, their legal support contracts, put it up on the website, and then find mentors for all the students from universities and other places. They will be able to do this themselves without asking anybody's permission. And it will cost them nothing. So we need mentors. On April the 24th, you'll see the website go up. And if you would like to mentor some of these students, lend them your expertise, particularly business expertise. A lot of these students are so shy, they don't think they know anything. Yet they do. They know more than the customer does. And they can find out how to find out what they don't know. So Odoo is the first mainstream thing we're going to do. We have all the hardware that people can order off the internet. And we will put together packages so you can just order one whole thing if you want to. But I would encourage people to order individual things to tailor it better. And we will have a list of VARs in each country that the students could go to if they run into a problem they can't solve. That is actually the end of my talk, which I wasn't going to give, but I did. Now we're going to go into another couple slides. And it has to do with tariffs on computers. There's been a lot of talk in the last couple months about tariffs, and particularly tariffs on things coming in from China. And so I have a suggestion for China and Taiwan. I think you'll like it. Stop shipping all laptops and desktops to the United States with closed source software on it. Instead, put free software. Because the argument given way back when of why you had to install a particular closed source solution on every single laptop and every single desktop was when it went to the retail store, people needed to see that the computer worked. People needed to be able to compare one computer versus the other as far as its efficiency and things like that. And there was no other solution other than a company in Redmond, Washington, to do that with. But it isn't 1994 anymore. We have companies that are selling Linux installed on their laptops. My laptop right here is from Lenovo. And so what you can do is put free software on that laptop and ship it from China or Taiwan to the United States, and the cost of the laptop will be reduced. And that means the cost of the tariff that you pay goes down. And people talk about the tariff, but they don't talk about something else, the sales tax that goes on top of the tariff. So it's not 25% tariff that you're paying anymore, it's actually 30%. So you say, well, geez, how much money could we be talking about here? Well, let's use my laptop here. It's actually about $22 billion a year that a certain closed source software company gets from installed products onto laptops. That's a lot of money. It's approximately, if you average it all out, about $40 per system. Doesn't sound like a lot, but if you're buying 1,000 systems at a time, it's $40,000 plus the tariff plus the tax. And it's not like I'm saying you can't get Microsoft on that. It's just that when the system comes into the country, it's going to have Linux on it. And they can install Microsoft on there if they want to. It's just it's going to cost them a little bit more. Or they could have a channel partner install that software on there if they want to. But there's a lot of countries around the world that are mandating free software for their government and stuff like that. And I think it is wise for the Chinese government to think about standardizing on free software on every single laptop and every single desktop. There is a group of countries called BRICS. You may have heard of them. Their actual purchasing power is now greater than the purchasing power of the United States and all of our G7 allies. And Europe has actually joined through a side path this BRICS organization. So I bought my Lenovo, I ordered my Lenovo laptop from the web, and I saw on there that not only did they sell with Microsoft, a closed source solution, but they also sold it with Ubuntu and Fedora. It's just that Ubuntu and Fedora would not be available until about a month later on the same day. I thought that was kind of odd. Ubuntu and Fedora being available on the same day for the laptop? And then I got it, and I realized it's a new kernel that went into both distributions. And not only did Ubuntu and Fedora work on that day, but also Mint, Alma Linux, Debian, okay? Everything worked on the same day. And so we know how this works, don't we? As I said, Microsoft makes about 22 billion US dollars every day from OS licenses installed. Let's be kind. Let's make it only $10 billion on license fees that come from laptops and desktops. But that's about 250 million systems, or on the average, $40 per system. Your 25% tariff generates a lot of money that's just going to the United States government and making it more expensive for United States citizens. And that's without the 5% sales tax. Now, other cost savings, license management costs. You don't have to do as much license management when you are using free software. And so for the Chinese companies and OEMs and distributors and stuff, it's a lot cheaper. And we're just talking about the operating system. If you bundle in a Office package, you bundle in a database engine like Postgres, then you're delivering a lot more functionality for the same cost, non-tariffed cost. Okay. And legal costs also you have to look out for. So, Mad Dog, how I get China to do this? You say this is SCaLE. This is the first time I've talked about this to anybody. How am I going to get China to do this? I have 5,000 people on my Facebook page spread all over the world. I have 300,000 certified developers in 180 countries around the world through LPI. And I have organizations that I can reach out to and say, this is just a suggestion, Mr. Ping. You know? And we'll see what happens. And we'll see how the United States reacts to it. I think that China will see the advantages. And so with that, I'll ask if there's any questions. We have a microphone, if you'd like to utilize that to ask a question. Any comments is also available. There's a question in the back.
Hi, thanks for the talk. Really inspiring. Coming back to
Project Kalwan?
sorry?
Project Kalwan?
Yes. So I think there's a sort of an elephant in the room about which is AI and how it affects or changes the balance of local versus centralized, where it comes to knowledge workers. So I wonder how you see it affecting your projects.
Well, I think a lot of it depends on the product that you're trying to sell with Project Kalwan. There might be a lot more, it might have a lot more effect on something like Udo, which is a business thing, so that the AI would be able to react to the business that you have. Of course, that also makes it easier for the local person to use the AI to be able to tailor the answer to the customer's needs. My finding has been, however, that a lot of times customers have a difficulty in describing exactly what they want. And somebody who has the skill to listen to the customer can then make the query of the AI system to be able to give exactly the answer that is needed. The other problem with AI is it isn't always necessarily correct. It may give you a large leap towards the answer, but somebody really has to check in on it, okay? At least for the next several years that I could think of. Maybe in the future we will have cognizant AI that will be able to more rapidly learn from its own mistakes. Of course, when that happens, I hope that I am dead. Or that somebody has the sense to pull the plug out of the wall. Did I answer your question?
Yes, so you're saying that it lowers the barrier for anyone to give services, right?
I'm sorry, I didn't hear that.
So basically you're saying it actually helps by lowering the barrier, knowledge barrier, for anyone to give local services.
Well, that too, okay? I mean, so the goal here is not to the goal here is to allow people to deliver services to the customer. Now, the thing is, if you go to a store and you talk to the storekeeper about putting in a new system of some type, they really don't want to know. They don't want to know that they have to have a Wi-Fi system. They don't want to deal with it. They want to sell stuff. So, for example, trick question. I love asking these trick questions. What do people sell in your typical PC store?
Yeah, they sell recommendation of what to buy, right?
No. They sell the same thing that they sell in a food store. They sell the same thing they sell in a shoe store. They sell shelf space. Where you line things up on the shelf, the customer comes in, picks it up, and takes it out. If the customer has to ask you even one question, you're losing money. It used to be years ago when computers were really expensive, you could ask 2 or 3 or 4 questions, and they had trained, knowledgeable people there. But they don't have that anymore. They hide those people back in the Genius Center or something like that. And if you have to ask even one question about that device that's on the shelf, they're losing money. That's why when you go into a food store, all of the high-priced stuff is up front and the milk is in the back. Okay? They're selling shelf space. And that's all that people want to sell, really. So what we're doing is allowing people who have the questions to find the people who can solve their questions locally and not have to wait for somebody to drive the 4 hours across the city to plug in their mouse.
Thank you.
You're welcome.
Hi. This project CALON that you're talking about, that seems, please correct me if I'm wrong, it seems tailored to Latin America?
No.
No?
No.
Okay, well, that was the nature of my question then, do you think this model is applicable in the US and outside, or only in certain areas?
It is applicable. Over in Europe, there's also a lot of universities that are free of tuition, but there's a lot of people who can't take advantage of it because they can't generate the money to live while they're going to university. It's only, in my estimation, in the United States that our universities are so freaking expensive that most people can't afford to go to them, or if they do, they end up with debts that are in the hundreds of thousands of dollars. We used to have land-grant universities that were free of charge to citizens of the state. That went the way of the dodo bird when Reagan became governor of California and later president. The University of California system was tuition-free until about 10 years ago. Now, if you try and go to the University of California, Berkeley, it's $15,000 a year. Now, you take a single parent who has 2 children, they're making minimum wage, and for the most part, they're making about $15,000 a year. They don't have health insurance. They're taking all of that $15,000 a year to pay for their house, their food, and stuff like that. What chance does that student, does that child of them looking out say, oh yeah, I'm going to be able to go to California, the University of California, Berkeley, if it's going to take the entire salary of my parent to pay for the tuition? This is a crime against God. I benefited from a land-grant university, but my friends' children or grandchildren cannot. We have to fix that. Okay, but going on, what if you're not going to university? Does Project CALON still have any use to you? And the answer is yes. Because we're to show people how to be able to sell products made up of free software and open hardware and be able to deliver services, be able to deliver their own company without having to give money out to stockholders who at one time contributed some money to get the company started, but hey, the machinery they bought has rusted away, but they still expect to get their dividend. So the money you make will go into your pocket, not to a stockholder, nothing like that. So yeah, it will have an effect. I don't know what it will be yet, but it will have an effect even in the United States. Yes, sir.
So I had 2 questions. That was my first question. So I'm brilliant, like the kind of grassroots impact of like what a project could have would do in this country. Also, I'll do the second question. Now, second question, you got the gears rolling. I think a big impact. I didn't realize the economies of scale when you talk about impact on, transitioning these OEMs from China and Taiwan to open source software and having them export with, say, a Linux distribution on thousands and thousands, millions of desktop, laptop computers, server systems and whatnot. So I was just thinking like, wow, yeah, it's a great point. BRICS, Brazil, Russia, India, China, and now, yeah, the S is South Africa. They have Indonesia on there. I think it's total like 22 countries. They have like 60% more. They have like 60%, I think, of the productivity base compared in the totality of the world economy, and so economically it's a huge adversary against the United States and G7. So bottom line, I'd like to know, what is your thought on how do you get the OEMs to transition? What would there be their incentive to move to something from like, let's say closed source just to open source? If they say, well, we can't do that because that wouldn't be viable for our customer base. Do you think that that really the majority of the consumers and really where we'd have to go is convincing governments? Because like say, Latin America, there's been some successful cases like you pointed out, but in Europe, there's been some successful cases too. Spain, France, I think Germany now is a big example. So would it have to be that like G7 plus BRICS, really you have to start to convince the government's prime consumer of these computing systems to transition to a open source kind of framework for consumption? Does that have a huge, like, considering economies of scale?
You're making this a little bit too complicated. Okay? First of all, you're talking about a capitalistic country. China isn't that. Okay? The Chinese government could simply say, we're going to stop putting Microsoft on these units. We're going to deliver them either with no operating system or with free software. You have your choice. And then it's going to be up to the places that want to have Microsoft on them to put them on there. Canada has recently made movements or statements that they're going to cut off the northeast part of the United States from electricity. They're not going to deliver hydro anymore to the states. They've been suffering through some brownouts and stuff because they can't produce enough electricity. So by not delivering it to the United States, they can solve that problem. So we're going into a realm right now. This is new space. And, you know, and it's not that, you know, customers could not get Microsoft or their systems. They could. All they have to do is install it themselves or have some company install it for them. But for everybody else in the world, they're receiving a system with a perfectly viable operating system on it. Now, if certain people in Washington, D.C. want to be more reasonable, then maybe we could go back to status quo. However, I think that a lot of countries outside of the United States would be just as happy with free software. And this doesn't have to happen overnight, but it can happen over time. And we could see in the next couple of years a broad sweep of 4%, 7% desktops into being 90% free software desktops. I hate to say this, but thank you, Mr. Trump. Yes, sir. You, sir, in the back.
So going on with that particular question, what if either the current or the next administration were to pull a C and be like, you know, this free software is a threat to the country, and bans it in the country. They make a presidential order banning free software because they, for some reason, deem it a security threat to the nation. How would we get around that when it comes to this potential solution?
Well, first of all, they could do that anyway.
Mm-hmm.
And second of all, I really don't care.
Sure.
Because as we just said, the BRICS countries in all is greater than the GDP of the United States and its allies. And if the United States starts doing that, it may even shove more people towards the BRICS initiative, more countries towards the BRICS initiative. I mean, BRICS a few years ago, I saw it coming. And I said, hi, you have to pay attention to this. People laughed at me. Of course, they laughed at me when I was supporting Linux back in 1994. And they laughed at me when I got the Rockridge extensions into the ISO 9660 definition, so we could put Linux and Unix systems onto CD-ROMs and stuff so we could make ISOs. They laughed at me then, too. And they laughed at me when I talked about Unix being a force in the universe back in 1977, they laughed at me. It's okay. I'm used to the laughter. I think they might try and do that, but it's not going to have any effect. I'll give you a different effect. What happens if all of a sudden there is a nuclear warhead that hits Redmond, Washington? How long would it take us to be able to formulate another distribution of Microsoft Windows to send out to everybody? What happens if a horrible disease hits Redmond, Washington, quickly wiping out the entire central engineering force of Microsoft? I don't know. And I don't care. Any other questions? Question down here. Oh, okay.
Hi there, just a quick comment. The last slide said it was about slide 29 out of 48. Are there more slides, or is just the typo?
I'm sorry, I didn't hear the question. I'm a little hard of hearing, and so you have your mask on and
Okay, no worries, I'll repeat the question. So the last slide, the question slide, at the bottom right, says it is slide 29 out of 48. Are there more slides?
yes, there are. And those are slides that were kind of left over from the talk last year. So if you go to last year's conference, my speaker page, you'll find a link of the slides and the talk that I gave last year, which goes into much greater depth of what Project Kawan is and how it's going to be implemented and stuff.
Thank you.
Yeah. Okay. How much time do I have? Time's over. All right. Thank you very much for coming. Yep. Great to see you again. Hi. Let me get this, because I have to get out of here so that other people can come in, and I can see you outside, okay? Sure. Thank you. I hope they're going to be even more involved next year. Hope. No. They'll find me. I'm at the LPI booth. Yeah, yeah. I got this. I got this. I'm going to do. I can't do that. It's tight around my tie. That's the problem. Yeah. Wait a minute. No, I can get it. It just has to. There it goes. It's around my tie. So, and I want to close up things to get out of here so that the next person can come in. Yeah, I understand. That's why I'm offering to help rather than trying to slow you down.
testing, testing. Nice. How about yours?
Standing too close.
Yeah, can you hear me? Yeah. That sound good? Okay. Awesome. All right, we're going to get started as it's 3:45, and I really appreciate you all spending this part of your afternoon with us. How's SCaLE been for everybody? Good? Nice. Okay, there was almost some clapping happened. So there we go.
All
We have to
right.
practice that because
Yes.
we're going to need some of that after a while. We thank you so much.
Encouragement is welcome.
Yes,
Yeah.
thank you so much. So by way of introduction, I'm Jeremy Adams,
I'm Rebecca Dittmar.
and we are from two different companies, but we care about some of the same things. I look after the ecosystem at Dagger,
And I'm a software engineer at Nike.
and we're going to talk a little bit about pipelines as code, impact for developers, and we're going to talk a little bit about some new stuff that's happening in the Dagger sphere. Who saw the keynote this morning?
Right.
Okay,
that's
so
good.
like half the folks did or so. So this is cool. So some of you that didn't, you'll get caught up, and some of you that did, maybe I'll show you a little something different that you haven't seen before, hopefully. So Rebecca, given that you work, she said, don't ask me like a direct hard question on the spot that we haven't rehearsed before, but I'm going to go for it anyway.
Well, I don't want to talk to the attorneys later, so.
Oh, that's right. Okay, do you have like a disclaimer that you have to use?
When I do development work for unknown places and
Yes. Yeah.
clients, I've noticed the state of CI/CD in 2025 is fairly similar to what it was in 2023 and 2021.
Yeah, some things never change, eh?
There's a lot of YAML. There's a lot of pushing and praying. A lot of the pipelines I have experience with might get to like 30 minutes and then it fails on a WSGAN, or a Cypress test fails. And you're
totally.
pretty committed, you're already all the way in there. And of course, it's when you're on production support and there's an emergency. That's when it usually has a problem. So not a whole lot of improvement, as much as we're all trying.
Sadly, okay. Is that resonate with folks here, that there's challenges out there in CI/CD land? Who runs CI/CD here? Okay. And who is a consumer of the CI platform as well? Okay.
Thank you all for your service.
Yes, yeah. And for other folks, are you just kind of CI curious? Or, you know, what? Yes, okay, yeah, so there's a little bit of interest. So we're going to try and like see if we can help with that. So like this idyllic scene you see here of this little software factory chugging along, pushing out the releases, right? That's what we like to see and imagine. But it turns out that, you know, as you grow and maybe just, you know, as time goes on, things get a little bit more like that. Yeah.
Right.
Yeah, and I guess it's not just the traditional CI stuff that you're seeing out there.
No, now we're having a lot of these like AI fueled tools, which just seems more confusing.
Yeah, there's we'll start with the CI challenges, and we'll get to some of the AI stuff as we go along.
Sounds good.
So this is, I guess this is kind of what you're talking about, you know, where, you know, there was a time, and a simpler time, when, you know, you start out and your pipeline maybe looks like the one on the left. It's a little bit of GitHub Actions YAML, not too much, you know, just a little simple build and test and just push that thing out there. And then, you know, as things go along, I imagine there's more to worry about and things.
Right, you have an infrastructure change or something like that, you know.
Yeah.
Start adding files because you're wanting to deploy to more than one place, for example. Yeah.
Just more complexity.
More complexity.
And this happens as things mature. And it gets to a point where, I mean, as a consumer of the CI, I'm guessing you're not in there you're just more trying to use it versus debug it, or do you have to try and intuit what's happening as well?
Right, you got to figure it out. It's just the goal is make it work.
Right, just make it work. Make it so I can ship my
I have
software.
things I'm trying to get out there, and I don't want this in my way.
Right, and then there's someone else.
Sorry, CI people.
Someone like some of these people out here in the audience actually have to deal with that state on the right side. Is that, so who's running like thousands of lines of YAML or hundreds or thousands? Yeah, so this is what happens, and it becomes, is the frowny face sort of appropriate? Like, okay, as you try and reason about what's happening inside of this stuff. So you get to this state, and I think Rebecca said it, where you're just like, I'm going to push the button, I'm going to push my code to Git, or I'm going to do, and hope it's going to work.
Right.
There's not a lot of guarantee, because even though you probably got it.
Yeah, I ran all this stuff already, and it passed.
Yeah,
so,
using your own tooling.
Yeah, using my own laptop. And then, it's when I'm pushing it that there's a problem.
So is it, I would hazard to guess that you're not running those thousands of lines of GitHub Actions or GitLab YAML on your laptop.
Correct.
You were doing something else.
Right.
Developer magic, whatever.
Well, I'm building, I'm running tests, I'm trying to make sure there aren't problems.
So you've got your own set of tools that are different than what the CI team has provided you.
Apparently, yes.
Right.
It's a black box.
Well, and then I'm channeling then from like the platform side as well. Like, I'll tell you, I'm sorry. So if I'm, maybe I'm that role today, but it turns out that we just moved, from Jenkins. Well, most of the org moved from Jenkins, but we're still a little bit on Jenkins. And then we also had to adopt, GitHub Actions. But then we also bought that other company. Remember the acquisition last year? Well, they were on GitLab, and we haven't moved. So we've got like X number of YAMLs, and they're not all. You can't just say YAML. It's not the same, right?
Vestigial Circle CI.
Oh, yeah. There's some of that floating around. Sure, there's a little bit of everything. So again, very, very challenging. And debugging these things, let me tell you, you think that you understand what's happening because you've put enough like comments inside of your YAML, but it turns out that there's a link to a shell script that has a link to some network service that has. It's just quite a challenge. So thanks for bearing with us, but maybe there's a better way out there. Maybe there's something else we could do. Okay, so now I'm going to switch. I'm going to put on more of a dagger hat for a second and talk about one possible way we could get out of this nightmare state between, that Rebecca and I are both dealing with from two sides. So if you don't know Dagger, open source project that provides kind of a programmable build engine would be one way to think about the Dagger engine. Another way to think about it is that it is a composable kind of runtime. So, like you're used to running things like containers or something like that, that it's on a runtime, like on Docker or Kubernetes. So Dagger is itself a runtime, and it's all driven by an API. So under the hood, there's all these primitives in Dagger that let you work with things that you care about, like containers you might want to build things inside of or produce, directories full of content, artifacts that you're building, files, etc., working with Git repos. So all these kind of building blocks that you might use if you're building software, if you're building a software factory of your own, and it's all in one API. It turns out to be a GraphQL API. If you're interested, come see me after. That image is crazy, is not. Let's try and push the button. I've got to push the button. It says if the...
Push and pray.
It's if your slides are not displaying, it says up here, push the button. So we're pushing the button.
Oh.
And it's in progress. So we push. Oh, okay, cool, thank you. Yeah, I don't know, it just said to push the button, so I'm going to go back and I'm going to...
Push it again, that's what I do.
Oh yeah, push it again.
Just
See
keep
if that
pushing.
fixes it. Is that, so this is like the flip side of push and pray is the resource. Oh, look at that. See? Sometimes you
off,
just got to keep
turn it
pushing
back
until
on.
it works, right? But I mean, you talked about
That's
that
what
too.
I do for a job. That's my career.
So wait a second. When I'm sitting there and Jenkins says that it's like no more resources left because...
Oh my God. Yeah.
Is that a thing?
It's such a thing. I mean, not to speak directly about my job, but I've seen times
Right.
where
Right.
all of us are pushing at the same time, usually 3 p.m. on Thursday. And everything just gets totally crushed and nothing's passing and it's all failing and I'm restarting agents and I'm dumping half of people's workloads and yelling at them gently
Yes.
in a Slack channel.
So it's a challenge. Sometimes we do all push the button several times, and sometimes sometimes I can slow things down. So the idea with the Dagger engine system is that you have this single API, but then we have a set of SDKs in languages that you might already know and love. So like Go or TypeScript or Python or Java or PHP, Elixir. There's a whole bunch of SDKs that let you access this same API. And you can also get to it through the command line, through a shell, and I'll show you that in a little bit. And then everything is executed sandboxed in containers kind of automatically with a really good caching, and it all just kind of just works out of the box. It all operates in a DAG if you're into that sort of thing, into those graphs, and that's how everything works. And then OTel is streaming out of everything automatically. So what you see a little later on the terminal user interface, the TUI, or what you see in our web UI, it's all the same OTel, OpenTelemetry, spraying around there. So, and then you see on the far right side, one other piece that's really important is the community sharing content they're building. So you can take these core primitives and compose them into functions that are then reusable. So I could like take, a directory of source code and a container to execute things in, and pretty soon I've like developed my build process, and I can make that a new thing that other people could use. So you can find tons of things like that in the Daggerverse, and they're all multi-language, right? One person wrote one in Python, another person wrote one in TypeScript or Go or whatever, but because they all have this same API under the hood, I could be writing something in Java, and I can just import, install somebody else's TypeScript module or their Python module. So then as a platform team, you could build a platform and say, oh yeah, front-end folks, encapsulate, please, your knowledge of how the build should go in TypeScript, say.
Right.
And then we'll have another team that likes to use Go, the cloud native team. We have another team that uses Python.
Not to hammer the phrase, but you go from push and pray to plug and play.
Oh, okay. I hadn't thought of that. I'm going to write that down later. So here is a taste of some code. We're going to get into some deep demos here in a second, but here's just a little primer on some code. So this is a new function. If I wrote this and I had this in a Dagger module, this would be a build that doesn't exist in the core API, but it's using things from the core API. So you can see down at the bottom, we ask the DAG for a container from a certain image. We want to load a certain image, the Nginx image, and then add a directory of content to it and expose a port. And now you've just built a web service, say. Up above, you can see I'm referencing another function off screen called build-env. And the build environment might have like, something that loads up all the node dependencies and then builds them extracts the directory with the built website. How does that work again? Like when you're building web, I don't do front end stuff, but I know that there's tools for things like this. I know there's ways to like build a production website, pack it up or something like that.
Webpack, Vite, for
Okay,
example.
things like that.
I think we're going to
Webpack.
look at Vite later.
Vite later? Is that okay?
Yeah,
I
I
don't
think it's
I
a
don't quite understand all these things, but I
VU
know
and V, yeah.
Okay, I know maybe Vite. We might see the word Vite, and then she can point it out to me. But we build a website, pull that thing, and stick it into. You could see the site down there in the lower right. So it's like a multi-stage Docker build, if you're familiar with that. Kind of a very similar flavor. So again, really, this is how you would use Dagger to build functions that, in this case, take in a directory full of source code and give out a container. Then if I wanted to call that build function, I could do so right from the CLI. So I could say like Dagger call the build function on my CLI and run it. Or I could then put that into Jenkins or GitLab or Circle CI or GitHub Actions so that now I have a way for Becca or any front engineer could like run Dagger build, even stick that in your package JSON, I guess.
In TypeScript, which I like.
Yeah, you could even run that, exactly. And then I could also have it running in CI. So now, instead of us having works on my laptop but not in CI because they're two completely different things happening, here is like the same things happening in both places, so it works in both places. All right, so that would, we saw what we're calling it on the command line looks like. And then down below, you can see if you just call Dagger on its own, you get a Dagger shell. It's like a REPL, a shell you can work with and you can play in. So once you've loaded up a module in the REPL, you can start calling those functions there too. So I can call build, and I can start chaining the functions. That little pipe operator, very much like a bash kind of an homage, right? So I could say build and then pipe it to up to bring up a running service. Or build gives us a container. I can also get a terminal into that container. Build I could publish that container to a registry. You get the kind of the flavor of that. So let's actually show that now in action, right? Enough slides for a minute? Okay, I'll show it in action now. So to do that, I'm going to switch over here to a project that I have running. Oh, it's actually running. Okay, I'm going to stop this right now. And then we're going to take a look first at the code, so you can see that there's something really here. And okay, there's that word I think you were talking about. Here we go. So
Vite, I spotted it.
Yeah, you saw Vite. Okay, so this is a let's look in the source directory. This is a Vue app. Yep. Is that right? So okay, React, Vue, these TypeScript, JavaScript frameworks. There's a lot of them out there. Okay, so this is a Vue app, and so none of this is Dagger that we're seeing here. This is just this app that's a website app. But in here, I've also Daggerized this project. So, much like when you want to take a project that you have and then you want to be able to automate things about it, like its builds, its tests, its deployments, or whatever. So we've actually run in this thing, Dagger init, and then I gave it an SDK. So in this case, I said the SDK equals TypeScript, but I could have said in here just as well Go or Python or whatever SDK I want to use. This one's already been initialized, and you can tell that because it's got a Dagger JSON in here. And you can see that this is written in TypeScript. Okay. So where is the implementation? Well, it's in that .dagger directory. And in there's actually, let's look in the .dagger directory. This is the kind of the structure of it. There's a source with the index HTML or index.typescript in it. So let's take a look at that inside of the .dagger directory. Cool. All right, so this is some Dagger code in TypeScript, and this is going to look very similar to what we had on the slide a second ago. On that slide, we had something that said we were going to use this build environment, and let me make this a little prettier. There we go. So we were going to get this build environment, switches down below, and we were going to run like that, and we were going to run, execute a build, an npm run build inside, and then we were going to extract one directory out of there and store that into the build variable here, and then we're going to start a new container, and we're going to get build going right there. So for folks that want to see that other piece of code, here's the build environment at the bottom. Again, it takes in a directory full of source code, gives out a container. The way it works is it sets up some caching for the node modules we're going to get from npm install, and it uses a certain image, a node image, so it can load all those things up. So this is just kind of like showing you what's in this module. There's also a test function that runs npm run test, so kind of like our way we want to do tests. And then up here, it's got a publish, which is publishing, in this case, to some ephemeral image registry, ttl.sh. It's like pushing to Docker Hub or ECR or GCR or GAR or whatever. So this is cool, but let's actually like use this thing. So this is how I would use it. I'm in this project. It's been Daggerized. And if you're interested, you can go to Dagger's doc site and look at the quick start, and this is essentially what the quick start exercise is. But I'm going to run Dagger here, which will throw us into the Dagger shell. So now I'm in the Dagger shell, and I can start tabbing and saying, hey, what's available in here? So you can see there's a bunch of core types, like a container, directory, Git, so forth. But there's also functions that we saw from the code a second ago, like build. So I'm going to run build here, and it's going to do all the things we saw in the build. So if I go up here, I can say, oh, okay, let's actually increase the verbosity a little bit. These are all the sorts of the things that happen inside of this build. And you can see cached on a lot of the things on the right. That's because anything that can be cached is automatically cached, so you don't have to run it again and waste time and resources. Okay, so that's looking good. So now that I've run this, let's actually run the build again, but let's bring it up. So what this is doing, it's built the website, which it was able to build really fast because it's in the cache. And now it started a tunnel locally to localhost 80. And here's the website. This is apparently
Very complicated.
It's very complicated. And
Lot
look at that, it's got a clicky button. That's pretty cool, right? Okay, so that's the website. So, and it turns out, Control-C that, and it turns out that this build, actually, remember, right now I'm taking in a default source, the source code that was right in the directory. But I could also specify some other source code here as well. So I could say, hey, actually, as the source, give me from GitHub, this is called hello Dagger TypeScript, and I want to get it from a slightly different branch than the main branch. So I want to build it from this other branch called the green branch. Aha, okay, and I want to bring that up. Let's see what's happening there. Let's quit in case might have too many services trying to run on port 80 here. Let's try that again. There we go. And let's go to that one. Reload. Oh, check it out. I'm on the green branch.
Ooh la la.
Yeah, the green branch has got some very big improvements, like a giant green button. So
That'll take 1 week for me to make. I'm sorry. I have to wait.
hey, you got to set your boundaries, you know. So this kind of gives you a little bit of like a sense of, right, you know, how you could work with the functions that are inside of this module. Now, the other kind of the cool thing is that you can, because of the caching, it's really fun to iterate this way. So I could say, like I said, I could say build, and then I can, you know, actually get a terminal inside of that as well. So I'm in a terminal inside of the built container. So now I can say like, oh, show me what the, you know, Etsy, Nginx, nginx.conf looks like in this container, for example, right? Other things I could do is I could also publish this container, you know, as an image, for example. So these are, and the reason I can do that is if I hit tab, all of these are functions that are available for the container type. Everything's like really strictly typed. So I can do any of these things, including getting a terminal, publishing. I could also say something like, you know, give me with a new file or something like that, and add in a file. So you can see this chaining is what works really well for doing builds or for a number of other things. So now that we've kind of got that foundation, and this could be just kind of for fun, you can also use, we're using this local module that you just saw there, but I could also do something like this. So I could say, like, let's bring up this site that we have, our green site, and then let's go over here and let's like actually share this site with all of you. So I'm going to run ngrok. Anyone run that at all? So ngrok, just for folks that haven't used it, it's just kind of a fun way of sharing something like that. So I'm going to have all of you, if you're interested, I'm going to throw up a QR code here in a second, and then you can use ngrok to connect to my local machine and see what I'm seeing. Anyway, it's kind of a fun thing. So I'm going to take this like one-time address it's giving me here. I need some way to transmit it to all of you. And so to make that easy on myself, I'm going to use another module I wrote that's called my QR module. And this is one, instead of in TypeScript, I wrote this one in Python. And it was like, it's a very, very simple little module. All it does is it generates a QR code. Basically, if it's supposed to be a QR, a part of it's supposed to be there, it makes this little ASCII bit. And so let's just try it. So I'm going to run this module. You can see it actually works because I did it before. But we're going to run, I'm inside of the QR module. I'm going to use the generate ASCII QR function that it has, and I'm going to put in this URL. And so this is going to run, and this is going to generate a QR code. So I'm going to see, and any of you that want to see could look at this as well, see if it actually comes up. There we go. You can do it from here. You might have to say, visit the site. I visit the site. I've got a Dagger site with a green button. So you're getting that off of my machine. But it's just kind of like it's kind of fun to see that. And if we go back over here to here, you can see where all the people that wanted to connect here, those are the folks that all connected in and grabbed these assets down there. So it's kind of a fun way. And what it's showing is that I can run modules in different ways. I can use a module, and actually I could run that just straight from the command line without having Python installed or without having whatever that SDK language that I have. I don't need to have any TypeScript on my machine. I don't need to have that runtime myself, because Dagger provides a containerized runtime to run all this stuff in. So then, cool. So we've shown some stuff that's pretty useful for CI. You could imagine doing builds, and you could imagine doing tests and a number of other things. And we got to see Dagger Shell doing that stuff. But it turns out there was some new stuff that we talked about. These LLMs and AI and assistants, and I don't know if you ever seen it.
Should I describe the problem that I wanted you to solve for me?
Please.
Okay. So I'm trying to wrap my head around how all of this works, because conceptually I'm still, trying to figure out how it works. So I watched a bunch of demos of how they're injecting LLMs into Dagger, and came up with a very simple concept, which was to save me from having to write end-to-end tests based on a GitHub diff. So I made a diff. There's a difference between branch A and branch B. I would have to write a test for that typically, but why not have an AI agent write it for me and then poop it out, and then I just throw it up in the project, and boom, I'm done.
Right.
Wouldn't that be great?
Yeah, get yourself an intern, right?
Basically, yeah.
Who could help you with this.
Right.
So cool. So in the same vein of what we saw already, and you maybe saw the LLM primitive kind of float by when I was in the shell earlier, we do have a new primitive in Dagger that is for connecting LLMs into your software. And so kind of like you see in the lower right there, our approach was rather than have to say like, oh, I'm just going to go pay a subscription to some big, LLM company that has their, and they give me an app for accessing it. I'm going to use Claude Desktop, or I'm going to use some, special thing from OpenAI.
Well, yeah, we've got like 5 co-pilots already at work.
Okay, so you got a bunch of
Very, very different ones, and they output different things, and they're loaded with limited information and maybe aren't so easy to use. And I'm a control freak. I want to be able to control it all, and it just kind of feels, again, like that black box. I'm just throwing questions at it and getting back sometimes useful, very useful responses.
But you'd like to take some control of this. You'd like to be able to use the LLM as a primitive, as another piece of the API, versus you having to go and ask it for stuff.
Right.
Yeah. So that was kind of our idea too. We think it's a powerful primitive, but we want you to be able to have control to build your own software with it. So to give you a little flavor of what it looks like, we're still, I think, in this project. And so let's go here, and let's just see if we have LLM available here. I'm going to see if I have LLM. Actually, I'm going to actually, because it's more fun, we've got like this other branch of it over here. So to start out, I'm going to show you really quick just like how this works in practice so that you can get a feel for it. So we have this primitive called LLM, and I've got it hooked up to 1Password here so I can get my API token in there. And my LLM is, it's GPT-4o right now is what I'm connected to, but you could connect to any kind of open source LLM that you might have. It could be a local one like an Olama. It could be, whatever you want to use. And to your point, Rebecca, it can be good to have different LLMs that are that are good at coding, or good at reasoning, or good at composing text, right? That sort of thing. And you could orchestrate those together. So in this case, I've got this LLM, and the magic that we have with Dagger right now is you could actually say, hey, LLM, I'm going to hand you something to work with. I'm going to give you something to work with. And in this case, I could say, it could be very simple. I could say, like, hey, LLM, I'm going to give you a prompt, right? And so in this prompt, I could say, like, what color is the sky in Pasadena, right? And so this is going to send to the LLM this query. I'm getting this back from the LLM. And so this is like a pretty cool, this is kind of a very nice, tool, but we're doing this already in ChatGPT or anywhere else that you're doing this, right? So what's really innovative is the idea is if we could get in a conversation working on some kind of a goal together, if we get into an LLM agent loop. And so that's essentially what we're going to do now. So in this, I'm going to give you just a quick view into this. In this software, we've got a little place for the LLM to work so that it doesn't break everything. Remember, we want to keep things boxed up in containers and with a limited set of things the LLM's able to do that work in our direction, not just randomly. So here we're going to give it a container to work in. We're actually going to make this first example, kind of the lead up to Rebecca's desire, is to first be a real junior Go programmer. So in this case, we've got a Golang image here, and we've got 3 functions. This is all we're going to allow the LLM to use. And when we connect that LLM brain to this body, to this piece of software that we've written, we're going to essentially give it this workspace that has this container, and it has a build function where it can just run go build to see if the software it's writing works. It can write a single file to the container and kind of clobber the old container state, or it can read a file to kind of look around. That's it. So if we give it that, and then I load up Dagger again, and you'll notice that that was called Go program was the name of that function. So now I can give it an assignment like write me a curl clone, for example. And so what's going to actually happen here is we're going to fire up an LLM instance. We're going to attach this toy workspace, and we're going to have it go in a loop and have it try and create this, accomplish the assignment, essentially. And I'm going to actually, while this is running, I'm going to go to the web, and this is going to be, remember I said all the open telemetry that was streaming up, but we saw some on the terminal user interface. This same stuff is coming up here on this web interface. And we gave it a real pep talk. We told it was an expert Go programmer, and we told it to do this assignment, and once it builds, it should let us know about it. And here is what it wrote as its Go program. Got a cool Go program, might work. And it tried to run it with Go build. It didn't work. It figured out why it didn't work, and it needed a go.mod. It did that, and it's like, hey, I did it. Here's the thing I did. So, and using the same kind of primitives that we had before, I should be able to now go in and run the same thing over, right out of the cache, jump into a terminal, and look around. And then sure enough, there's the assignment I gave it, write me a curl clone, and here's the code it wrote. And then I could say something like go build, similar to what it did to make sure things actually worked. And now I can see if this program it wrote, which is called curl clone, actually works. And they want it, we'll even get a fancy flag here for it. And I can say like that, boom. So there, that like worked. It wrote a piece of software, and the magic of this was that I just had it run in a loop until it was done. So we showed you the workspace it worked in. This is what it actually did. So when I actually ran this Go program, I gave it an assignment, and then it started up an LLM, just like we saw in the shell, and it got itself a toy workspace with that assignment and the pep talk. And we basically said, just keep going in a loop until you're done, and then give me back your results. So that's what you just saw. So now, to like Rebecca's point, what if we want to do something a little bit more ambitious? So in this case, what we're doing, you're like, bring it up.
I don't know if it's more ambitious, but
Okay.
directly useful to me at my job.
It would be useful in your job, okay. So maybe it's just the same. So here we've got a similar setup, but I've given it some slightly different tools, and we'll see if we can see the difference. So here I've actually got this function that I called Cypress Test Update. So we saw earlier we had the regular white button, boring, and the green button. Very exciting, right?
Very
yeah.
pretty.
And that we see is in that project. And you see here, I'm not giving it a local directory. I could give it a local directory of content, but I'm actually pointing it at Git. And I'm saying, hey, grab this thing and pull it in. And luckily, we have some caching working in our favor. Oh, it needs a little key to get something as well. And now we've got some instructions for it to kind of run some tests. And let's see it do it. So it actually ran the first Cypress test to make sure that there was just the words, hello from Dagger in there. And now it's actually writing a test on its own. It's writing a new test, and we'll see if it actually works. And it's going to try and run both of the tests and see if they both still work. And so it looks like it's running the button style test that it made.
Might be better at naming files than I am.
And now it's got, it made a mistake. It didn't quite work. And it's like, oh, here, why don't you try and write it? Attempt this. Wait, it gave up? Well, maybe. Sometimes it does. And sometimes
it's only temporary execution error.
Ah, okay. Well, sometimes you want it to give up because sometimes, you don't want to just like burn all your tokens and waste all your money. And then sometimes you don't want it to give up. So actually, I have cooking show-like. I have one instance here where it actually was, actually successful. And this is the curl clone. This is it writing a Cypress test update. And in this Cypress test update, you could see that it wrote a new test here, this button style test. And this one looks pretty simple. Let's see if we can actually get that guy to go, and then we'll actually jump in and look at it. So we'll run this again. More fingers crossed.
Now it's like a real engineer.
Do
it again.
Do it again. It's like earlier. It's like just keep pushing to get, see if it works. And then again, we can see this all happening. And actually, I'm going to increase the verbosity on this thing so we can see all this stuff happening. And you can actually get really verbose in the TUI as well and get like a lot of information. Let's actually resize that a little bit. Okay, round two. Round two. How do we feel? This one, it's spec test passed. Okay, there it is. Look at that. The wonder of, this is where you clap. The wonder, thank you. Thank you. It was a good effort. There we go. Thank you very much. So here it successfully created a Cypress end-to-end test to ensure the button in the application has green button class and styling appropriate and so forth. So like, let's see, like, okay, again, it's this whole question of, okay, did you do it, right? So now we're going to actually look inside of this container that it was working inside of, and we're actually going to put that to bash. We'll take a look. So inside of this Cypress directory, there is an end-to-end directory in there. And oh, sure enough, in the original project, there's just this one Cypress test that says it should say hello from Dagger. And then this one, it actually creates a new test called button change. And this is the test that it created, right? So again, this works well because just like we saw when we were building up Dagger containers where we could like create a container, add a new directory into it, and that became something that we could then bring up as a service or publish or whatever. In the same way here, we could give a workspace container to an LLM and have it go back and forth and add files or directories onto here and execute commands until we got it to work. So this system that was really good for builds can also be really good for things like LLM agents, you know, AI agents. If you're at all curious about kind of how that all works, then you can just, we can take a peek really quick in here. And again, it's going to look very, very similar. The workspace that you saw, instead of it being in Go this time, it's in TypeScript. And whether you like that more or less is a personal preference. But you could see here really simply, we brought in that project, that Hello Dagger project. We were interested in a base branch and a feature branch, so our main and our green. And then we used this fully loaded Cypress image that gave us all the Cypress tools we might need. Did a bunch of stuff, installed some other things in the container we needed for dev. And then what did we let it do? Well, we gave it a few functions also. We said, hey, you can read a file. You can write a file. And you can look around. Yeah, you can just basically, you can, and to look around, we said you can run the find command in the Cypress directory. So I'm like, I don't want you to look at the whole project. Just look in there where you're supposed to be doing your work. And then I gave it a test that it could run. That was it, essentially to run that little end-to-end test, something that's in the package JSON. Yeah. So yeah, to wrap up, to go back to the slides for just a second, and to kind of wrap up. Yeah, yeah. Oh, we'll grab a microphone for you. That'd be amazing. That way it gets on the recording for everybody.
Thanks. Hello? Okay. So I have a two-part question in having to do with testing. So when you write, when you run the CI and you're doing a test in CI, they usually, what you usually do is you publish it to like a JUnit format so that it could take the results and put it in the, and put it in, you know, as part of the code review.
Yes.
So the thing is, but if I'm running that pipe, you know, running the Dagger within on my terminal locally, I want it to come as pretty, you know, say on my screen.
Right.
So my thing is there a way, one in the function to say, well, if you're running in the CI, do create the file, and then, but if I'm running it locally, do this. And then the second part is, because I think you said that each, like the functions run within a container, so how does the file get outputted so that the CI can pick it up?
Yeah, that's great
publish
questions.
it?
Yeah, great question. So the way you could think about it is these are just functions, and it's just code, and it's just programming. So you can use if statements, you could use a case statement, you can use a for loop, you can use any of those constructs because it's just code at the end of the day. And you can also do things like you could say, oh, I'm going to upload this thing, like a JUnit, XML, or whatever. I can upload it to some kind of an artifact store, right? Because it's got networking as well. Right. So you can, anything you might want to do, you can also create, you could create, say, a custom type that is something that you output that's your test result type. And your test result type has, you know, exactly what you need to pass on to the next stage of things.
Couldn't you just make a PR and get with the new file?
Oh, absolutely, yeah. If it was something like, say you were trying to create a new test like that, then you could also, yeah, have that get into Git. You could output that from here into a separate directory. Again, that could be something you could upload and share and so forth. So yeah, super flexible just because it's all just code. So you can do anything. Yeah, great question. Other questions? Yeah, one up front here.
Our CI guy.
Yes.
Can you programmatically customize the container tags?
So yes. So kind of an example of that could be something like this. So say if you're going to be publishing containers. Yeah, so in this example that we had over here, where I was in my hello Dagger, in my .dagger source. So here you could see in my publish, I was actually generating a new, a new name for this image. Now that could be colon whatever, it could be the tag. So yeah, again, it's just code, and so you have all the abilities that you have. And in fact, you can, since it's just code, you can also import anything you want. So say you have, a particular like library that's like important to you. It's like maybe there's some kind of like cool like Semver library or some kind of like whatever you want to use. It's just code, so you can use any of that in there, mix and match. Yeah, any other questions?
Yes.
Awesome.
All right, get my steps in.
So the LLM stuff is interesting for sure, and the container workflow versus like a Docker file seems much faster. For the replacement in CI/CD, where you drop in, Dagger instead of writing a big pipeline YAML for
Yes.
GitLab or something, how is that different than just like bash and make?
Totally, yeah. So so there's I think bash and make are classics for a good reason, right? Because you get a DAG, very similar, you get a graph. You get build targets, you get targets like could be build or test or, whatever, CI or whatever you want to name your targets. And you also get a lot of baggage, unfortunately, still, because, if you've written a lot of make files and you get all these phonies in there and all this and that. I mean, there are things about writing make files that are not delightful and intuitive for everyone. So the idea here is that the whole team, no matter what language you're familiar with or use, you could get involved and write Dagger and share it and use it together. That's also kind of speaks to the bash thing. Even though bash is really pretty universal and awesome, again, a lot of teams, there's like maybe a bash guru or, that kind of thing, and it's not necessarily the case that everyone in the team is going to bust out some awesome bash and get the fine points like, oh yeah, I got that bash array perfect, or I got this, you start like messing around with that. You also don't have type safety in bash. And so one of the really nice things is because it's all fully type safe, so I can go into here and I can be writing something and say, oh yeah, give me DAG from this dot, check it out. These are all the things that are available on a container type, right? So it's all fully typed, so I can say, oh yeah, I say like, I want to say with new file, boom. And then I'm just, so it makes it really, really easy to use in your IDE, which means that anyone on the team who knows the language, has an IDE hooked up, they don't even have to know the Dagger API very well. It's very intuitive. It just kind of starts working for them. So a couple of reasons why, for some teams, using something like Dagger and their own languages and this API, common API, might be better for them than Makefiles and Bash. But your mileage may vary, and Bash is awesome. Anybody else? Any other questions? Did that answer your question, more or less? Okay, thank you.
Let's say I'm part of a platform team and there's like 5 different TypeScript applications. They're similar where they have to test and push to a container registry. Would I have to do a Dagger init for every single project, or is there a way to kind of package this template?
Yeah, that's a great question. So a lot of people like a monorepo pattern. So if you wanted, do you have that? Do you have like a monorepo with all those projects inside, or are they separate?
Just separate repos, and I kind of want to inherit this pattern of testing and deploying it.
Yeah.
And I don't want to copy and paste this into every single repo. How would I do this with Dagger?
Totally, yeah. So I think, a good pattern is the one kind of like we saw here. So like, for example, I could say, say I go into the Dagger shell without any particular module in place. What you can do is, you could, I think this would actually be an even better way of doing it than I think about. So like, remember we were inside of this particular project, and this is that Hello Dagger project. They gave us the white button and the green button to push. So if I open up a shell in here, we had some functions, like we had a build function. And that build function was actually super reusable. The code for that was like pretty general for a certain class of project. And of course, you could have conditional statements inside of there so they could handle like all your projects. And it could be like, that build is your TypeScript build. And that is at the company, it's enshrined, this is what we use here at the company or in our group for our builds. And you can do things like, you can give it different inputs. So you could have one place where you have, there's the build function, and then since it took source code as an argument, it could be that instead of living inside of one project, this module could live outside as its own project. And then right there, it could take as inputs the Git directory of your different projects. So like, for example, here, we saw, like if I say build, build, and then I put in here, say, it could be a local directory, or it could be, in this case, I wanted to go to like github.com, there's a Dagger, hello Dagger. It's a totally different project, right? So I could have it go to, zero positional arguments. Let's go do that again. Let's build that again with the source being that. So now it's actually reaching out across the internet to GitHub, to this other project. It's not the one I built earlier. It's the one that we use actually in the quick start. And it just pulled that in, and it's going to try and run the same build function I was using for this other project on it. So this is like part of the power is that, and you could have this build function itself can be in GitHub, and you can say something like this. You can say, Dagger, I'm going to use this other notation. You can say like, Dagger, use this module, the one I've been using, right? Hello Dagger TypeScript. Use that module and then call the build function, but give it the source code of Dagger, hello Dagger, right? So this is now, I've got Dagger, I don't have TypeScript, I don't have anything. It is going out, it's grabbing a module that has these functions, these capabilities, then it's giving it another thing as input all off the internet without, so like you can just have a developer on their laptop run that. All they need to have would be Dagger, the ability to run Dagger, and they could run this same thing without having any of those tools locally. So that's how, and being able to then jump into that and say, look, you just built the project, grab a terminal, now I can jump into the project, inspect it, or I could get a local dev, very much like a Docker compose situation or Docker run situation. I could jump inside of this thing and look around. So yeah, that's, as a centralized team, you can maintain those centralized functions that could be used across. Other questions? These are great questions, by the way. So what do we think? Do we think that now that we've I think we've converted some people here. So if these folks just Daggerize a couple things and tell 10 people, or I think we'll be good. I think.
Yeah, definitely.
Yeah, I think we'll be good. So yeah, one more question. Oh yeah, so the question was, how do we plug in your own models, going back to kind of the LLM piece. So I would encourage everybody to do this as soon as possible. Go to Dagger.io. The very first thing you need to do is go up here and click on Discord. The only reason I plug Discord so much is that's where we're all at. So if you saw Solomon's talk earlier, this is me like talking to Solomon, or if you know, whatever, you wanna like jump in here because this is like where all the action is happening. So definitely like jump in there and everyone's talking about everything that's happening in Dagger. But also jump into the docs. So in the docs, you'll see whether your interest is more in the CI piece, you can take the quick start and kind of do the things we were doing, or you can go in this agents thing, and you'll see there's like information here and some of the different things that I showed off, like the Cypress one and the toy programmer here. We will add in more and more docs in here soon, but for LLM endpoints, you can put in, you know, we have support right now for a bunch of them, so you can add your API keys for like OpenAI, Anthropic. I think Gemini support is coming. I think we just shipped it maybe. And if you want to use local models, like with Olama, you can do that as well. And yeah, it's like a simple config file or environment variables you can use, and it'll just get picked up and go from there. So yeah, in my case, I'm using OpenAI in mine, and I think in mine I'm using OpenAI, and I'm also over here, let me just quit out of here for a second. I think, actually in the other project that we were just in. Thanks for bearing with me, because this is the LLM powered one. So I've got this .m file. I hope I don't have a key in here. No, I don't have a key. But what I have is I've got a reference to my 1Password account. And so we also have like built in like 1Password and Hashi Vault support. So you can just put like a reference to a key. Mine happens to be in my 1Password. And so when I run this and bring up, you probably saw before, but if I run this and then run, you know, LLM or something like that, then it's asking for my password now, for my key to the LLM, and I could give it to it. So yeah, it's pretty easy to kind of hook up any LLMs that you want, and we're going to have more examples about multi-LLM, multi-model flows as well soon. Other questions? I think we're just about, we still got 5 minutes in case there are, but who's going to try Dagger? Yay! Okay, awesome. Yeah, definitely join Discord. I'm in there, Jeremy Adams. Just I don't have a fancy handle, but I'm just Jeremy Adams. I'm there, and so is the whole team. So we'd love to help you with whatever you want to build. And there's a whole community of other folks that are like-minded and building stuff right now in there. So see you soon. Thank you so much. Really appreciate it. Thank you. Nice. Oh, wow.
Check, 1, 2.
That seems like a, but that seems like such a, no, he didn't. Yeah, but that seems like a very modest ask we could make staff.
Check, 1, 2.
We were talking last night about like how we've been partnering with like Stanford and community technical colleges and the workforce force and things.
I feel like that's a very modest ask for us to make though, like from the state. And it kind of makes more sense for the state to be funding it than industry longer term.
Right. That was, so I don't indicate industry, that's what it used to
Right.
be. You're sponsoring the reception.
Yeah.
So.
Yeah. Should we bring up another?
It's good to have a little bit of everything. Our class, everyone's like, we have 3 streams, so if one of them goes away, the other 2 will get us through if we put all our eggs in one basket. You know, you gotta diversify.
I know, I bet in the very beginning, well, houses are really industry funded, and then after a while, it's like, we need to diversify people. I need people who might pay my mortgage in a downturn.
I think they want us to take here because it's recorded. It's like live stream. This is cool.
I know. I saw that in another room the other day. I was like, oh, that's really neat.
Yeah,
I didn't notice that they were like custom.
Yeah, it's like custom laser cut
that's cool.
computer case. That's neat. Yeah, everything here is like entirely done by volunteers. It's pretty cool.
Very cool. Yeah. Did you by any chance include? I don't know about the Pinterest group on the slide or anything?
There's a QR code. I need to check if it still works. Last time it didn't work.
There should now. I set the Discord invite to be infinite now.
Okay.
But I don't
know which one is on the slide. I can edit it really quickly.
But I was just wondering, yeah, if there's a way to point people there who might be interested in joining the call.
It goes to the link tree.
Let me see if I can modify that.
Okay. It's got a link to the Discord server. It's not the top one, but it's got the top one's the UC Osco.
I can't remember what I made the link to. Was that for Fossey?
I'm not sure.
Does it have Kendall on it?
It does have Kendall. It also has Jonathan, who's not here, but Kendall is on it.
I'll see if I can edit it.
Hello. Wait, are they? How did I not notice you the entire day?
I mean, I've been sitting there for several hours, so I'm not sure. But I could have done more to like actually wait to get.
Yeah. Cool. They record it. So
Yeah, it's like, oh yeah, there it is. Yeah, the other day we had a panel and we set up on the floor and we made them move the and I don't think they liked that. But it was the last session of the day, so it's not like they had to move it back.
Yeah, afterwards.
Still, yeah, not immediately. Yeah.
Yeah. Well, let's try to fit 5 people on the stage.
Yeah. We have to snuggle. We almost have to go eat.
Testing?
Yep.
So this is working.
Yeah, if you can get it in the next
If it's
5
easy,
minutes, yeah.
yeah.
Test, test, test. Yeah, we can use this one too.
Yeah, like if you want to sit down, you can grab another chair off the floor. Oh, it's SCaLE A.
Is this actually the title of our talk or the title of our
Nope, I don't think so.
It's Mentorship is an on-ramp to open source.
That one. We're updating the slides on the fly. I love it.
Yeah, I'm trying to update the link through too. Teamwork. Teamwork.
Ain't no minute like the last minute. It's so good. Yep. To match the schedule. Hello.
Oh, okay. Okay. Yeah, thank you so much. I appreciate that.
It's funny how password management is like one of the hardest things.
Sometimes it fails.
That's a good little notebook. That's a good little notebook. Is it one of the rodeo ones? Oh yeah, yeah. Oh, it's a good brand.
They're gonna bring.
Yeah.
Cool.
Cool. Okay.
Hello, everyone. I think we still have a minute. Thanks everyone for coming. So this is Mentorship as an on-ramp to open source contributions. Yeah, we're really excited to have everyone here. I will quickly introduce myself and then I'll have everyone go down and introduce themselves. My name's Tyler. I am the CEO of the nonprofit Code Day, and we focus on helping students get experience in making their first open source contributions. We have like a 1 month, 1 month long, basically 3 weeks of really serious work on good first issue style issues. And through that work, I've been really lucky to meet Kevin, Kendall, and Emily. So I'll let them introduce themselves and a little bit about their program.
Hi, my name is Kevin Wang, and I'm the founder of the Mentors in Tech program. We help students from overlooked and underserved community colleges, and usually those students are attending schools that are less well known but affordable and accessible, and they're usually pivoting into a career in tech from something else, and so we help them with career navigation, embedded capstones in their classes in open source, and also we work with employers to help them understand the unique strengths and backgrounds of our students and help them hire our students.
Hi, everyone. I am Kendall Nelson. I'm a senior upstream developer advocate at the Open Infrastructure Foundation. So we're a nonprofit that hosts open source projects focused on infrastructure. You may have guessed it from the name. Very original. But what I do is facilitate relationships between a variety of universities inside the United States and slowly growing the numbers outside the United States to get open source projects in front of students while they're in university. Ooh, that was fun. That was fun. And so we find projects in our open source communities for students to work on, and then I coordinate with the professors to have students work on them for a semester or as an internship. Lots of different things, lots of flexibility, lots of fun.
Hi everyone, my name's Emily Lovell. I'm a postdoctoral fellow at UC Santa Cruz in our open source program office. So we are one of a small but growing cohort of academic OSPOs figuring out what's useful to all the different functions that we can serve to the folks on our campus who are interested in open source or already doing open source work. Our office does a lot to support student interest in open source, and my background is in teaching computer science. I've taught open source courses before coming to UCSC. And in particular, right now, we have 2 summer mentorship programs that run in parallel. Two types of open source mentorship programs, I would say, that run in parallel. One is modeled on the Google Summer of Code, or GSOC model, where we have many remote contributors, new contributors from all around the world working on academic open source research projects. So it's pretty cool that they're getting hands-on experience with open source and also academic research. And then the second, and that one is largely coordinated by Stephanie Ligi, who's our executive director. She's in the audience. We also have a newer program that we're about to go into year 3, in which we host students from historically Black colleges and universities to make their first contribution to open source software. That's a program that I lead that runs as an 8-week summer program that's 50% in person and 50% remote. We work with a specific small cohort of HBCUs to bring their students to our campus and work together, and then contribute to external open source projects once they learn the basic skills and tools to do that. Yeah, I think that's it.
Cool, thank you. So the first question I have is just on the purpose of mentorship in general. I think as many of us have experienced, there's a lot of great resources out there online. Even now with ChatGPT, there's lots of ways that you can learn on your own. What is the importance of mentorship? Why do we do mentorship programs at all?
So I'll start. I think a lot of open source communities are vast, and there's a lot that is not written into the documentation. There's a lot of tribal knowledge, and knowing somebody and having a person there to ask your questions to instead of the entire community, which can be very daunting for people, whether English is their first language or not. Having that extra little bit of support can be really, really invaluable, especially when you're uncomfortable, you're new to it. So having a mentor is really what makes it work, I think, a lot of the time.
I would add also just like for us, and I think the same is true for Kevin, like we work with a lot of these schools where the students are non-traditional backgrounds in tech in a lot of different ways, and it's just really scary for them to do something real, especially with something like contributing to open source. It is actually you're shipping code to a bunch of people, and it's easier for a lot of our students to say, yeah, my skills aren't ready yet, like I'll try this next year or something like that, and having someone there to support you is, even just the having someone there to just give you the thumbs up can be enough to sort of overcome that emotional barrier.
Yeah, I think to just piggyback on that, like through our work, we find just the impact of students seeing somebody like model what it is like to work in a really large code base where you don't understand most of the code, especially initially, and that like it's okay and very normal to be lost, and like how do you find resources, and like how do you figure out who you should talk to, and like then like what do those messages look like? So I think like through mentorship, like our small cohort spend a lot of time like sitting together going like, okay, we're gonna draft our first Slack message to the community together, you know, things like that. And then there's of course just a really big impact of seeing people that look like you and have similar, experiences and identity overlap that I think is also really important for students. And then the last thing I'll say is I think, relating to that first point about seeing what it is like to look lost or realistically work in software, open source software, the feedback I get from students, like every time they meet a like real world open source developer for the first time, is they're just like, oh my gosh, they're just normal people, which I think we all see that in our work, and like, I just don't think it can be overstated, like the actual impact of that on like our next generation of open source contributors, to see that, yeah, they don't, like, I think it's actually very helpful for them to ask, some developer at Google who's contributing to open source how to do something and see that person say, I have no idea. Like, that's really important and powerful for them.
There is so much unspoken things about the software development process. You can read all the books on software engineering, but if you put that person in a software engineering process, they probably will not do well. So that's why internships exist. That's why all of these things that companies do exist. How does the process work end to end, how they're connected? What are some norms and expectations that are completely unspoken that you get from, quote unquote, the water cooler? Professional skills, things like, if you want to have a meeting, you should probably go talk to them, like use calendaring software, right? Find a time that's acceptable to everyone. Hit accept if you get, like there's tons and tons of these things that are not taught in schools, and it's not in software engineering, software engineering books. It's not taught anywhere. You only learn it when you're actually in it. How do you ask questions in the right way so that it's the most productive way to ask a question, and not have people, seeing, things like, wow, this, and still want to work with you in a nice way, right? Get to where you want to get to. How do you say no also? So how do you say no in a productive? That's really true for entry-level folks. They don't know because the power structure and, management, all that stuff. They don't know how to say no in a way that's productive, or maybe they're overloaded, or how do you ask for help, right? So all of these things, you need a mentor in these very particular situations to help you in software development, in your career. These are all super important things that if we want more people to be involved in open source software development, that the newer contributors will all need to have to keep the ecosystem healthy, and also, for all of these projects to thrive.
Yeah, and just speaking of unspoken things, I remember we're all here at this conference today, and like we try to bring students to conferences a lot. And I remember recently, like one of our students went to a conference for his first conference, and afterward he was like, I was surprised that people made jokes there. It's one of those things that is like so completely obvious to us that like, this is just fun and it's a social thing, and like people don't know things like that, and how many of those issues come up in other places. I think, Kevin, for you and I, for our students, I think calendar software is probably the biggest one. But yeah, a lot of those are definitely ring true. So, that's the kind of, talking a lot about the importance of mentoring in general. What makes open source unique as far as tech mentorship, and why are we working in open source? I mean, all of us are passionate about this. Why are we passionate about this?
Yeah, I can start. I am really passionate about engaging students in open source for, I guess, a number of reasons that I'm sure overlap the rest of the panel, but I think an obvious one maybe is that it creates a public portfolio of work for those students, and that seems like increasingly important. Like people are putting their GitHub handles on their CVs or their resumes now, or being asked for those. So I think it's really powerful for students to just have a place to point where someone can go and see like what code they've worked on, you know, what projects they've worked on, the nature of how they communicate with other people professionally, since they're also, you know, all these comments on their pull requests will be public as well, or in Slack channels. So I think that's really important. I think that there's a lot of potential for students to grow their network really rapidly through, again, doing like outward-facing open work. And getting to grow their network to include people who work all different kinds of places that they could learn from or might want to work in the future. And then the last thing I'll say is I think for my students especially, I think about the importance of community and like belonging in computer science. And I think I didn't really feel like I belonged in computer science before I found open source. In finding a place where like community was valued and treating each other with kindness and recognition and appreciation was really valued. So I think that resonates with at least some of my students as well, that particular piece of community and being able to have positive impact on the world.
All of what she said. I 100% agree, but everything from like the direct benefits that students have as a result of being able to point at, I did this thing, this is how I collaborated, to I collaborated with this person that's on the other side of the world, and maybe like our priorities weren't exactly the same, but we were able to work together on an implementation and figure it out. Like, that's a skill that is invaluable and not something that really gets taught in university, especially because a lot of the times you're working in isolation. So open source gives you a like real world experience without having to be backed by a company as an intern or an employee. There's so much opportunity and there's so much diversity within the breadth of open source projects that are available that you're going to find something that you're interested in. Like if you go look, there's going to be something there. And once you find your place in that community, having the network to just continue working in that community but bouncing to different companies, I've seen a lot of that too. So it's like the benefits are endless.
Yeah, I love what you said also about the like finding something that's meaningful to you, right? I think that is one of the really big benefits of open source, and there's a lot of research in humanitarian open source software just showing like if students are doing something that is meaningful to them, that is and meaningful to their community and is making, you know, a positive impact in the world, whatever that means to them, like that is really, really heavily motivating. So I agree. I mean, I think that's super, super unique. We've had students who've, you know, actually as part of people I met at SCaLE last year, we've had students who've shipped some code on NASA projects, and like how cool is that to be able to say that you have code that, you know, is eventually, if not currently, like going to make it to space. Like that's just such a unique opportunity. So yeah, I mean, being able to find a project that's meaningful to you is really super valuable. Kevin?
And in addition to, I think, meaning for a lot of students, a lot of our students from smaller, accessible, affordable colleges have a wide range of backgrounds and expertise and work experience. And so they can find the right project for them that's meaningful to them, big or small, and you know, all of the different variety of projects out there. And also, open source, to be able to work on an open source project, it is not gated by a elite internship from a elite company where software development sometimes is gated by the name brand of the college you go to. And that comes with a lot of implications of a lot of other things. And it helps our students, without having access to those elite institutions, to legitimize the skill set that they have without the brand, you know, without the benefit of having gone to a brand name college or university and show themselves publicly what they're capable of. So I think it's equally about access and you know, one of the few remaining places where students can really demonstrate what they do, whatever the access.
Cool. So to get into a little bit more of the details about how some of these programs work, there's a lot of different programs. I think we all have different ways of doing this, and that's part of why this has been such a successful long-term collaboration, is we all have kind of a different approach, and there's advantages to each. There's also a lot of other great things out there, Outreachy, MLH fellowships, the Linux Foundation has a mentorship program as well. Can you talk just in more detail about each of the programs? How do they work, and just kind of what differentiates your program from all the other ways of doing it?
Yeah, so we are all very different, like you said. So I really represent the open source projects, first and foremost. I have been a contributor to OpenStack since 2015, I think, so about 10 years. But I've also been involved in other open source projects, and so I have that context, and that I know, oh man, I'm getting all in front of myself. So the University Partnership Program is a collaboration from the project standpoint with universities. So our goal is to get open source in general in front of as many students as possible. And so how that works for us has been really organic. Over time, we have been introduced to a number of universities and faculty, and professors that have computer science courses that could be focused on cloud computing or virtual machines specifically, or open source generally. And usually those courses have some sort of semester-long project. And so I go to our open source communities and I find pieces of work that would be good for students to work on. And I also find mentors in our community that are willing to spend a couple hours a week kind of helping them along and making them feel comfortable to be able to get that work done. So they're helping the project. They are accomplishing something that maybe we don't have time to do, but have time to mentor somebody in doing. And yeah, it's gone really well. We've branched out to about a dozen universities in the US now that run different times a year. And we have one university in Seoul that we're starting to work with, so I'm really excited about that and hope to get more universities in Europe. But that's been hard because my context is I went to school in the US, so I know how the US college system works approximately, but it's definitely different in other countries, so that's something that we're working on, but yeah.
Sure, so as I mentioned before, we have essentially two main mentorship tracks that run in the summer through UC Santa Cruz. One is the Open Source Research Experience, or OSRE, and that's the program that's modeled largely after Google Summer of Code, although we do have some in-person students, or students who are local. And we have students work on all different kinds of projects for that. The main theme is that they're academic research projects. So some of them tend to be smaller projects or earlier in their development than maybe, working on like Firefox DevTools or some big project. But students are getting this really unique experience working on academic research. So that's a distinguishing feature of that particular mentorship program. And that program has grown to like 40-some contributors, I think now, each summer that we work with over the past 10 years. No, not that long. I thought it was that long. 2008? Okay, I was going to say, wow, 7 years. Okay, so yeah, we've grown to include 40-some contributors in that program. So that's been quite successful. And some of those students have gone on to mentor in future years. Like contributors have turned into mentors, have turned into PhD students. So that's been like a pretty neat conversion out of that program. And then the other program is called Contributor Catalyst. That's our HBCU-facing program, where we host students from historically Black colleges and universities to work, to come to our campus for 4 weeks and then work together remotely for 4 weeks. And that's really a start from scratch program where they're learning everything about open source tooling and norms and all these unspoken things we're talking about. They make LinkedIn profiles and fill out their GitHub READMEs. And for that program, this is our 3rd year, and we are growing. We started with one HBCU, Norfolk State University, who helped us to design the program to serve sort of their students' prerequisites and needs. And this year we're going to include a second HBCU, Southern University in Louisiana, And then over the next couple years, we'll be expanding to a handful of additional schools. And really that program focuses on like bringing students in small groups from their university, since there's like a lot of just cultural differences between the East Coast and the Southeast, where a lot of HBCUs are concentrated, versus California. We also use peer mentoring in that program, so we have alumni come back and help mentor their peers in future years, which has been really successful. And yeah, those students, they choose what project they want to contribute to, and it's often something that I have no experience with, and I like learn on the fly with them. So it's a big adventure, but we like emphasize like the fun and learning that comes with that. And I do coach them how to sort of make educated guesses at projects that will be welcoming to newcomers, and then establish contacts there. And that program also has yielded some productive outcomes. We are now, we got NSF, National Science Foundation funding to grow that program based on the early pilot success. And those students have gone on to like be on podcasts and speak at conferences and get job offers that they think the program really helped them to secure, and even to do some paid work in open source by invitation. So yeah, small program, but both of those programs have grown well.
And Emily, and I think someone else referenced this earlier, you referenced Google Summer of Code. How many people here are familiar with Google Summer of Code? Okay, so most people. Cool. Yeah, that's great. I think that was probably one of the earliest examples of the sort of programs that we built out, so that's great to see.
Mentors in Tech, what we do is we help students from overlooked and underserved juniors and seniors in smaller, less well-known, but also affordable and accessible, flexible CS programs, navigate the whole tech hiring landscape and help them land their first job. We do that in 3 different ways. One is career mentoring through each student having a couple of industry mentors, and it's super structured, and they have a topic every month that they discuss over the school year, from how tech does hiring to resume and technical interview prep and STAR interviews and everything. So lots and lots of topics to start from the very beginning to help our students understand what that looks like and what they need to do. We also work with Code Day on capstone projects, embedded capstone projects in the classroom. That's open source, where the students get a chance to make significant contributions to an open source project with the help of industry mentors. And lastly, we work with industry folks and companies who we help them understand and recognize the unique backgrounds and strength of our students and think about how they can hire them and meet their talent needs. Majority of the average age of our students is 30. They're usually pivoting from retail work, food and beverage service, the military, mothers coming back from being a stay-at-home mom, rejoining the workforce, and any and everything in between. And we help them understand how the whole, we help them get that incredibly important very first job in tech. So that's what we do. And each one of those things I just mentioned have 90,000 different details and fun stories about how all of these come about and all of the situations we have run into. But it's been thanks to about all of the mentors we have had. We have about 150 industry mentors who are giving time to our students, and we partner with community and technical colleges in Washington State, in California, in New York to serve those students. And usually those students are the farthest away from opportunity. And so, yeah, that's why we do what we do.
Yeah, and I'll sort of speak for Code Day here. With Code Day, we've been working very closely with Mint for many years, and we really work a lot on trying to get students into their first open source contribution. So a lot of the students who do the capstone that we do in collaboration with Mint, or the students who are doing our micro internships, which are these kind of month-long 10 to 20 hour a week experiences doing like a good first issue. They've never done any open source stuff before, and a lot of our students, in fact, have literally never done anything in their entire educational career that they hadn't previously been expected to know from reading a textbook. And so this is the very first time that they are going out and trying to do something that no one knows the answer to, and that's super scary for them because we frequently will get complaints from students who are like, well, I'm not sure what to do, and I asked my mentor, and she doesn't know what to do either. And it's like, well, great, that, that's kind of how it works. That's, none of us are going to be paid, the salaries that programmers are paid if we have someone who knows exactly how to do what we need to do step by step, every step of the way. That, this is what the job is. It's figuring things out. And so, like, for us, a lot of what we've tried to do is build up a program that's focused around teaching students those skills to work independently, and then pass them on to really awesome other programs, or just have them continue to contribute to those communities on their own without quite as much support from us, but hopefully after having those skills, they do that. And one of the reasons actually we work so closely with Mint is because that other stuff that's sort of the non-technical mentoring is equally as important, because a lot of students are leaving our program and they think, well, I spent 4 weeks working on this and I only ended up writing 5 lines of code, so that means I totally failed. And having a mentor that you're familiar with, that you can go back on and reflect on this with, and say, have them say, well, yeah, but sometimes figuring out which 5 lines of code to write and where to write them is actually 95% of the work, and that's what it's like. Having someone who can sort of be that partner with you for that discussion and like reflect on that is kind of a big part of it too. So been really lucky to have almost all of our students are going through Mint as well, and to have that support.
One small anecdote. I totally, I might have been in one of our like meetings and discussions, but I heard that students thought of like the percentage of unit tests that pass and come back. If it's like above a certain threshold, it's okay. Or like in our projects, if it doesn't pass 100% of the tests, it doesn't get merged. And they're like, oh, well, I got like 70%. That's like a C, right? Oh, that's great. That's passing in terms of grades maybe, but not as far as code being merged.
Yeah, that's definitely funny. So actually, on that sort of note, thinking about some of the problems that we face with all of our programs, especially from a student perspective, what are the sort of outstanding problems in getting students involved in open source? And especially if you can share any more anecdotes, I think they're always kind of interesting.
Oh, man. Does anybody else want to go first? I don't. It's a very lengthy list. The number of things I get, well, for students in our programs, they're taking other courses. They're not just taking the one to work on the open source project. And open source project working on an open source project can take up as much time as you're willing to invest in it. So balancing that with like the other courses that they're taking is really difficult for a lot of them, because they'll like be really dedicated for like 2-3 days and then they fall off the face of the map for like 2 weeks because they're focused on other things. Maybe they have projects or finals or whatever, and that's totally understandable, but that does make it really hard to be consistent in building skills and like responding to comments on your patches and getting them updated. But the other thing that we see as being very difficult is like time zones. The world's not flat, apparently. And so when you have students in Doha trying to work with mentors that are in Seattle, that time zone overlap is not great. And the amount of support that the mentors want to be able to offer to the students is like at odds with sleep schedules sometimes. So yeah, that's definitely one that I don't know that we'll ever really have a...
Use the Outlook time zone check.
Yeah, World Time Buddy is like my favorite tool, even as an established contributor, because keeping track of time zones is the worst.
we had like our code day email. We have like an automated email that goes out, and we would always write in it, please specify your time zones when you're available. And then we made it bold, and now it's bold, all uppercase. Yeah.
Yeah.
Time zones are a big problem.
Yeah, that's why we just do everything in UTC, right? Yeah. Everybody loves UTC. Oh yeah, also daylight savings time, and that it happens differently in different continents.
And
or
in different U.S. states.
And in US, yeah, some states. Oh man, I'd love to be Arizona.
The time zone availability is a big one for, sorry, not time zone, the general availability is a big one for a lot of Kevin and my students too. A lot of our students work a second job to pay for schools, to pay for their schooling. A lot of them are caretakers for their family. And so, yeah, I mean, even one of the big advantages to open source, I think, for us is that it's accessible to some extent to those students, because those students who are like a primary caretaker for their family, they can't take a traditional internship. Or if they're working a part-time job and that's how they're paying for their schooling, you know, if they can't quit that for 3 months and then go take an internship and then just go beg for your job back.
Yeah, we literally just talked to at the booth, a UC Berkeley undergraduate who she just graduated, and she had an internship at one of the big tech companies, and she was invited back, but only in person in the Pacific Northwest, but she lives down here. So she had to turn down on that offer and continue to look for jobs here. So she was asking us for advice. So there's tons of that kind of, you know, we talk about how software is used by millions and millions of people and all of that stuff, but when it really comes down to it, it's student by student. Everyone has different circumstances that we need to help them the best way that we can. And the other thing, I think, especially with more students coming in that are beyond digital natives at this point, their life, especially, you know, since the pandemic, has been with things that are on demand, whether it's Netflix or Amazon delivery or Uber Eats or all of those things. Sometimes they forget, even though in open source, in software development, it's a screen, they sometimes forget there's a real human being behind that. So the expectations of how to communicate and collaborate, I think we have to teach even more so and help them understand there's another, even though it's just text like anything else, there's a real person behind that, and how do you collaborate with a real person that is not, you know, click and something happens and sets off a chain of events, that the people you collaborate also has like a life and, you know, have work, family, kids, etc., and things that, you know, that happen. It's sometimes our students forget that because, like anything, they're so used to interacting with a smartphone or something on a desktop and click and you get that instant gratification. Sometimes our students forget that, and, you know, and that's just one of the many, many things that I think we have to remind our students.
Yeah. One of the instructors that I work with, who's also involved in our group, Stephen Wally, in his email signature, he's like, my time zone is not your time zone, and I might not get this email until the next day, or maybe I'm traveling or whatever. And I think that that's a really good reminder just across the industry that everybody should have. So it kind of goes with that struggle of lives clashing and everything.
Yeah, I think another sort of cross-industry challenge that I can highlight is like acronyms and all these like niche knowledge. Yeah, I see some reactions. You know, one example that has come up with my students is like LGTM, which you might be familiar with as looks good to me, or let's get this merged. My students saw that for the first time and they were like, let's get that money? Like, you know? And like, there's actually, I met someone recently who gave a talk about this particular, that was sort of centered on this particular same anecdote. at All Things Open that I think is online if you're interested in hearing more about that. But yeah, this is like an example, right, of there's so many things that like you can interpret differently whether you're like a member of sort of the classic tech majority group or not, or you might have different context for. So I think, that's again, I think mentorship can have a place for our students to be like, what the heck is this, And I find that I have like a really different nature of relationship in like a mentorship capacity than I did when I was teaching in a classroom. So I think, if you are a mentor or an educator mentor, it creates space for those things to surface, for you to be able to talk about them. The other thing that is a challenge in sort of the area that I mostly work in is, students will come and they'll do a program like this. And some of you are already working on this issue directly, but students might come and have this experience and come away from it saying like, ugh, I wish this was in like more of my classes, or I wish this was in my degree program. Like, this is very useful stuff. And I think that is also a challenge, both in terms of like convincing departments and institutions that these things have value. Some of you have already been very successful in doing that. I've taught in a department that was very supportive, and I've also faced resistance, from other faculty in different departments that have said like, I give them the whole pitch of like how important this is and why we're doing this work and the impact, like the profound impact that it's having on students in very measurable ways, and then might have a faculty member return, and say to me something like, oh, but it sounds like students aren't writing like that much code. And I'm like, well, that's not the point. Like, they have all their other classes that they can be writing lots and lots of lines of code. This is different for a reason. So I think that is a challenge. And then also just, faculty maybe don't have time or experience with open source, sort of expanding our capacity, nationwide, worldwide, to support faculty who might want to teach with these things and just haven't had the opportunity. And for that, I will give a plug that there's a workshop called the Professor's Open Source Software Experience, or POSSE. That's a National Science Foundation workshop. It's how I learned initially to teach open source many years ago. And the workshops are starting back up. The next one's in May. And if you want to participate, or someone who might want to participate, it's a funded opportunity for US faculty. And please ask me more about it. I'd love to tell you.
The only thing I'd add is, I think a lot of it is just translating between the academic experience. A lot of the problems that our students have is just kind of translating what they're doing with what they're experienced with in the classroom. I think similar to what you're saying, a lot of students expect that their success is valued by the number of lines of code. A lot of students think that their success is valued by, do they know what lines of code to write, right? In school, if you struggle, that means that you're not passing the test, right? You're supposed to know the answer right away, and not knowing the answer right away is a really big challenge. So I think the biggest thing for us is just, it's not been that hard for us to get students to make one open source pull request. I think over 90% of our students make their first open source pull request. The challenge has been getting them to stick around, because so many of them think that they didn't do a good job because it wasn't what they were used to from most of their classes. Or even to put it on a resume or to talk about it in an interview. I mean, we've had students contribute to really amazing projects. Their code is in use by hundreds of thousands of people, and they didn't have it on their resume because they didn't feel like they did a good enough job in that experience. And so, I think that for us, that's the challenge, is just contextualizing what happens.
Yeah, I just want to add to that. I see the same thing with my students, and in particular, one thing that I see that I think is common to all of us probably is a student will maybe submit their patch or their pull request, and they're like, did it, I'm done. And then maybe a maintainer comes back with feedback, which is like the coolest thing ever, that these people are investing time in helping my students learn. And I think it's a very different model than taking a class. And so students sometimes kind of panic in that moment. They're like, oh, like I did it wrong. Or maybe because there was back and forth before the PR was ultimately merged, they feel like ashamed to put that in the open or share that with people and tell them. And I'm like, no. That's the success. That's the success, is that you saw it through, you came back and kept engaging in that conversation until your PR was merged or your patch was accepted. And that's what people in the field are gonna see and recognize. So I think it's a perceptions challenge, right?
Yeah, and we actually went and, well, one of our partners went and has gone to a bunch of tech meetups and just talked with hiring managers and just asked them, like, what would be impressive to you if you saw it on a resume? And they're not looking for, you know, the people that just have 1 or 2 pull requests. They're looking for, like, the discussion and the participation in the community and helping out with code reviews for other people's things and, you know, taking the feedback and integrating that. So it's so funny because it's just not the way that students are, you know, traditionally evaluated.
Yeah, it's hard to grade communication and collaboration, but you can more easily grade, oh, it passed the test, or
Right.
whatever.
Yeah, absolutely. So we're going to take some time for audience questions in just a second, but before we do that, any sort of parting words for you know, things that you've learned or things that you'd like to share that the open source community could do better to you know, to help our students get involved in the community?
I think one of us always mentions that if anybody's aware of a hidden pot of money, please tell us. Because we all, I think, are like furiously constantly writing grants and talking to our governments and things to try and fund this work because we think it's so important. But I think that I would love to see like industry especially invest in this work more. Like we, through being an academic OSPO, we talk with a lot of amazing industry collaborators who do a lot to support us. And we hear feedback from them that part of the value that we offer is by doing these sorts of programs. And we do have some industry collaborators who financially support them. But I think that, you know, it's everywhere in open source, right? We would all like to see people put money on the dependencies that they rely on. And I think mentorship programs are the same. Like that we're really passionate about this work. We want to keep doing it. We think it's really important. We see the value to everyone in the community, but it's expensive. So if you have a secret, tell us.
No? I think we're ready for questions, unless you have anything else, Tyler?
I'll just kind of second what Emily said, just in terms of also like folks talking to their companies, talking to HR departments, recruiters, things like that, trying to get them to understand what this is and why it's important is also really helpful because we want our students to get jobs. That's great for everyone. So yeah, that's
We want
great.
them to stay in open source. Yeah.
Yes, I'm sorry to interrupt the questions, but I want to make one plug before people maybe trickle out if they do during the questions, which is that we have a cross-sector interest group, which is kind of how we all connected loosely. And it's a group of people who are doing mentorship work in open source or want to be doing mentorship work in open source, who gather once a month on Zoom. It's a pretty low time commitment, but a place where we can all pool our expertise or requests for the community. And our next meeting is going to be on Monday, this coming Monday at 11 a.m. Pacific time. And any of us can connect you with how to get plugged in with that. Or I think the QR code there might also go to our Discord
Yeah,
server.
if you click on the QR code or if you scan the QR code, can I zoom? No. The QR code, oh, I can, it's just really slow. QR code down here in this corner will, okay, I'm just gonna zoom back out. I don't, I don't like what's happening here. The QR code down there will take you to a link tree. You can click on the Discord to register for the calls. And I think there's also links to more information about all of our programs as well.
Yeah, and we do things like we organize panels of people to talk at conferences to represent these efforts and get more people involved. We are working on pulling together an event for people to come and workshop, you know, how to pool our expertise towards things like funding or future events, best practices. So yeah, there's a lot of interesting stuff happening there.
Yeah, and anyone who's involved in open source projects or might want to be a mentor for one of these, we'd also love to hear from you. But yeah, the Discord is a great thing, and the calls are super awesome. So do go ahead and scan that QR code and scroll down near the bottom. There's a link to the Discord. So yeah, we'd love to take some questions. I think we have a volunteer here with the microphone. Awesome, and then we can share this one.
So I work with developers and product owners and QA and designers. You've talked about mentoring people who make code contributions. Is there any sense that maybe people have other skills that they can contribute to documentation or automated tests or something.
Yeah, definitely. Within the open source projects that I represent, we even need translations. If people know other other languages, that's really helpful. Definitely always need documentation. Oh yeah, translations is like really interesting. But yeah, documentation, just it's endless. Like the infrastructure to run the tools that support our open source communities. We also need like those sorts of admins too, and there's a wealth of experience to be learned from the people that we have doing those roles right now, and they would also be interested in doing mentorship. So
that reminds me, I always think it's kind of interesting, I think the documentation is kind of perpetually out of date in most projects. At least some aspect of it is, sort of perpetually out of date, and it's always kind of funny that almost every project the students will struggle to get something to build properly, and then at the end of it we're like, well, you could also submit a pull request for this. But I think general problem in open source, people I think undervalue the work on documentation. So yeah, I do think documentation is a big part of that.
So part of our mentorship program is to help students understand there's more than a software engineering role in tech. And because our students come from such different backgrounds, we try to encourage them to think more about than software engineering, that one role. A lot of students haven't heard anything else, and if they kind of like computer science, they're like, I want to be a full stack, engineer. If they're like, I don't like to talk to people that much, I'll be a back-end engineer. If you're slightly artsy, you're like, I want to be a front-end engineer. Or like that's kind of like how their concept of like the tech industry as a whole. So part of our mentorship program is to help students to understand, especially the ones that have so much really interesting background and experiences, to not throw that away, but incorporate that in their pivot into tech. We have folks that have a graduate degree in English, technical writing, a couple other things. If you worked in customer service in the past, dealing with customers in retail, you have a patience of a saint. So customer success engineer might be the role for you. Or if you were, sales engineering, or if you're a veteran, you're cool under pressure. Site reliability engineer, right? So there's a bunch of these things that we help our students think of, not just what they come in with thinking, understanding all of the different career opportunities that their unique skill set are a strength and an asset to them.
Yeah, I think to that point, I don't need to sell you all on open source. You're here at SCaLE, but I think that's like another reason open source is such a cool place to do this work, is because a student can go and see what it feels like to do a little bit of design work or a little bit of tech writing work without having to take a full tech writing internship or a full design internship. So I think, it's a really great question, and I think we all think about this. We have students at UC Santa Cruz or through our programs who work on everything from design to, all my students work on docs. I require them to work on docs, actually, because I think it's so important. And it helps them very quickly see the value of their work, too, because the community is like, thank you. If you'd like to keep working on our docs, here's 10 issues. So they all work on docs. I've also had students work on translation, which has been very cool for them to use maybe a native language to improve a project, or they're being bilingual. And I've also had students work on curriculum. Last year, my students were really interested in security. OpenSSF was doing some curriculum work, and that was what drew them. So, I think it's a really good point and something that we could be, it's good to be intentional about surfacing in these types of programs and settings.
Hello. I've heard you talk a lot about how you're working with the students, but what I'm most curious about is part of what you're doing as the mentorship program is, are you teaching people in open source projects how to be mentors and then sending students to them? Is that how that works? Or tell me how that exactly works.
I suspect it's different for all of our programs. So in our projects, there are, like, basically I go and I'm like, does anybody want to work with students in the upcoming semester? And then I give them as many details as I have from the professor, which may or may not be a whole lot of detail about like the level of skills that the students have. But usually I try to get at least 2 like community members signed up to be mentors so that they can also like peer mentor each other in the mentoring process. And I've been incredibly fortunate to see a few sub-projects even like kind of create, like mentor the mentors while they're mentoring the mentees. And it's like this crazy self-enforcing, excellent, I would call it a vicious cycle, but like in a good way. So it's really different. Virtuous cycle. Oh, that was a good one. I like that. That's very smart, very clever. So yeah, I say we don't really train our mentors, they train each other. But we do try to share knowledge and experience and context as much as possible amongst each other so that the quality of the experience for students goes up over time.
I think Code Day is as far on the sort of other side of the spectrum as you can get on this. We have kind of an interesting thing. So again, we're trying to teach students how to be self-sufficient to some extent and to break out of the cycle of studying for tests and really learn to work on their own when no one knows the answer to something. So we used to get mentors who were experienced in the open source project, and we found that those students actually did worse. So now we're actually looking for mentors who have no experience in the open source project. And you're just kind of there as a sounding board for the students to say, here's what I think is going on. And you can say, I've never seen this code base either, but when I look at this code, here's what I see. And you're kind of teaching them those skills. But again, I mean, ours is really focused on those good first issues. We're not really focused as much on the other parts of it. And I think like one thing we would like to do is work more closely with these projects so that once the students finish it, they do have a little bit more of the subject matter expert mentorship from the project maintainers.
And we approach it in a slightly other end of the spectrum. We provide a lot of structure. It's our students' first time sort of outside of the classroom. They're used to classroom structure, expectations, and things like that. So our students have expectations and they're trained on how to be a good mentee. Likewise, same side or different, the other side of the same coin would be our mentors are also trained on how to be a good mentor and what their expectations are, how to engage with the student or if things come up, how to engage with us or the faculty. And there's a lot of intentional programmatic elements that were built to support faculty, student, and the mentors, and we support all three sort of in the background the entire time. So it's not a fire and forget kind of situation. We make sure that things are always going well. Just like any project, things happen, and sometimes we just have to kind of figure out what the best way of unblocking it and get things back on track, or there's misunderstandings or miscommunications and things like that. So we're emotional support and things like that, and things happen, during the school year too. So we just do everything we can to make sure everyone is supported throughout the whole time, because it is, after all, their first time doing something completely new.
Yeah, for us, it's a mix depending on the program. So our academic research-focused program, I would say mentors get access to resources on like how to be a good mentor, and they have a community of, they have like a Slack community. They can bounce ideas off each other, talk through challenging situations. And then Stephanie, who directs that program, also provides a lot of ad hoc support, like if something comes up or an emergency happens. For our HBCU-facing program that has a lot of in-person time, the peer mentors for that, I mean, we're still growing the capacity for that program, but it's a lot of more like coaching for me to support peer mentors within the program. And then with regard to the actual communities, I would say since students choose the project for that, I'm not I don't know ahead of time like who we're going to be working with, and we sort of enter a community in a very like in the wild sort of a way of working. But I do see my role there as being sort of a buffer liaison where I can reach out to maintainers within the community and check whether they have the capacity to support my students or in the way that I think would be particularly high impact for them. And then I also just listen and get a lot of feedback from them on like what would make those collaborations smoother, which in the past has been like doing stand-up calls periodically or things like that. I will say, I think your question is a great one because we, in our monthly calls, this is like a resurfacing topic of people saying like, oh, I'm a maintainer of such and such community, or my friend maintains this community and they want to start a program, but they just don't have a lot of experience mentoring new contributors in the community. You know, where do they start? And so far, if you like join one of those calls, we could all info dump a bunch of resources on you, but there's not like a great central place. But that is something that we're thinking about and working on. And if you're interested in that, we'd love to talk more with you because I think there's a demand for that. And there's so much expertise already. There's, you know, a lot of people that we collaborate with who aren't here at SCaLE who are running all different kinds and scales of programs where they do different types of training for mentors within community. Or maintainers within communities, yeah.
Yeah, I think we have 2 minutes left. If someone has a really quick question, we could get to it, otherwise.
Yeah. Otherwise, it'll have to be the hallway track.
I know, yeah. But thank you very much for what you guys are doing. It's an amazing thing. As a software engineer myself, open source, like we need mentors and all that. But my question is like, you keep on mentioning students. I'm trying to understand the definition of a student. That do you need to be coming from a school, in a school program, or can you be anybody that you are self-teaching yourself and you want to get like mentorship from others? So I'm not a student. I'm just learning myself, and I want to see if I can get an opportunity to be mentored by you, by your company or your group.
Yeah, I think probably it's a little variable for each of us, again, depending on the program. For our program that works with HBCU students, that specifically is open to students at particular partner institutions. Our academic research mentorship program, though, anyone can apply who's, I think, new to open source is sort of the qualifier for that. So you don't have to be enrolled at a, you know, academic institution to participate.
For the university partnership program right now, it's just the students that are taking the courses that we integrate with, but I'm always looking to make new relationships with more universities everywhere. And I also have had students come up to me after panels such as this one that have been like, I really want to get involved, but my university is not supportive. Is there any way we can figure something out? And usually I can introduce them to someone in the community that is willing to like take them under their wing for a bit till they can confidently work on their own and then are just a fully fledged member of the community, so.
Yeah, we also partner with a variety of college and university programs, and that's where our partnership comes from. And I think that is a spot that we don't have, and I think programmatically, we're not sure how to build a program where folks that are not in like students, but also not in industry, but trying to get in, how to accommodate those students and what that, like a structured program for those students, what the goals are. So we do get those requests. So we do think about that. Right now we do, what Kendall does is like, hey, put us in touch with your professors, and we can build a relationship there and then get students in. But yeah, for individual students, it is hard to figure out how to build a successful program for them individually.
Yeah, and only thing I'll add, Code Day, we have in the past taken people individually who aren't students. We're not currently right now, but we may again soon. I believe that you're very passionate about that because you're here and you're asking about that. It's very hard to tell. Sometimes people will apply for things and then they'll just sort of drop out, and then that kind of ruins our relationships. So for, you know, the 20% of people that do that, it kind of ruins it for the other 80%. But I think that's something we're trying to figure out, is just how to make sure that the people are really accountable and actually have the time. But if we can do that again, we'd love to get more individual people and who aren't students. So, oh yeah, okay.
I just want to shout out a couple programs that are open to non-students. Google Summer of Code or GSOC is open to non-students. Again, it's just new contributors. So there's lots of different mentor organizations that work with Google Summer of Code to offer paid mentorship summer, or I think it's only summer opportunities. And then I don't know if it's changed, but I think at least at some point in time, MLH or Major League Hacking also offered, thank you for confirming, open source opportunities that are open to non-students in open source, or maybe I said that twice, but yes. So there are opportunities that are not student focused that we just aren't personally affiliated with, but please look into those, yes, because they're out there.
Cool. Thanks everyone so much for coming. I'm sure that most, if not all of us, would be happy to stick around and chat in the hallway a little bit more. So if people have more questions or things they want to talk about, we'd love to talk to you. Thanks everyone. I'm so glad to see so many people are excited about mentorship and open source, and I really appreciate you all for being here. So thank you.
It's a little over 30, but it was when there were not. I should have counted like during the last one. I think it was like 34 was what I got. So that's cool. At the end of the day, in the corner. More than that.
I like that 4 at mine. The question for you, but it was specific.
Yeah,
which is why I didn't ask it. Which is, are you like in contact with alumni at UC Santa Cruz? And I ask that because there's like 40 or 50 years.
Testing, testing, testing. Okay, cool, cool. Okay, thanks so much, Donald. Oh my goodness, hot mic'd. Okay, I'll go ahead and get started. Thanks everyone for joining. Oh goodness, good to see everyone here, familiar faces, some new faces, good to see you all. Okay, so hello everyone, thank you for joining me on a Saturday evening, soon to be Saturday night. There are a lot of other great talks happening right now in this very slot, so I do appreciate you all picking this one to attend. I also thank you in advance for sticking around until the end if you're interested in this topic, because I know game night starts at 7 p.m. and goes until 11:30. Spoiler alert, see you there. The title of my talk is rather broad. I imagine you're interested in either engineering, solving problems, using GPUs, or just computing itself, of course, at this conference. My point being, I hope there is something everyone in the room will leave having learned something, so something new, and be inspired to look up or try something out later. The intended audience for this talk at SCaLE is folks with intermediate experience or knowledge of any of these concepts that I'm talking about today. And as you've noticed, I chose this specific plot here for my title slide because I thought it was telling of future computing trends. And because I thought it would be lame to just show a picture of a graphics card or a photo of Jensen Huang on stage selling you more GPUs. So yeah, I'm here to convince you and only you that there is value in GPU computing and specifically multi-GPU computing as well. Okay, I'll first go into a disclaimer and motivations for the problem I'm going to discuss in this talk. And then I'll give some background on GPU computing and segue into the multi-GPU case. I'll also provide some examples of problems that I have looked at in preparation for this talk. I just think it's so cool that this is like on my head and I don't have to hold a mic. Goodness. Thank you, SCaLE. Here are some basic disclaimers that I'll go into super quickly. Views presented in this talk are my own and not that of my employer. I am not a programmer or a software developer. So if you are a developer in the room or a programmer, hats off to you. You can probably already do what I'm going to talk about in this talk. So, so please take things I say also with a grain of salt. I'm sure there are better or more efficient ways of doing certain things. And if you have a different way of doing it that works for you, kudos. I'm open to feedback, so please provide comments or suggestions. If you want to interrupt me, you can, but I kind of prefer at the end of the Q&A for the Q&A section, or at the end I'll also have my email address shown, and you can send me an email, whatever you guys like. What I am is not a programmer, but I am a problem solver, and one who wants to communicate that knowledge is meant to be shared. And some learning is best when done collaboratively. I don't work for NVIDIA, but I do use their hardware and their software. So I'll touch on that later. If something is available as open source, I will prefer that solution, because we are at the SoCal Linux Expo after all. Because I know it is vetted by others, the source code is available, and there exists some level of documentation for it as well, or so we hope, right? Takeaway, if you have a novel idea, use anything that works for you to get results. Motivations. Why am I here? Or why am I here talking about this specifically? So there are a lot of other computing problems, specifically within the Linux realm, that I'm interested in as well. But to answer that, I'm motivated by the fact that the most interesting problems to solve tend to be the hardest, or the ones that keep me up at night and annoy my wife that I'm still working on stuff at 1 or 2 a.m. I don't always get it right, but I do learn a lot in the process. And for me, that's the goal. It's learning. And I know that's kind of like a marketing thing to say sometimes, but I'm not selling anything, so it's the truth. I also note in my slides that in my time in computing, I've also learned the difference between being an operator, power user, engineer, and developer. And if you want to get nearer and dearer to how things work, you have to take them apart and learn how to put them back together again. And like the slide show, I wanted to port personal and academic projects to Python, which I'll get into more a little bit later in this talk, which is common and supported. And even folks that are not adept programmers will have run some Python scripts or have familiarity with Python. So I think it's a good way to bring what I'll be talking about to the masses, or just to my audience here. And also take advantage of any hardware optimizations that exist. Python is easy to learn, and it is a myth that it is slow at everything. Okay? Python is dynamically typed, and it's a higher level language than, say, Fortran or C, right? Your code runs slower out of the box, but this is because things are being checked and validated at runtime. There's no separate compilation process. Not to say that there's anything wrong with Fortran, but I did want to modernize some of my code. I did most of my master's thesis work in Fortran, so no Fortran hate. You can optimize Python using Cython and Numba, but I wanted something that was more scalable and future-proofed that could take advantage of existing hardware. Okay, I'm currently in school part-time right now while pursuing a PhD, and my advisor and I are interested in how turbulent fluid flows behave. We're interested in direct numerical simulations instead of simulations that utilize approximations or linearization models. This makes what we do useful because it's closer to real life than an approximation or a model, but harder to simulate and scale accordingly. Turbulence is nonlinear, and it's a multi-scale problem. Current simulations are limited by either restricting their runtime or the physical domain that they are capturing when running through time steps. Typically, you can't scale both, and you have to pick one or the other depending on what behavior you wish to capture in your results. So as I point out in my slide, there are many, many problems that are important. National security, energy, safety, future power considerations are all at stake for this kind of research, because this is not just fluid flows like I'm researching in my program, but it's applicable to anything that is using computation. So you're probably coming to this talk because you're interested in GPU computing, but I titled it multi-GPU. So why multi-GPU? Why is that? That's probably only for people who own data centers, right? Not for me. Scalability. Most systems have enough physical space and power for just one GPU, and for most power considerations, that's enough, right? That's basically half of what I'm allotting some of these new power supplies that I'm buying for home builds, just for the computer, just for the GPU alone. But of course, power supplies, motherboard servers continue to grow in capacity, and I theorize that multi-GPUs will become more and more commonplace. Folks can also buy multi-GPU capable motherboards, and they can, for example, I'm already starting this trend. I'm aware of NVIDIA selling NVLink to link two individual GPUs, right, to bridge them, and you can write code that can utilize both in parallel, right? So if not multi-GPU on one single system, right, multi-GPU can be done across networked nodes, right, which is how the OpenAIs of the world, the NVIDIAs of the world, folks that are doing all the Gen AI in the background are linking all of these systems together. They're not all doing all of that on one single GPU, right? So complexity rooted in questions, aka nonlinear problems, demand complexity in answers. So that means the models that you work with also will not be linear. The tools I have at my disposal. I personally, not to make it vendor specific, right? I'm specifically working with CUDA in this talk. If you want to stay vendor agnostic, right? RCM, ROCm, or Triton are other models that exist for doing computation on GPUs. The code that you write must be cognizant, must be aware of routines that the CPU, that the host can run, versus what the GPU, also known as the device, can run. That's a distinction that I'll get into a little bit more.
right? The very first requirement to performing compute on GPUs at all is having a library that can translate code that you write and data you input or declare, meaning variables or arrays, into GPU memory. And by default, most programming languages at runtime will store data in system memory, which will execute calls and functions via the CPU. Because GPUs and CPUs are separate devices, they must speak a language that both of them can understand and interpret as well. Indeed, in NVIDIA's CUDA language, there exists this distinction. So clicking through, CUDA C is mentioned in this talk as well. That's NVIDIA's solution to having C, but built in with C++ extensions in order to allow for on-device execution on the GPU with multiple threads. Nickel is also another library that's used to enable multi-GPU computation on NVIDIA GPUs for a multi-GPU setting. And in the example at right, I show C code that's extended by CUDA and defines a function called a quote-unquote kernel that gets executed on a GPU device. If you can read the text within that main function, you will see a reference to the kernel using the triple less than and greater than symbols, which kind of looks weird, known as the execution configuration syntax in the CUDA language. And that tells it that whatever it is trying to run there on the host should be run on that GPU device. Okay, and in Nickel, which is, stands for the NVIDIA Collective Communication Library, there are two ways of implementing multi-GPU, and that's via CUDA streams. For people, just quick show of hands, does anyone here actually code in CUDA? Wild, okay. So if you're familiar with CUDA streams, that is something that's very, very useful for running certain jobs in parallel. And if you're not using CUDA streams, right, you can also get an assist from MPI, the message passing interface, to create separate threads on the fly for each GPU. So the very first requirement to performing compute on GPUs, that's the previous one. How CUDA is structured must be well understood if you want to solve engineering problems in this paradigm. Like I said, everything must be seen and considered through the eyes of a CPU versus GPU. Failing to do this, if you're interested in converting a lot of the code that you yourselves in the audience are running to run from a CPU to a GPU, you must keep this in mind, because failing to do this or take this into consideration will add overhead, complexity, and compilation runtime errors to your code base. Most projects looking to use CUDA will suffer a quick death in this way. So the more you know about CUDA's capabilities before you start getting into this, the better. So how can I solve a simple math problem using a GPU? How can I use CUDA to do it? So a little bit about me. Most talks start with an introduction at the beginning. I'm doing it now because I'm just, I don't know, strange. But I think it makes more sense to give some context about the problems I'm interested in, give some motivation first. So first of all, I'm a Los Angeles native, hiker, camper, husband, and dad. I got my bachelor's from UC Santa Cruz, go Slugs, heck yeah. And my master's from the Technische Universität in Darmstadt in Germany, which is a cool place to be if you're just hanging out. I think this is my 5th scale, I'm not sure, but it's my first talk. So if you guys have pointers for me for how to give talks, please come to me after. I'd love to do better, thanks. And like I said, I'm also a PhD student in aerospace engineering at the University of Alabama, home of the Crimson Tide. Roll Tide, roll. Yes. I'm a Linux power user at home. My wife hates that I'm always putting the TV stuff on the Raspberry Pi, but that's just what we do, honey. I'm sorry. And I'm a Linux engineer at work. Okay, so I mentioned Python earlier. I want to do things with Python. So how do I take this thing CUDA, which is basically just C, to my headspace? How do I make this happen? I'm not a programmer, right? But I do know that I need to take advantage of GPU hardware and GPU capability in order to solve hard problems. Okay, running Python itself can be slow, but using Python is a delight compared to other languages, lower level, and makes the code feel familiar to me, which I like. So how can we make the experience better and make this awesome tech accessible? How do we do it?
have your cake and eat it too. So I introduced the CUDA Python suite, and again, I'm not selling you anything. This is stuff that you can use if you want to dip your toes into CUDA, but you are not ready to make the commitment of learning CUDA C or CUDA Fortran, just to be able to use this stack. Yes, sir. Yes, I've explored that a little bit, but not specifically for the project that I'm working on, which is like fluid mechanics, fluid dynamics. But I do know that it does have some GPU capability as well, natively. Okay, very good. Yes, I didn't know what just-in-time compilers were until I started working on this project. So yes, thank you. I'm learning a lot too. But I will look into Julia more. So yes, CuPy. Has anyone here used CuPy? Raise your hand if so. Cool. Okay, a couple. Nice. So CuPy, everything has a name in this world, right? So if you're familiar with Python, you've probably already used NumPy or SciPy for working arrays, math libraries for GPUs. CuPy is essentially a drop-in replacement for NumPy or NumPy that runs on GPUs. So if you are using some Python code currently at work or at home and you have some projects going and you're using NumPy or NumPy, and it's running slow and you want to speed things up super quick, you have GPU hardware you want to take advantage of, hot swap, Indiana Jones, just boom, 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 Temple of Doom. And that will automatically leverage very quickly GPU hardware that you have. So it's a drop-in replacement. Yes, CUDA-Python, if you ask NVIDIA, the NVIDIA folks, what it is or what it uses, they have a library called NVMath, which actually pairs with CuPy and pairs with Numba to do several different things. But this is the stack that they offer to basically make CUDA accessible or useful for folks. Of course, to leverage CuPy and to take advantage of this, programs must be written in Python. That's the requirement. But fret not if you actually are a C programmer or a Fortran programmer. Multi-GPU capabilities are linked to this Nickel library, which is also in CUDA C and in CUDA Fortran. And it makes it easy to port applications from CUDA C or Fortran to a paradigm that uses Python and CuPy. So what I will do in this talk, I want to show the value of integrating CuPy into your Python code. I wish someone here was from the CuPy project, or like I was from the CuPy project, but I'm not. But yeah, CuPy is super cool. It's open source. It's on GitHub. So I feel comfortable talking about it here in this talk. And this is valuable because, I say, versus writing CUDA C from scratch. If you're able to do that, great, but some of us have other things to do in our lives, right? So you don't want to just be learning CUDA C in order to facilitate this. And like I said, remember, we want to use something that is familiar and feels good to use because we use it for so many other projects, right? So if some folks are learning assembly to do, work specifically on assembly, or, something project specific, to learn a whole language just for a project, Python makes that no longer be. Python is so easily adaptable and flexible that you can actually take that language, use it for an academic project, you can use it for work, you can use it to do your taxes, whatever, it's just up to you. HMM, heterogeneous memory management, can also simplify programming models, programming model development in CUDA Python using CUDA Unified Memory. And CUDA Unified Memory is this cool thing that's in newer architectures of GPUs released by NVIDIA that actually let you avoid needing to, for the C programs out there, use like malloc calls or CUDA malloc calls to assign memory, right, directly on the GPU. It actually unites and bridges host memory and device memory so you can actually use them in the same address space, which is pretty cool. And non-programmers and expert coders alike can benefit from that feature and functionality in CUDA. But can I do this at home? Can I do this on hardware that I have? Can I? So to answer that question, I put together this little project on my GitHub. So I wrote this little thing that basically spits out CUDA device properties to tell me, hey, do I have this functionality? Do I have, what is it called? Like, it's on there, but pageable memory access. Do I have access to goodness, do I only have CUDA shared memory access, or do I have enough flags enabled in the model to enable CUDA unified memory as well? So I didn't see any tool out there that spat that out. The CUDA C programming guide on the NVIDIA website said, you can do this, and then it didn't give any more like samples. There's a very nice CUDA samples project on GitHub that NVIDIA releases that shows very nice samples of things that you can run yourself, but it didn't have a tool that determined how to do that, so I wrote that. But for the rest of this talk, if you know C, Fortran, or even like a little bit of Python, just a print statement or whatnot, you will follow the rest of this talk because Python has been brought to the forefront and is accessible enough to everyone in this room. So what I want to do is run a few canonical problems in CUDA Python and show all of you here, and hopefully I do okay. My first example, or what I'll call a canonical problem, is that of AI/ML. So like I mentioned in the first bullet point, it's not just engineering that can benefit from multi-GPU. I start with this problem to highlight that machine learning and AI/ML can use multi-GPU, and have been for a while now, right? One of the reasons this industry is booming is that anyone with the right hardware can optimize and scale their AI/ML workflows onto multiple GPUs. So yes, like I say here, yes. Have any of you heard of AI, right? Raise your hand if you haven't heard of AI. Okay, we got 2 people, all right. I won't name you. Okay, so users of PyTorch and TensorFlow have already been doing this with ease for a decade now. And that's because of all the libraries and all of the support that the open source community has provided to people in these projects. And you will be familiar with this already. There used to be a data parallel library that was deprecated and replaced with the distributed data parallel library that extends these workflows to scale, not only to multiple GPUs, but also multiple machines. And many of them can also have multiple GPUs. And if there is native multiprocessing that needs to happen, there's already a Python library for that. So again, we're seeing again and again, Python is the tool of choice for folks that are interested, folks in computing interested in solving science problems, and science folks that are interested in solving computing problems. So this is a natural bridge and a natural place for solving a lot of these. Okay, folks that do work with AI/ML pipelines, CI/CD pipelines, AI/ML pipelines, LLMs, Gen AI are already doing this. Also, for example, with PyTorch. All you have to do to encompass and use all of the available GPU devices on the system is just say, hey, load this pre-trained model with device map equal to auto. And it's like, okay, I know about all of these because it's querying CUDA under the hood to know what is available on the system. Okay, so I mentioned Nickel as well, optimized primitives for collective multi-GPU communication. This enables GPUs, this enables GPU compute for multiple GPUs on one box on the same system, multi-node GPUs on different systems, basically right tethered via networking, either Ethernet or InfiniBand or what have you, or even multi-node, multi-GPU. There's a very nice set of blogs written by an employee of NVIDIA, a gentleman by the name of Mark Harris. He coined MNMG, which is just multi-node, multi-GPU. But it's a specific paradigm, it's a specific way of solving these systems, right? Having an ecosystem where you can run the software that you're writing that can take advantage of all of this in order to solve your problems. Okay, Nickel is compatible with any multi-GPU model, right? So that includes single thread control of all the GPUs, and gentlemen, they're familiar with CUDA streams. If you're familiar with CUDA streams, that's single thread control of all the GPUs, if you can work that out at the CUDA level. Multi-threaded, meaning right, one thread per GPU, and multi-process, leveraging a helper function or helper software like MPI for message passing. Okay? So that was problem 1, AI/ML, PyTorch, TensorFlow. I want to get deeper. Nickel operations canonical problem 2. There are 5 types of primitive operations that Nickel focuses on, shown on the slide. All reduce, broadcast, reduce, reduce scatter, and all gather.
the colors represent ranks, or you can think of them as just the GPU cards themselves, which you can think of separate GPUs. These primitive operations are the foundation of how data gets shuffled and manipulated between GPU devices and CPU host. Okay, for canonical problem 2, I'm actually just going to focus on one of the three, or one of these 5, which is the all reduce operation. So for the sake of your eyes and time, I'll focus on just this one. And all reduce is heavily used specifically for neural network training, so machine learning. So for example, in the first canonical problem I showed, I alluded to PyTorch and TensorFlow, which heavily use this in their multi-GPU implementations as well. So you have some operation, right, on these multiple nodes, A, B, and C. There is some kind of helper function or associative operator, F, that performs some operations or reductions on the data that you're interested in. And that associative operator can be different, right, with all reduce. So you can say, I want to take a sum, I want to take a minimum, I want to take a maximum product, or even get even more granular with, you know, logical bitwise and/ors. Okay, so here I show some snippets of my Python example application where I ran this test. In this case, I used the multiprocess, multi-GPU model to run this test, which means I needed to import the Python multiprocessing library to create independent CUDA threads for each GPU. Then I created a class that allowed whatever was invoking it to populate it with an array of ones, just ones. So take an array of ones and have them on each GPU. Then I use a separate function for running the example using the multiprocessing function, multiprocessing Python library, where I set one process per GPU rank. The necessary, or the all reduce example function sets up all, at write, this sets up all necessary nickel communications in CUDA, and additionally uses the CUDA synchronize method to then update the device and the host, followed by a call to CuPy to clear the default memory pool as well. Okay, and then, at the left there, the last one that just popped up shows this basically multiprocessing Python helper function that gets the unique IDs from all of the GPUs, and then facilitates the multiprocessing. So this is like a multiprocess manager that I was able to use. Okay. During the run itself, here is what I see as the result of the all reduce operation on all 8 GPUs that I used. When it runs, all the GPUs all churn at the same time. And it outputs, when I run the application, to standard out to on screen. So when I run it at right is me running the program. At the left there is, for those familiar, NVTop. It's like top or HTOP, but for NVIDIA devices. NVIDIA SMI is another command that you can use to kind of view what is going on with your GPUs. Cool, cool. No name change though, hopefully in the application. Okay. Okay, cool. So yeah, this outputs to screen, but that's very good. Nice to know that NVTop is alive and well as far as updates go. Okay. The question? Oh, the question was, thank you. The question was, or the statement was that NVTop is actually now supporting non-NVIDIA specific architectures, so RISC, AMD as well, and Intel as well. So that's a good update, something to keep in mind for folks that are not going to be tied specifically to CUDA, but that are running something open source like Triton. Okay, but how can I apply this to engineering? Who's here today because they want to hear about engineering aspects or physics aspects? Wow, sick, okay. All right, cool. You guys. All right, sounds good. Super interesting to me too, the last thing that we saw, but you might be, you might think it's cool, but you may be asking yourself, when is this guy going to start talking about engineering and science? Okay, so maybe you're not asking yourself this question. Maybe you're hungry, your stomach is growling, it's dinner time. All I can offer you is food for thought. Dad jokes. But don't forget, game night is right after this talk. Okay? Turbulent fluid flows are some of the coolest things around. You see it in action when you add cream to your coffee, condensed milk to your Thai iced tea, or when you're landing your private jet, which is where you can see wake turbulence visualized with sufficient tracer. Why are you guys laughing? You don't have private jets? Come on. Okay. All right. I have that pause in here. Pause for laughing joke about private jets. Another place where this is seen is nuclear fusion experiments. Actually, cool place to see them, both in magnetic confinement fusion down there at the bottom, and also in inertial confinement fusion at the top left. So 2 different techniques, 2 different ways to do nuclear fusion studies and experiments. But guess what? They're both interested in turbulent fluid flows. Magnetic for like plasmas and things like that, and then inertial confinement for like mixing of different species, protons, neutrons, different things. Okay, so this stuff is happening. It's no longer a pipe dream, right? A lot of folks always say it's always 20 or 30 years away. Well, here it is. And what makes turbulence difficult to characterize is its nonlinearity and its multi-scale, multi-species, and cascade behavior. In order to capture this nuance, granularity, and detail, turbulent flows must typically capture compressible flows, skip out on convenient approximations, and in order to be modeled and seen, must use full direct numerical simulations, also known as DNS simulations, in order to visualize them. So turbulent fluids in CFD, in computational fluid dynamics. This is a field that has not yet seen much in the way of GPU computing, and if so, much less multi-GPU computing. CFD codes do not lend themselves well to expose the CUDA API as easily as PyTorch with its device map capability or feature. And this usually must just be programmed in from the very beginning. So most codes are traditional CPU codes that simply leverage MPI, the multi-message passing interface, in order to, quote unquote, become parallelized. But this has its limits too. Okay? Modern hardware provides more compute capability than scientists and engineers are currently leveraging. This is what I'm learning from my day job too, is a lot of folks have a lot of problems, but there's a lot of untapped potential in a lot of these GPUs for solving these problems. And these problems also can naturally lend themselves to be solved on GPUs. Turbulence problems are nonlinear and multi-scale and complex, which is a perfect candidate for GPU computing. So my third and final canonical problem, I revisit the 2D Poisson equation from physics and engineering, which is seen in fluid dynamics as well as heat transfer. In fluid mechanics, when assuming the incompressibility condition in 2 dimensions, we can also solve for pressure, where P takes the place of psi in my slide here. So we can then become interested in solving for pressure given some source function. And this type of problem is perfect for GPUs as well, because it's one that's also known as being embarrassingly parallel, if any of you have heard of that, which means it gets solved very well on these systems. We assume some kind of uniform spatial discretization to make the continuous 2D Poisson equation discretized and be able to solve and put into a computer program. And I write here that this discrete Poisson coincidentally also arises in the theory of Markov chains in probability theory and statistics. Okay. So Python. So we use this algorithm called Jacobi iteration in order to solve this discrete 2D Poisson equation. The solver function then calls the Jacobi iterator via CUDA, via CuPy, coming back to CUDA and CuPy. The domain, the grid, the physical grid where this is happening in 2 dimensions in X and Y, you guys remember Cartesian coordinates? This grid can then be split up in as many ways as needed to leverage the number of GPUs you have available in order to solve the problem. And in this particular example, there's no multiprocessing, there's no multiprocessing library. So there's no MPI taking place, and all of this is happening as a multiprocess CUDA model. So this is all inherently CUDA, so multi-thread specifically. So keying off a number of GPUs present on a system and splitting the grid accordingly can of course be greater automated if you have some systems that have 2 GPUs, let's say at your home lab or small business, and then if you have 4 GPUs or 8 GPUs or 16 GPUs at like a data center or an enterprise location, you can split it up accordingly as well. And this is just one example, of course, a million other ways to do this. Okay. Then after running this program multiple times with different NX and NY in my Python code, that just defines the problem size, right? The grid, X versus Y. And in this example, I'm using 2 GPUs instead of 1. The grid is split, and each piece goes to a GPU separately to work in parallel. Let's see. Yes, the previous slide defined the distribution of the grid to each GPU, where grid size in the table at the right is just the value of both NX and NY. So I'm showing grid size once at the left there. But if I say, like, for example, grid size 100, that's just 100, comma 100. So X, comma Y, 100 by 100 of a grid to do this work on this, to solve the 2D discrete Poisson equation. Okay, and the results I got from my program, totally fascinating. So when I ran with a small grid, let's say 100, I was able to solve this on a CPU in 0.009 seconds, and on a single GPU in 0.03 seconds. But a multi-GPU took 0.162 seconds. It took longer on a multi-GPU? Is this guy selling me lies, but now he's telling me that this is not faster? Okay, so yeah, so it took longer. And if you think about it, a CPU, when it receives code to solve something, it's doing it instantaneously on the host. Whereas if you have GPUs set up, right, you have that extra communication. Not everyone is lucky enough to have an NV switch that's just sitting around where you can have GPUs co-located and they can have peer-to-peer communications, or even an NV link where they're paired, right? So you can't always have that. So that tells me that if I'm running with a grid size of 100 by 100, it makes more sense to just run it on CPU. Forget this talk, right? So as I go up in grid size, so for example, up to 1,000, if you can see that, CPU is running at 0.534. Single GPU is at 0.03. So at that point, yes, GPUs are faster, and multi-GPU is even less. But what is really, really striking is actually, if you take nothing else from this table, take this, at the bottom, all the way in the bottom, when my grid size moves past like 10,000, look how long it's taking me to run this on the CPU. It's 90 seconds for a 10,000 by 10,000 grid, and only 0.6 seconds on multi-GPU. At a grid of 35,000 by 35,000, it took almost 1,100 seconds versus 6.2 seconds on a multi-GPU and 12 seconds on a single. So not so bad, but I'm about to show you guys, if you can just hold the question for the next slide. What this tells me is that there's actually a range where some certain devices that you're using to solve some of these problems are valid. This is the result of comparing the data from this solver. The lines you see here, CPU in blue, single GPU in orange, and multi-GPU in green. This is a log-log plot, meaning each of the axes are adjusted or scaled to a log scale, with the grid size on the horizontal and time in the vertical axis. And then I'm about to highlight these 3 areas of interest, but there was a question? Yes? Yeah, I'm curious about that too. Yeah. I wanted to show all of the things, but I knew I had finite time, so I was wanting to just keep it adjusted. But yeah, good point. And I think even in the next plot that I'm about to show, you kind of do see a little bit of that there's like a almost linear relationship between them too, even in the log. But yeah, it's expected. Yes. So for these here, On this one, I was using A100s, NVIDIA A100s, but you can do this for the single GPU case, you can do it on any GPU, right? Plain and simple. And yeah, so they were, yeah, A100s, NV switched, which is, of course, faster than NVLink, but something to keep in mind. Yeah. What was the question? It seemed like a, you know, a decent number to start with when you're thinking of computation and sizes and grids. Yeah, yeah, something to start small. I had data. Oh yeah, I think I had data. I had initially had them at like 512, 1024, you know, 2048, but I decided to just make them round hundreds just for the sake of showing things on screen. Okay, so like I said, there are regimes. And what's interesting is that the first is where the grid size is basically dominated by having solutions only be solved by the CPU where it's advantageous. So lower values are better, so that's time, right? And then as your problem grows, right, you get into this regime where a single GPU is actually more advantageous. And a multi-GPU is actually slower, right? That's the green line. So all throughout that middle part in that single GPU regime, it's actually slower. And that's a sizable range, I should add too, because it's between where this that boundary between the GPU regime and single GPU regime is around 250 by 250. And that extends all the way to about 4,500 by 4,500 for this 2D Poisson equation problem that I was solving. So pretty sizable. But you get to this regime eventually where a multi-GPU dominates. And that tells me something. Yes? That's a very good question. So the question was, what is up with this little peak on the multi-GPU green line in the middle? I don't know. I don't think that's, it could be an artifact. There was a lot of other sources of error. It could have been systemic, like a systemic source of error from other processes running on this server. This was a shared server that this was all running on. So other folks are running things too. So when that gets very intense, it could explain a little bit of you know, deviation. So all of these should be taken with a little bit of a standard deviation grain of salt, essentially. Okay? Okay, so to wrap up this talk, again, thank you for your attention. Multi-GPU is not a bandage, and you should consider the requirements of your problem precisely before using it or applying it. Just because you see some software out there that says, yes, use multi-GPU, it's going to give you more performance, it's going to give you deliverables and results faster. Don't necessarily buy into it, because you have to take a look at, you know, the validity of the range of the data, the length of the data that you're feeding into these models. And yeah, you just should know this precisely before using it. And this also tells me that there are certain types of problems that lend themselves better to GPU computing, and that needs to be thought out better as well. And you know, I want to wrap up, but I did also prepare talks and slides for this talk, additional content, where I was actually doing this canonical problem 3 to be a tri-diagonal matrix solver, which is very commonly used and seen in computational fluid dynamics. And I was consistently getting worse results, and it was always taking longer and longer and that was my metric. It was taking longer and longer to run things multi-GPU. And that was using the, I think it's called the Thomas algorithm. And that has like this systemic forward sweep and back substitution that gets done for the solver. And that is very, very inefficient for multi-GPUs because it's sequential. So each GPU would then have to wait for the other one to finish, and they all depended on each other's data. So even though you were dividing up that grid or that input array, they still had to wait on each other and not being done in parallel. So be very smart if you're going to be applying this stuff to your work, right? that you're applying it to the correct problem. Okay. Yes, if a solver algorithm itself is sequential, you're going to have a bad time, right? So, South Park. Optimizations need to be carefully planned. Okay. Conclusions and where I see this going. There are a few strategies that can be employed to leverage CUDA's multi-GPU compute capability. Can, CuPy, and CUDA-Python, I can dance the can, that's an old song. Can CUDA and CuPy bring CUDA to the masses? Yes and no, not quite and not so fast. A lot more work is required if you're trying to do this yourself, but I was able to do this myself. I'm not a CUDA programmer, and I was able to come here and present this, these results and share this with you guys. So that means that anyone, in theory, can do it. CUDA-C and CUDA Fortran are more mature implementations, I should add. But there is room for CUDA Python to make an impact in engineering, science, and AI ML, and should be explored more. So, something to take back to your teams. Yes, question? Yep, that's correct. Yep. Yep, so the question or comment was, don't immediately buy into multi-GPU just because it's more and better and faster. Definitely look at the problem that you're trying to solve to see if it's appropriate. And I should also add, when I was showing that multi-GPU regime, the types of problems that I'm personally interested in are in that regime. So I feel good about that I'm going into that territory knowing that the problems that I'm solving are difficult and multi-scale and use a lot of data, right? So what's next for me in my projects? Take what I learned here for this talk and then make it useful for my PhD program, right? So in theory, I should have worked on my PhD stuff and then brought it here, but I'm actually doing the opposite. So I told my advisor, I'm like, SCaLE's coming up. I'd love to give a talk on GPU stuff. He's like, cool. And then I realized I have to actually do this more after I go home. Okay. Next for me, learn more CUDA-C and CUDA Fortran, which will help me in the long run with CUDA Python and CuPy, because under the hood, that's what CuPy is using. It's just making CUDA calls under the hood. And then determine which problem and domain-specific algorithms I need to be doing in order to do computational fluid mechanics and dynamics in order to use multi-GPU and not, mess myself up, to say it nicely. Yes. And then also learn how to really get good with building custom device kernels. So that means doing very, very GPU device-specific CUDA code that can be solved very, very quickly on the device level, either via CuPy, binding libraries, or CUDA-C, dare I say. So thanks go out to my doctoral program advisor, Dr. Denis Aslangil, for continued support throughout this project, and who will continue to advise me on this project after today's talk. Thank you also to the Aerospace Corporation, who is, it's my employer. So I work there. And I'm in a graduate student fellowship there, and they've been supporting me also in my graduate studies, working on my doctoral program. So hats off to them. And thank you to SCaLE, of course, as well, and the open source community for providing everything that they've provided, which we all, of course, all of us hope to give back to one day, right? If you aren't already. Oh, this little unicorn is a reminder. Special thanks to my wife, who's here today. Thanks for being patient. For letting me work on this stuff while our 2-year-old is like in the background. So references, if you want to look at references, here are a bunch of references that I'll leave on screen for just a moment. I'll point out that nearly all of my references are links to open and public documentation on the internet. So use your resources wisely and just look at stuff, look stuff up when you want to look stuff up. The information's out there. So I'll leave it there. If you guys want, you can also email me. I can send this slide as well if you need references. But lots of stuff out there. And yeah. Any questions? See, we have 10 minutes left. that's the end of my talk. I will now yield the remaining 10 minutes to questions. Are there any questions from the audience? Saw the first one here, Phaedrus. Yeah, so, so they're going to want to hear that again for the recording.
So I was wondering, I don't know how you're modeling fluid dynamics, but if you break it up into like three-dimensional cubes and distribute those across the different GPU cores, then what happens when something in one of those cubes affects something else, like a molecule, you know, has some interaction with a molecule on another cube, and then that other GPU has to know about that, right?
That's correct.
So how do you still have parallelism, or is it not fully parallel?
Yeah, that's a great question. So ultimately, you have to decide where you're making your optimizations count the most. But to answer the first question, you have these, if you're doing a three-dimensional simulation, you have these cubes, essentially, right? And each one has different fluid properties that they're reporting, right? Be it density, velocity, whatever it may be, temperature, right? And when you're reporting these, that cube has its own information, but if the cube next to it needs to know how hot or how fast the previous cube is moving, right, that information needs to be passed on. And in computational fluid mechanics or dynamics, they have these concepts of ghost cells, which is basically what is sitting at the boundary, and it's essentially a plane that's passing information from one cube to another. And that canonical problem number 3 that I showed was taking that grid, and because I solved it in 2 GPUs, it cut it right in half, that grid. And right in half where it was cut was the boundary where it had to exchange information. But that information does not need to go back to the CPU for the next iteration. That can be passed from one GPU to the other, provided, right, that you have some capability of linking those GPUs, such that you do not have that additional bandwidth where it's going, through the system, through the motherboard, back to the CPU to do the actual computation. So when you have these ghost cells that have that information, you can limit and significantly mitigate the number of calls that have to be made. And there's a lot in CUDA as well, where you have to say that, okay, some things can run in parallel while everything is running via CUDA streams. But certain things where there is dependence on the previous time step or previous, spatial location, that information has to get passed. But you optimize where you can. You can't do it everywhere, but if you can reduce the time by just having GPU to GPU communications, for example, via that nickel library, you can optimize overall and from like a macroscopic scale, decrease the time, simulation time. So instead of being something that lasts 3 months, it can be something that's 3 weeks or 3 days even. So there are all sorts of different optimizations that you can make depending on how much time you want to spend optimizing your algorithms. So, yeah. Correct, but hopefully not waiting on the CPU side, right? All the waiting that is done is strictly in the CUDA level. And if there's any part of that communication where there isn't waiting involved, for example, like a different aspect, that can run in parallel and progress forward.
So my question was
Ryan,
about, you did benchmarks to figure out which regime different sizes of the data set would go into. And in order to do that type of benchmarking, it seems like you need to have access to multi-GPU to see if something falls into that regime. Do you know good ways to do that without having access to multi-GPU, or easy ways to temporarily have access to multi-GPU, or any ways to kind of look at what's going to be running and get a sense of which regime it may fall into without just testing it?
Yeah, that's a great question. So, for everyone heard, I don't have to repeat it, but how do you know which regime you're going to be in before? And that's kind of the point of studies like this, and it's kind of also what I want to do as part of my doctoral program. So I am in an aerospace engineering program, but I'm not, flying planes or designing, looking at airfoils. I'm really interested in bridging my knowledge with computation and science in order to solve problems. And one of them is, where should these problems be run, right? So it's trying to answer exactly that. So having some kind of, prescriptively, some kind of model that tells us, the kinds of problems that I'm interested in, should they be solved multi-GPU? Is it worth the investment, right? Is the, lemon, what's the expression? Is the juice worth the squeeze? Yes. Thank you. Is it worth it, right? Or can everything be done single GPU? And I think that was very like a naive approach for me to do, a naive attempt to show that on screen, to say there are regimes, there are different places, right, that exist in terms of the problems, the size of the problem that you're trying to capture. But I hope that that's something that can be studied more, especially industry-specific too. Aerospace is working on different problems. Pharmaceuticals are working on different problems. Biology, protein folding, they do GPU computation as well, right? They're going to have their own optimizations, things that are very, domain-specific, that will let them do that and answer that question for each industry themselves. So I hope that answers that. Cool. Yes, question.
Oh, I was just curious how fluid dynamics affected nuclear fusion, because I was working on that. So.
Oh, cool. Yeah. It's as you can imagine, it's complex. So when you are, I gave two examples, right? I gave you asked about nuclear fusion.
Yeah.
Right. So there are two paradigms in the nuclear fusion world, which is magnetic confinement of plasmas, right, to create in fusion environments, and there's also inertial confinement. I think Lawrence Livermore is working on, they're the ones who have the most recent results with inertial confinement fusion, and also ITER in France. There's a small town in France called Cadarache, and they have a huge facility that's almost like CERN, but for the nuclear fusion world. And they do magnetic confinement fusion. But they're modeling multiple species of fluid, right? So they have regular gases that get heated, right? When gases get heated, they break down, ionize, and then also form plasmas. And plasmas actually have a different set of physics that regulate them, that are different than traditional classical fluids, right? So that's basically it. Yeah. When you have that interplay between those different fluids, that must be modeled. And if you have a more accurate depiction of how that is modeled in real life, in 3 dimensions, and also in the 4th dimension, which is time, right? How that happens in time, right? You can more accurately make predictions. You can actively, make mitigations for things that could go wrong. So the more simulations you do, the more information you can get. I hope I answered that. Cool. Yes?
I was wondering if you would happen to have more benchmark data on, in particular, like CPU vector instructions, aka AVX or SIMD, etc.
I think you're talking about like architecture-specific things, or what do you mean?
So CPUs, I guess newer and newer CPUs have more and more accelerator that are like ECA's GPU, I guess.
Yes.
And I was wondering if you would happen to also have benchmarked those for if you optimize like a Python program for those as well as for GPUs and stuff.
Yeah, negative. No, I don't have that for CPU code. If that is something that you're interested in, check out Numba. I think Numba is a very good way of using like those just-in-time decorators to something like Python and Numba are very good for that, because if you're interested in device-specific CPU acceleration, they're very good, and that's their niche, that's their focus. So I don't know more than that. Yes.
One of the things that got me into CUDA was watching YouTube, and I saw this YouTube video about it was a simulation run in CUDA for the Chernobyl reactor when it exploded.
Okay.
I was wondering if you have ever run any like physics simulations on CUDA, given that that's one of its uses or main uses right now.
Me personally?
Yeah.
I have not, but that's the goal of my research. Yeah. So I need to dive in and do more strictly CUDA stuff, just so I can kind of get more on board and understand, you know, what kind of optimizations I can make for, because I've done regular programming for simulations for CFD, for computational fluid dynamics, but I've never done it on GPU that's device specific until now. So.
So the graph you were showing earlier about the different regimes between CPU, single GPU, and multi-GPU.
Yep.
You're only showing showing the time spent with either one GPU or two GPUs. Is there, if you're trying to extend that further to even more GPUs, is there like a 2 GPU, 3 GPU regime, and so on and so forth? Or at the multi-GPU regime, is it at the point where you could just put as many GPUs as you could reasonably put into a single system and have it improve the performance?
Yeah, this goes back to PyTorch, also in the AI ML world, right? If you're able to provide additional things that CUDA can see, you can definitely use more GPUs to do compute, and you know, you can get results faster, right? With the example that I gave here, I showed it for 2 GPUs. If you want to have additional ones, I think there was already a question that was posed by one of these gentlemen too, asking, would that speed things up, right? Would it, because it looked like there was like a 2x you know, improvement in solution time. So if you throw more GPUs at it, can you do it faster? And I think, yes, you can, but right, you have to make additional considerations of, can my code do that, right? Your code has to be able to do that. Did I answer your question, or did I go off on a tangent? Might have gone on a tangent. Okay. What was unclear? Or what did I miss?
Or is there like a 2 GPU regime where like adding additional GPUs wouldn't help?
Very good question.
Yeah.
Very good question. I just need to do this again and just do it for a more than 2 GPU case. But then I would have to then take the same code and actually program it for the 2 GPU case, which it already is, 4 GPU case, the 8 GPU case, and so on. Because currently it's set in stone. The reason I mentioned PyTorch earlier is that does it seamlessly because their libraries that they've written to handle that has already been coded, because they have teams of programmers that they pay up the wazoo to do that. So, but yes, in theory, it can be done, and I would imagine, to answer your question, that you would have additional regimes, perhaps. Yeah. Especially for more complicated problems, too. This is a very simple 2D small problem. Larger problems, yes. Okay, we are at time. I want to be respectful of everyone else's time and also just say, where's my thank you slide? Thanks everyone for coming. Thank you so much. If you guys have more questions, I'll just stick around and I'll just kind of I used the word apparition earlier, I'll just kind of drift. But see you at game night. Come to game night, and there's also going to be a bunch of folks doing rummy. Does anyone here play rummy? Yeah, okay, we got some people. All right. There are going to be lots of games, so go play. Yeah, go have fun. Go have fun. Thanks everyone for coming. Yeah, absolutely. I probably do.
So just as a heads up,
Okay.
Triton
Yeah.
is CUDA based.
Oh, is it? Okay,
So
okay.
the
Oh, sorry. I should give this back to you. Thank you so much.